Welcome to this year's Data Octagon, coming straight to you from Data Innovation Summit 2020. I'm your host, Robert Luciani, and we have an action-packed schedule for you guys, filled with people from all over the world. This year has really been a strange year. We have had COVID, we're not seeing each other face to face, but it hasn't really stopped the progress of technology. We've seen new machine learning models come forward, we've seen new product launches from all the big name vendors, and we've seen a lot of innovation from startups that are really getting their niche in the startup space. So in terms of machine learning, we've seen GPT-3, we've seen YOLO 4 come out, we've seen lots of progress in NLP, lots of progress in graph neural networks, lots of progress across all the disciplines of machine learning, and at the same time, the infrastructure that's being propped up to support this machine learning stuff is also making progress, making it easier to put processes into place to prepare the data on the way in and to host the models and the data that's supposed to come on the other side. And many of the panelists that we're going to be seeing in the next 2 days are going to be talking precisely about that, sharing with you their experience on what works and what doesn't work. And moreover, to touch on the human element of things, again, top of mind this year is the ethics and the people centricity of machine learning, what it means to have explainable models and all that kind of thing. So now we have 2,000 delegates attending from 700 companies and nearly 50 countries represented. We have 300 sessions, 8 stages, and 70 technologies for you guys to go through. Now, what's coming up next here in the Octagon? We will have the keynote presentation live on this channel very soon. After that, we will be having interactive panels with some of the most advanced and innovative technology and service companies in the world. We will be having tech news sessions where I will be talking with panelists one-on-one to get a little bit more of a deep dive into some of the technologies that you might recognize and some that you might not. And we will also have interviews with some of the speakers from the summit with our Read editorial director, Ivana Kotorcevic. So stay tuned. Today's program will end at 18 CET, and we will be back tomorrow at 8:30 to 15:30. You can follow us here on our YouTube channel or on Twitter. The links you will find below, and don't forget to send us your questions here on your YouTube channel or on Twitter.
Hey everyone, welcome to Data Innovation Summit 2020 and welcome to the decade of data and AI industrialization. This year we are celebrating a 5-year anniversary. Yeah, and we are truly celebrating that we are going from the last decade of pioneering and piloting into a decade of industrializations. So let's stop right here. In the midst of a pandemic, where are we at 5 years in for this conference? If we take the pulse on all our partners or the practitioners, people in the industry, public sector, private sector, what is on top of our agenda this year? What's the theme that we think we should be talking about, all of us, and that you should have in the back of your mind throughout all the presentations you will see this year? So for us, it's clearly that we have come so far now, so that on a strategic level, the importance of data innovation and AI is unmistaken. And just looking at all the different partners we have and we are working on with this year, it's clearly that we have technology. And it's not like if you're the Googles of the world, really super cutting edge, you are looking for more stuff. And in some ways, maybe we are looking for ways to make life simpler and easier and all that. But in reality, technology we have to get started and get moving. So what's the number one thing we should really be dealing with? And what is the one thing we are struggling with? Well, we think it's the how topic. So not the why and the what, but the how topic. So how do we go about to really operationalize data and AI? How do we go about making it part of our daily operations? This how topic is what this going to data and AI industrialization is all about. Now, what is interesting is that this how topic in many ways is a classic middle manager challenge. Yeah? So you have the strategic discussion on the board level. We need to do things, we need to automate, we need to optimize. We have technology discussions or very technical discussions on a very nitty-gritty level, the data scientist, the platform, the data, is it clean? But the challenge we have right now is that how do we orchestrate work? How do we operationalize work? That seems to be where the real blocker is and where we really need to get more focus if we want to accelerate. This middle manager challenge, I actually had in a conversation with one of my clients in the mining industry last year, a quite interesting theme came up. You know, should we do things top down? Should we go bottom up? How do we really drive the how to operationalize things? And then one very smart individual said, we should start talking about middle out. So the real challenge, the real work, the real tricky place to be right now is the middle manager. To take what the strategic direction says and now doing something we have not done before. And especially if you're coming from an organization with a proud analog legacy, you know, how we organize, how we steer, how do we structure the team, how we balance the teams, it's new. So this middle management challenge, the how, what sometimes also we have referred to as the operational vision, it's really key in order to get moving as an enterprise. Now, last year we coined the word data and AI ready, to dare. We need to dare. We need to dare to reach new frontiers. This dare is, in a nutshell, the pursuit of data and AI industrialization and stabilization. So this is really where I think the real challenge is. Now, I want to put this to you that I think this is, that we go on this journey to dare is something that is of societal concern. If we think about the companies that are coming from an analog background, you have produced something, you have physical products, you have physical assets, you have a physical process, that we succeed, that these companies and organizations succeed, is of a societal concern. Why? Because right now we also see a growing data and AI divide in the world. We see it in some few superpowers within data and AI who is really driving, and most of us are playing catch up. Now, where I say this is a societal concern is that I think that it's better if we can reinvent ourselves, our traditional companies, to be part of this new future rather than being disruptive from a powerhouse. So if we can manage to get this journey, to drive the dare journey within our organizations, we will have a better world. We will have a more equal world, we will have a more inclusive world, we will have a more diversified world, and we will have less of the segregated world of the haves and have-nots within data and AI. So for me, this is a real passion. Now, actually, what I'm talking about here is actually, to some degree, the pivot of the decade. This is the real pivot of the decade if you're in this industry. The pivot from piloting and pioneering to become data and AI ready to industrialize and stabilize your ways. And essentially, the vision that I'm talking about when this is stabilized is when we have truly cross-pollinated our business domain or the domain we are in with data, AI, and software. So we are living in a new core. Our organization is a new core where this is functioning as one. Now, let me now share a couple of minutes my personal pivot. You see, I'm one of you. We coined last year, if you went to this conference, Dare Legends. Basically, all of us that is working on this topic to make our organizations data and AI ready. If we are in a coder, if you're a leader, or if you're in the industry supporting this, we are all Dare Legends. And I've been one of those Dare Legends, part of the energy industry for many years. Now, what happened to me was essentially a creeping realization that we need to do things differently. A creeping realization that piece by piece, by working on it, that what we are doing in our enterprises or in our organizations in the public sector, in the private sector, compared to what we should be doing, it's a mind shift. It's a fundamental shift. Now, with this creeping realization, actually it led me to quit my job. I found my why. What am I good at? What I believe in? What am I passionate about? What is something that I think is actually really important for society, but that I also can make a living around? So basically to work on these topics is my true passion. Now, what I thought I'd like to do now, I would like to share you some of those key realizations, how I sort of started to feel about the data and AI divide, what we were doing compared to what we should be doing. And ultimately how this has led us moving forward on how to tackle this. So this, my personal why, I started sharing and discussing with a lot of you in this room, with my peers. And a lot of those things resonated with several of you. So we have now a growing community where we're trying to figure this out together. But these realizations, let me take them. All right, so let's dig into these realizations. What are the real realization, what the data and AI divide is all about, that really drives us that we need to be there? The first one, let's start with the wow factor. And with wow, I refer to ways of working. So the way of working, the way we go about organizing stuff, orchestrating work is fundamentally different. And it starts already with a mindset around analog first, and we put data and AI on top. It goes around how we view process static. We have line organization versus project. We are application centric. So it goes on how we are running the world based on how we knew it from before. If I contrast this with the sort of data and AI powerhouses, it doesn't work like this. They start with the data and AI first mindset. So the product, the technology, the algorithms is an ingrained part of how they're thinking about the process or service or product. Multidisciplinary teams. We are not so worried about, application standards anymore. We are worried about data standards, coding standards, design patterns. So the whole idea of how we view technology is also different. This was the first one. The second one, we need to own it. The ownership topic, owning the problem, owning how we do things, how we work, owning data information ownership, algorithm ownership, ownership over our design patterns. So on all different perspectives, in the traditional enterprise or organization, public or private, this is a real hurdle today, that we haven't really figured out how we will work together when we are dealing with multidisciplinary setups. Also, it's around owning the fundamental data literacy, owning the business problem and how to translate that into a data problem. And it's about owning, that we need to, in the business side, own up to taking care of our data and algorithms. Owning the understanding from business to data translation, etc. So this was the second one. Think about ownership. This is a key topic in many ways that is challenging. The third one I want to highlight is that was a journey also for me, that I didn't see this until I got deeper and deeper into it. And it's the fundamental power of community and open source. So all the big data AI powerhouses has grown up with a strong open source frameworks, communities around that, and been developing communities within their organizations. In reality, you don't start developing a deep learning algorithm from scratch today. You tap into some frameworks, some open source frameworks, whether they're coming from vendors or they're completely open source. But ultimately, this idea, we need to be much, much better at understanding. And ultimately, I believe this is the true way forward within their enterprise as well. So even if you can't use open source software because it's, you're a regulated organization, open source thinking and how you spread stuff within your organization, how you build communities, how you drive standardization pull through communities. This is key. The Tayloristic approach will not work anymore. We have different experts in multidisciplinary teams we need to figure out within our communities. We need to get out of tribal knowledge and into community knowledge to drive enterprise knowledge and enterprise value. So let's stop right here and reflect a little bit. Data and AI readiness, data and AI industrialization, the realizations of the data and AI divide. So why do we really need to care? Why is it that me together with a lot of my peers thinks this is the only way? Well, let me highlight that there are some underlying drivers, some underpinning factors that actually makes all this, to dare the only way forward. There are some internal drivers, and we talked about it quite extensively last year. In my opening keynote, I highlighted the idea of intersectional innovation. This is what we're doing. You have a domain and you're cross-pollinating with data and AI capabilities. You're creating a new core. Intersectional, you're living in the intersect. Perpetual innovation. We will drip feed data and AI algorithms and new technologies for the foreseeable future. It's not going to be the flick of a switch and then we are AI ready. It's a drip feeding exercise, and simply because that's the only way we can cope with the change. Yeah, perpetual innovation, we call this. We're going into a continuous cycle. Process becomes product. Business ops, data ops, DevOps. Development and operations as one. And then the last topic we talked about last year was the enterprise dare dilemma. How do we balance the focus on use case level where the real value actually is created as operational value and putting use cases in production versus the enterprise perspective? How do we balance that? This is the enterprise dare dilemma. So this was the internal drivers. What I put to you now is I want to highlight some key external drivers. So we will live in a world with distributed data. Okay, the more sensors and IoT we use, data becomes distributed. We come more and more into the conversation about edge versus cloud or the central parts. And this is fed, of course, by the emerging ecosystems. So in different industries or in the public sector, there becomes data and AI ecosystems. Energy system ecosystem, transport ecosystem, intelligent water ecosystem, sustainable city ecosystem, transport ecosystem, you name it. So there will be an ecosystem of players where data need to flow. So we need to have this idea of how we work in communities and open source. We need to have this understanding that the siloed approach will not work. The proprietary approach will not work. And then I move on and we can talk about fundamentals such as the network economy, the gig economy, and moving all the way into the talent war. How people will work, how we will be organized, how teams will come and go, but experts need to come in and out. It's changing, and all this is essentially fitting more to the setups of the powerhouses compared to the more traditional Tayloristic management. So that's why, in my opinion, we all need to dare. We need to dare to move forward. What I would like to do now, I would like to give you a hint on some key principles to get started. I put to you that this journey is actually not difficult, but it's damn hard. In reality, the key takeaway, what we have found out, is that you simply need to get started. And then you need to learn by doing and stabilize by doing. Now, so we have now, within the Airplane Alliance, this is a community, we are co-creating, having an open source philosophy on these ways of working. So we came up with some core principles that is sort of guiding us, and I think it should be guiding you how to think to get started in the right way, but eventually it's your own journey. Let me take these principles for you. Okay, so DARE principle number 1. You need to focus to build your DARE engine rather than projects. And this engine should be focused on a use case lifecycle, because it's at the use case lifecycle that we find the core operational value. And it's here we need to have the orchestration of a multidisciplinary team happening. Now, principle number 2, your DARE engine must be balanced. It must be balanced in such a way that you are hitting all the facets needed to go from data to value. So the business dimension, the data dimension, the algorithm dimension, the UX dimension. And the idea here is that if you can have a common artifacts, common lingo, we can come together as a multidisciplinary team, work on the right phases together, but then of course be experts on the different parts. DARE principle number 3. Your DARE engine must encapsulate a learning organization by design. So you need to have the mechanisms to harvest what you have done in one use case, feed it to your community to then reuse it and improve on it in your next use case. This is core of perpetual innovation. And it's core that in this way we can stabilize by using and improving both our technology, but also our structural capital, our way we work, if we harvest and reuse. Now, and DARE principle number 4. Your DARE engine must incorporate federated sharing and learning. You want to use communities as a way to create pull to drive standards. The community drives standards and improves and stabilizes by sharing best practices in this community. So the whole open source approach. And this is truly how you deal with the enterprise DARE dilemma. How you can be operational, use case, autonomous team, but at the same time scale. So please everyone, take these realization, make them your own. Take these DARE principles, make them your own. It's what we believe in working on this. I put to you, have them in the back of your head throughout all the presentations you will see at this summit this year. Are they saying the same things but different words? Are they relating to it in different ways? If you want to know more about this, in the opening keynote tomorrow that I will do, I will share how we in Scania Financial Services have worked on putting these DARE principles in practice on a global scale. And if you want to know more about joining the Airplane Alliance, to be part of an open source community, a peer-to-peer community, I will tell you more about that in a technology in practice session that you can find from Dairdux on Airplane Alliance. So with that, Have a great summit. Thank you.
Our appetite for data has never been bigger, but connecting data across an organization can be a daunting task. As the dynamics of your data change within your organization, so does the complexity you face when trying to deliver value from data at the pace your business requires. All too often, the solution leads to a complex data architecture where you spend more time managing infrastructure at the expense of finding untapped potential within your data. Snowflake allows you to build a modern data architecture with our leading cloud data platform that eliminates the complexity, cost, and constraints inherent with other approaches. Available as a service on leading cloud providers, Snowflake eliminates architectural complexity so you can run many workloads with the elasticity, performance, and scale required by the modern enterprise. What makes Snowflake unique? In one word, architecture. Built entirely from the ground up for the cloud, Snowflake's architecture is comprised of centralized storage for virtually unlimited amounts of structured and semi-structured data, multi-cluster compute for running multiple workloads without resource contention, cloud services to automate common administration, security, and database tasks, and a cloud-agnostic layer to deliver a consistent experience across cloud regions and providers. This unique architecture makes Snowflake applicable to a wide range of workloads, including data engineering by leveraging Snowflake's ability to streamline data ingestion and integration, as a data lake by using Snowflake as your data lake or alongside an existing one, for data warehousing with unlimited performance and concurrency, to streamline data science to simplify and drive performance for complex workloads, for building data-intensive applications that require an analytics workhorse at their core, and streamlined data sharing between consumers and providers. Thousands of companies, including McKesson, Instacart, Square, Caterpillar, and many more, are seeing performance, scale, and productivity gains utilizing the Snowflake Cloud Data Platform. Snowflake has over 1 exabyte of data under management, and hundreds of thousands of users execute hundreds of millions of workloads every day. The next step should be an in-depth conversation with you to help us understand where you would like to go and how Snowflake could enable you to get there.
Tableau Desktop helps you see the stories in your data. It's visual analytics anyone can use. Drag and drop to find trends and outliers. Effortlessly drill into your data and use quick table calcs like running total to see the bigger picture. Connect to the data you care about, whether it's a spreadsheet, database, or big data. Access data warehouses, cloud applications, and cloud databases from a single application. Mix and match from different sources. Tableau brings all your data together in one simple view. Sort, highlight, drill down, or filter your data in seconds. In this view, we can easily spot underperforming products. With Tableau, you can keep on asking questions in the data until you discover the root cause. Change your perspective to discover something new. With a click, the scatter plot transforms into a tree map, highlighting that Western Asia has several unprofitable regions. Use drag and drop forecasts to spot trends, identify opportunities, and ask questions like, will I sell more next year? Add calculations to extend your data. Transform your data into powerful interactive dashboards. then customize them for different devices. Share your analysis securely on Tableau Online or Tableau Server. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau makes analyzing data fast, easy, and beautiful for everyone. It's designed to help you be smarter, so you can make better decisions faster. Tableau. Answer questions at the speed of thought.
Welcome to Data Innovation Summit and to our exhibitor page. We are Teradata, and our mission is to transform how businesses work and people live through the power of data. Teradata leverages all of the data all of the time, so you can analyze anything, deploy anywhere, and deliver analytics that matter most to your business. We call this pervasive data intelligence powered by the cloud. We will be happy to meet you here at the summit and help you to discover how to successfully operationalize your analytics and leverage your data to achieve real business value. So don't miss our sessions. A keynote and technology interview with Martin Willcox, VP Technology EMEA, on the topic of machine learning and the importance of advanced data analytics. Customer session with Wells Fargo, demonstrating how the early adoption of an analytics platform can effectively support the development of a truly data-driven organization. In the Data Octagon panel on the rise of AI in business, our EMEA Data Science Director Chris Hillman will be sharing his view together with other industry leaders. And in the breakout session AI and Game, Chris Hillman will also show how to create an AI vision, keeping an eye on future trends, and how to bring this vision into reality. There are also 2 technology in practice demo talks, one on each event day. And here on our exhibitor page, we have prepared a selection of resources, including the latest white papers and customer stories. For more information on Teradata, our products and solution, you can always refer to our company website, teradata.com. So don't hesitate to contact our reps attending the summit, which are listed below. You will be able to book a meeting with them and our SMEs through the app to further discuss the needs of your organization or to get answer to any question you might have on Teradata. Enjoy your time at the summit, and we hope to talk to many of you directly.
Hi everyone, my name is Martin Willcox. I'm Teradata's Vice President of Technology for EMEA, and today's presentation is entitled Getting Advanced Analytics Out of the Lab and into Production. I think it's instructive to take the long view of digitization because, I think we tend to talk about digitization a bit like our parents and our grandparents talked about sex in the 60s, like we invented it. Only we didn't. The first wave of digitization arguably started in the late 80s and the early 90s with the client-server revolution. During the late 80s and the early 90s, organizations shoveled money at IT like it was going out of fashion. But as Robert Solow famously quipped in 1987 when he wryly observed that you can see the computer age everywhere but in the productivity statistics, at the level of the whole economy, productivity actually decreased over the start of this period. Put simply, organizations were doing IT all wrong. The so-called productivity paradox was not resolved until Michael Hammer and Thomas Davenport and the rest of the business process re-engineering crowd taught the rest of us that effective digitization was not about automating existing business processes. It was about reinventing end-to-end processes to make them more streamlined, more efficient, and more customer-focused. In his seminal 1990 Harvard Business Review essay, Michael Hammer was absolutely explicit. It is time to stop paving the cowpaths, he wrote. Instead of embedding outdated processes in silicon and software, we should obliterate them and start over. Now, probably one of the best examples of an organization that got that first round of digitization absolutely right is Walmart. If Walmart's ambitions for digitization in the 80s and the 90s had been confined to just deploying electronic point of sales to shorten the lines at checkouts, Walmart would not be the power in retail that it is today. Instead, Walmart combined sales, inventory, and order data to create a demand-driven supply chain that both dramatically reduced the amount of capital invested in inventory and improved on-shelf availability. In that way, Walmart was able not just to maximize sales in existing locations, but also to simultaneously free up large amounts of capital that were invested in lower prices and more and bigger stores in more locations, thus fueling a virtuous circle. That transformation was powered by data and analytics, and not just by any old data, but rather by lots of detailed data integrated across functional and departmental boundaries and shared with suppliers. So much for the recent past. What about the present and the near future? Well, you won't need me to tell you that there is off-the-charts hype about the potential of machine learning and AI right now. And cutting through that hype can be tough. So if you haven't read it already, I highly recommend the book Prediction Machines. Like Solow, the authors are economists, and that's the lens that they bring to this discussion. But they also ran the Creative Destruction Lab, a program that arguably fostered more AI startups than any other. And so they have a keen sense of what actually works in practice. Their central argument in Prediction Machines is that most of what we today call AI is really supervised machine learning aimed at predicting events and outcomes, and that the real meaning of recent advances in technology is ultimately that the cost of making predictions is falling steeply, even as the quality and the utility of those predictions improves. As they put it themselves, cheap changes everything, and cheap means everywhere. Hence, machine learning and AI will really become ubiquitous. They also point out that economic theory also tells us that when an input like prediction becomes cheap, the value of complementary goods increases. The chief complement to prediction are the data that we use to feed the algorithms that do the predicting. So data becomes exponentially more valuable even as the unit cost of prediction falls. When writing about the recent Google Citibank deal, Robert Armstrong in the FT argued that fundamentally, a bank is a balance sheet, a data processing system, and a sales force. Personally, I doubt that Google is much interested in the Citi balance sheet and all of the regulatory baggage that comes with it. But I can absolutely understand the value to Google and to Google's business model of the customer behavioral data that is locked up in Citi's data processing systems. Now, whilst there may be off-the-charts hype about AI and machine learning right now, as Erik Brynjolfsson, among others, has pointed out, the parallels with the late 80s are striking. Once again, organizations are shoveling money at IT, this time at machine learning and artificial intelligence initiatives housed in swanky innovation labs. Check the shiny espresso machine count. If it's higher than 4 per floor, probably you've stumbled into the lab. And once again, productivity growth in the OECD countries is underwhelming, even before the impact of the COVID-19 pandemic has worked its way through the wider economy. Brynjolfsson, another super smart guy, and not coincidentally another economist, argues that like the steam engine, electricity, the internal combustion engine, and computing before it, artificial intelligence and machine learning technologies really are general purpose technologies that will ultimately transform the economy. But that the benefits of the application of the technology are not yet evenly distributed. In Brynjolfsson's model, implementation lags are slowing both the adoption and, probably more importantly, the successful exploitation of the technology. And interestingly, one of the specific lags that Brynjolfsson calls out is developing datasets. Now, I would argue that you don't have to look very far or very wide to find multiple data points that support Brynjolfsson's assertion. I've put 6 of my personal favourites on this slide. As data scientists and machine learning engineers, we've established a way of working based on the creation of pipelines, typically end-to-end processes designed and built to solve a specific problem on a project-by-project basis. Most of the time, that pipeline starts with code for feature engineering. And for small-scale developments, for testing and for science projects, this is a good approach because it's both efficient and it ensures repeatability. Now, ensuring that the same result can be consistently and reliably reproduced whenever an experiment or an analysis is undertaken is, of course, a key consideration in research and increasingly in the regulated industries. And in this model, repeatability is generally achieved by storing the code for the machine learning pipeline in a versioning repository like Git or SVN. However, scaling this approach to an enterprise level very quickly leads to a very inefficient one pipeline per machine learning model approach that results in the creation of silos of data and processes. In particular, because the processes are stored as code that are often indecipherable to everyone except the original author, the pipelines are brittle and resistant to change. Worse yet, the majority of the data and features used to train and score these models have already been captured, cleansed, and transformed somewhere else in the organization. So the natural outcome of this way of working is the creation of multiple, redundant, overlapping, and inconsistent data silos, and the rapid accumulation of technical debt in the form of multiple, redundant, overlapping data wrangling processes to feed and maintain those data silos. Google themselves describe the outcome of this way of working as pipeline jungles, and note that data dependencies are one of the key contributors to technical debt in machine learning systems. Now, in general, there's no return on investment in technology until we deploy in production and change the way we do business. And Gartner's research indicates that at least 65% of the predictive models built in organizations today are never implemented in production. For all of the caffeine-driven work done in all of those innovation labs, much of it brilliant, by the way, most of the insight that is generated never leaves the lab except as PowerPoint. And since you can't connect a slide deck to an operational business process, mostly we are not changing the way we are doing business, and so we're never likely to generate any positive ROI. As a former boss of mine once commented when rejecting one of my less well thought through project proposals 20 odd years ago, old business process plus expensive new technology equals expensive old business process. Which, when you really think about it, is pretty much what Michael Hammer's argument was 30 odd years ago. In short, I think that as an industry, we have over-rotated on algorithms and model training because it's easy to get started that way and feel like we're accomplishing something. Because it's the sexy bit that allows us to get in touch with our inner geek. Because it means that we can go and play with some of the amazing new technologies that we've been given these last few years. Because it's fun to debate the relative merits of ridge regression, support vector machines, and random forest for a particular use case. Unfortunately, what that means is that in many organizations and companies, we've lost sight of our ultimate objective and lost sight of the overarching set of capabilities that we need to achieve that objective. It means that most of us are stuck in the innovation lab. Let me give you just a couple of anecdotes from recent discussions that I've had with senior stakeholders in large EMEA companies. I spoke to the CIO of a big EMEA bank recently. He has an AI lab stuffed full of what I think is genuinely top-tier talent. His team have built 25 predictive models in the last 24 months that are sufficiently accurate to have a significant impact on the way that the bank does business. And he has been able to implement in production exactly 2 of those 25 predictive models. I spoke to the CDO of a big EMEA telco just before I went on summer vacation. He described his 3 biggest challenges to me as time to market for new analytics, reusability at scale, and technical debt. It takes his team months to get access to the data that they need, months more to wrangle it into some kind of shape. And when they've cleared those hurdles, the tools that they're using to train models in the innovation lab will not scale. So those models have to be re-implemented before they can be deployed in production. By his own admission, he is currently creating silos faster than he's creating value. I think we need to think differently about advanced analytics, to stop paving some of our own cow paths, if you will, and to use Michael Hammer's language. My coaching to business leaders is that they should start to think in terms of machine learning 1, 2, 3. 1 is for data preparation and management. Data wrangling still accounts for up to 80% of the cost and effort of analytic projects. If machine learning really is to become ubiquitous, we need to bring very significant pressure to bear on that number. And that means that we need to stop handcrafting one data per pipeline machine learning processes and to focus instead on enabling reuse by investing in curated feature stores of variables with proven predictive value. Number 3 is for deployment and operationalization. There are several different analytic operationalization design patterns that make more or less sense depending on the use case. But in very many cases, scoring predictive models in production and at scale requires us to performantly process multiple features and to ship the result, typically a prediction or a next best action, to a connected operational touchpoint, often in near real time. A feature store built on a high-performance enterprise-grade parallel data warehouse platform gives us scale, performance, high availability and reliability, channel integration. And of course, it also gives us rapid access to all of the variables in the feature store. And even where this design pattern doesn't make sense, for example, where performance or network considerations mean that we need to score models at the edge, we still need to instrument those models to understand where they have been deployed and the predictions that they're making. Because predictive models, particularly in adversarial circumstances, have a shelf life and need to be maintained, updated, and ultimately retired. Making those decisions is also a data problem. Number 2 is for model training, and I come to it deliberately last. For the foreseeable future, I think that most big organizations are probably going to need to use multiple different technologies to support their model building activities. The reality is there isn't really one tool to rule them all right now, and probably there never will be, even if the smart money is on some level of consolidation in the marketplace over the course of the next couple of years. But where you are deploying multiple technologies to train models, you should insist that those technologies pull data from the feature store, that any new features, model-specific features, are added back to the feature store, and that models are published in a format that mean that they can be consumed and run on your centralized and integrated data platform or on an edge node as appropriate. No exceptions. None. Let's briefly drill into one of the emerging best practices around analytic data preparation, the use of an enterprise feature store. As we've already discussed, a one pipeline per process approach results in data silos and rapidly accumulated technical debt. Can we do better? The short answer is yes. We increasingly encourage the customers that we work with to curate variables with known predictive value in a feature store to enable their reuse for training and scoring of other models in the same or adjacent domains. It's important to understand that the use of a feature store often doesn't spare us the creation of a model-specific analytic dataset. It's still often necessary and important to apply model-specific customizations to existing variables like PCA or scaling. But by applying those customizations to a curated set of features relevant to use cases across the enterprise, in telco we might be thinking about things like last 5 events before churn and contract end date or 7-day moving average of data used, by applying those customizations to curated sets of features, instead of going all the way back to source systems or the data lake and rebuilding those same features from scratch, leading organizations are dramatically improving time to market for analytics and dramatically improving data scientist productivity. Anecdotally, those organizations also tell us that they improve model quality that way, because the very act of curating features for reuse encourages the team to make sure that they are building the right features. And their frequent reuse means that any issues are discovered more quickly than would otherwise be the case, ensuring that the features have also been built right. Now, a central part of my argument in this presentation is that we've been too concerned with model training at the expense of other less glamorous but no less important parts of the machine learning lifecycle. My argument is not that model training doesn't matter, more that we need to stop treating it like it's the only thing that matters. Given all of that, I probably shouldn't spend too much time today talking about model training myself. So let me just say this. If machine learning is really going to be ubiquitous, then it had better scale. And I mean really scale. As one example, we work with one of the leading mobile telcos in the world who have probably the lowest churn in the industry. They regard their churn and propensity models as core IP that is central to their competitive advantage. When they're training new champion challenger models, they typically train them on more than 1 million observations, and they typically score them on the entire adult population of the US, so over 200 million observations. I would argue that that's a great example of Google's unreasonable effectiveness of data principle, of a relatively simple machine learning model trained on a large number of observations, outperforming more complex models trained on fewer observations. We often refer to that as vertical scaling of machine learning. By the way, the telco concerned wants to be able to run multiple champion-challenger model cycles per day. So they demand a runtime of less than 30 minutes for each training and scoring cycle. Don't try that at this scale on a laptop running RStudio. So much for vertical scaling. There are a whole group of use cases that we often refer to as hypersegmentation use cases where a different approach is increasingly best practice. If we want to predict remote account takeover fraud in retail finance, for example, then we essentially are comparing a current online behavior with a model of previous online behavior and creating a similarity score in near real time. And since that behavior is very personal, those models need to be personal too. That typically means one model per customer. In grocery retail, the best practice in demand forecasting is increasingly to predict demand at the store SKU level. Remember, it was demand forecasting and mastery of demand-driven supply chains that arguably enabled Walmart to dominate retail in the 90s. Now, if you want to do demand forecasting at the store SKU level, then even on fairly conservative maths, it follows that within the next few years, typical national European grocery retailers are going to need to score 150 million predictive models in production on at least a daily basis just to run a competitive supply chain. Each one of those models is only going to be trained on between a couple of hundred, couple of thousand observations, but that still adds up to an awful lot of model training and an awful lot of model scoring. And we call that horizontal scaling of machine learning. So when you're evaluating analytic technologies, remember that there's no return on investment until you're in production, that production means deployment at scale, and that you need to be able to support both vertical and horizontal scaling to get there. Now, if you have deployed or are deploying a data warehouse on a scalable high-performance platform, then that's often a very logical place to build your feature store. It's where the data are, after all. By the same logic, it's often a very logical place for Teradata customers to score their models in production. Teradata is a high-performance parallel platform. It's where the data are. It has robust mission-critical mixed workload management so that mission-critical scoring workloads with tight SLAs can coexist on the same platform as more complex data transformation and model training processes. And it's already connected to many of the operational touchpoints and processes where we need to make the predictions available. There are broadly 3 different approaches to enable model scoring on a Teradata data warehouse. We can use open source libraries to convert linear models to SQL. We can exploit our in-DBMS R and Python capabilities to score models built in R and Python directly, an approach that works really well for embarrassingly parallel tasks like scoring. And we can consume PMML models. So models built in an alternative technology that can export those model definitions as PMML, we can accelerate those using our IVSM accelerator framework, which, by the way, will become part of our supported product later this year. Scoring models in production on the data warehouse can enable radical architectural simplification, provide high performance at scale, and can dramatically reduce TCO. And there are 3 nice examples on this slide. Now, this is a keynote presentation and not a sales pitch, but I would like to briefly give those of you that don't yet work with Teradata a sense of why we continue to be central to the data and analytics strategies of many of the largest and most analytically sophisticated customers in the world. Teradata was the industry's first commercial implementation of the massively parallel processing model, and we won the argument that scale-out architectures are a better fit for large-scale analytic data processing. And today, more than 4 decades after the company was formed, and when essentially all of the leading analytic vendors have implemented some form of MPP architecture of their own, you might be forgiven for wondering if Teradata continues to be differentiated. In fact, Teradata is significantly different from those other implementations, different all the way down to the file system. And those differences drive important benefits for our customers. Teradata was designed from the ground up for always parallel all the time execution. Other implementations parallelize the simple operations and prematurely serialize the more complex operations, limiting performance and scalability. That's the basis of our ability to support complex data transformation processing at scale and vertical scaling of machine learning at scale. In addition, Teradata is just about unique in the industry in using a logical hash-based file system that not only maximizes parallel efficiency, but that also provides O1 access to individual observations. And that's the basis of our ability to support the extreme horizontal scoring of workloads that characterize horizontal scaling use cases. You can think of Teradata essentially as just basically one giant hash table. On top of all of that, Teradata has the industry's leading mixed workload management. That means that Teradata customers can support mission-critical near real-time scoring workloads on the same platform and against the same dataset as complex model training workloads. It also means that they can deploy data labs on the same production as platform and segment those use cases. You basically create workload partitions that mean that those workloads will not interfere with production workloads. So much for, I guess, what you might call the parallel data foundation. What have we done for the data science community lately? Well, we've introduced advanced functions, path graph, time series functions, among others, that make the creation of complex features much simpler. We've doubled down on our in-database R and Python support. We've made it easier to import models trained on other technologies so that they can be scored in database on Teradata. And we've developed a comprehensive analytic ops accelerator framework to support model deployment and model management at scale. In short, we enable machine learning 1, 2, 3 for our customers in production and at scale. In summary then, machine learning and AI really will be ubiquitous and the basis of competitive advantage in many industries, but only when we're able to deploy them at scale and address the implementation lags. Today's approaches are very often associated with poor time to market, poor productivity, and unacceptable failure rates. And addressing those challenges requires us to think differently about machine learning and AI. In particular, we need to understand that this is first and foremost a data problem, that it's the data that feed the algorithms that are the chief source of competitive differentiation, and that data reuse is critical to successful deployment at scale. In short, only the organizations that think about machine learning and artificial intelligence in terms of analytics 1, 2, 3, with a heavy emphasis on 1 and 3, are going to make the cut. All the rest of us are doing is boosting the profits of the espresso machine makers. It's been my great pleasure to be with you today. I've always really enjoyed my time at the Data Innovation Summit. I'm so sorry I can't be with you in person this year. Hopefully we can all get back together in face-to-face events and conferences soon. And in the meantime, enjoy the rest of your virtual DIS conference. Thank you very much.
Trifacta empowers everyone to prepare messy and diverse data faster. It's a data preparation platform built for the speed of modern business. Start with a flow where the elements of your data preparation project are managed. Add new data to a flow by connecting to a source or dropping in a file. Trifacta presents your data visually for intuitive exploration. Easily spot patterns or data quality issues that may need to be addressed. Preparing data in Trifacta is interactive. Immediately see how a potential transformation will impact your data to ensure you're making the right choice. In this case, we've standardized a date format. With each interaction, Trifacta offers an intelligent suggestion to guide you on how best to clean and structure your data. Use the toolbar to kick off common tasks, such as joining two datasets. Trifacta guides you to select the right common keys and how best to execute the join. All of these transformations are automatically tracked as part of your recipe. When you're finished, click Run Job. Schedule workflows to run on a regular basis for repeated production use. Publish your output to any file format, database, or application for broader use. With Trifacta, you can bring together more data faster, whether you need to prepare data for analytics, machine learning, or standard reporting. So, what data do you need to wrangle? Get started with Trifacta today.
Hello, everybody. It is an absolute privilege and a pleasure to be here with all of you today. It's an honor to be able to keynote at this event. Honestly, I really hoped I could have been with you at the event altogether, but unfortunately, times being what they are, it's not going to happen this year. I have to say it's the first time in 3 years that I don't come to an event in Sweden, so I do miss all of you guys, and I really wish that I could physically be there with you. But enough about the introduction, and today I wanted to talk about data literacy, and you'll understand a little bit more about how this topic is probably at the core of everything that we need to do in order to start to benefit from data within our organizations. But before going a little too deep into the topic, I wanted to introduce my organization. And I thought that instead of boring you with a 3-minute speech and me talking about what we do and what we don't do and how we do it and how great we are, I'd let a little video do the talking for me. Have the creative minds behind Ubisoft share with you a little bit about who we are. Better than what I could have done, of course. And honestly, every time I watch this video, I'm blown away by how large, complex, and magnificent the company I work for really is. That being said, you've seen it. It's better than what I could do in terms of introduction. But can you imagine how much fun I have working in an organization that deals with video games? Just think of the volume, the depth, and the breadth of the data that we produce and generate every single day with every single game. It's kind of like the dream of any data geek, and I'm very comfortable with qualifying myself as a geek. So enough with my company. I'm not going to walk you through an entire pedigree of myself. You have the little booklet. If you're curious, you can always hit me up. We can talk. But just to give you a little bit of background, as you know, I'm the head of enterprise data and business intelligence for Ubisoft, and I do teach data and analytics at university. But what really matters is the fun stuff behind all of this, and it's my family that supports me in all of my craziness, my passion for triathlons, which, by the way, I get to share with my eldest, which you can see in the middle over here, winning his triathlon, motorcycles, 2 wheels, boxing, all the fun stuff. But ultimately, I'm just lucky to be able to have this wonderful family that supports me in all of my craziness. And I do have a very special little young boy, which is over here with his little crazy smile and the blue shirt in the middle on the podium, but as you can see, he also hides behind the mask of Darth Vader, convinced that Darth Vader is his one and true friend. Cute, yes. Scary, a little. But to get into the meat of our subject, every single conference I've attended in the last few years has always spoken about the importance of artificial intelligence, about how everyone is spending money on artificial intelligence. Hey, everybody's doing it, so that means we must be all doing it too. If we're not, we're falling behind. I mean, it's the new oil, right? No, sorry. I heard that it's not the new oil anymore. It's the new fire. It's going to revolutionize our lives. So start spending money on AI, of course. And I'm sure that every one of us does, or every one of us wants to. I mean, I remember attending a conference for retailers not too long ago, just about a year and a half to 2 years ago. And every single vendor on the shop floor had the word AI in their name or in their slogan. And I guess we're all pretty much advanced, we're going down that path. We're all investing in AI after all. If you look at the statistics, spending in AI and in big data has increased year over year, 40% year over year for the last 3 years. More than that, just so you know, the spending on artificial intelligence is expected to hit $98 billion by 2023. That's a lot of billions of dollars. I think it's amazing. And we all know it. The value that can be delivered via artificial intelligence is massive for our partners, for our clients, in the healthcare industry, in the financials industry, in the gaming industry, in all of our industries. Except that honestly, it's really not all roses and butterflies. In fact, it seems that less than 15% of data science and AI projects ever make it into production. If anybody has a calculator and wants to figure out what's 87% of 98 billions, well, it's too many billions if you want my opinion. But that's not where it ends. And it's not because our data scientists aren't brilliant individuals. It seems like the problem is deeper rooted and lies in the fact that companies and people have a real hard time adopting and trusting AI solutions. In fact, 77% of businesses report that business adoption of big data and AI initiatives continues to be a huge challenge for companies. And with the amount of money we spend on, I think I can think of saying is ouch. And doesn't even end here, guys. I mean, it just keeps going. 80% of analytics insights won't deliver any business outcome. I'm shocked. I remember hearing people from Gartner saying that the majority of AI projects are going to remain alchemy run by wizards. Like, why? What is the problem? What's causing all of this distrust and non-adoption and lack of value from AI? It's actually quite simple. The fact is that we don't have enough data literate people within our organizations. It was said that by 2020, more than half of the companies won't have enough AI and data literate people to deliver business value. Well, guess what? We're in 2020. I agree. Prediction, pretty much bang on. If we're spending $98 billion in a couple of years on AI and 87% of it doesn't deliver value, you can, bet your paycheck that it's in fact due to people that don't understand how to use data, how to read it, and how to embed it within their business processes. After all, according to CDOs worldwide, the second biggest internal blocker to success, as it relates to data, of course, is how poor data literacy is in our companies. How can we expect to spend all of that money, all those tens of billions in AI and in data science, when most of the people that we employ within our organizations don't even have the basic rudimentary blocks of data literacy? How can we expect to garner success when we don't put in place the basic programs needed to educate our people on what this data will do for them, how to use it, how to leverage it, and how to run our operations based off of it? I mean, it's a pretty rampant problem, and it's all over our organizations. I'm not even sure you guys realize, but did you know that less than 25% of decision makers are actually data literate? It's a bit better as it relates to our execs, but that's still less than a third of our execs that would qualify themselves as being data literate. So if we're going to spend their money, we might as well spend it on something they understand and they know will deliver value, because they know how to make it deliver the value. But then what is data literacy? Why is it so important? Well, that's actually a pretty good question, and that's why I'm here today, so good timing. There are very detailed definitions of what data literacy is, and this is honestly as good a definition as any, and if you Google it, you'll find a million others, and I didn't invent this definition myself. Ultimately, data literacy is our ability to derive information from data, just as literacy is the ability to derive information from written words. For me, it actually came together a few years ago, actually, and I share that story with everyone when I talk about data literacy. So if some of you have seen me before, you may have heard it, but I remember a few years back, I was, putting my eldest to bed, and he was reading his book like for the first time pretty much, and he was just going through some of the words, and I was laying in bed with him and just reading it, and he was sounding out the letters into words, and at some point he just turned his head, looked at me, and he said, "Dad, the letters are making pictures, and I can see the story in my head." And I was like, damn, that makes a lot of sense. That makes a lot of sense. And that's what data literacy is to me as well. It is seeing that data that may mean absolutely nothing to anybody, but garnering and deriving information from it, being able to see the data, being able to see it tell us a story coming to life and explaining things that we just did not know before. Yes, it means that you have to use some statistics and you have to understand some math concepts, etc., etc. But that's not the point. The point is that you look at the data and it is helping you educate your decisions because you know how to read it. And if you don't know how to read it, well, then it's just like me giving you a Shakespeare novel. You're not going to get anything out of it. You're just going to look at the letters and they're going to be mumbo jumbo. You're going to put them aside and you're going to invent your own story. Now, we want data literate people in our organizations. And just so you know, I've listed out what a data literate person is capable of doing. They know what data is needed, when it is needed, and how to apply it in the context of resolving their problems. They know that there are many different types of data that exist, and they know how to connect those different pieces of data in order to transform them into information, mapping those elements together, integrating them so that it can tell us a story. They also understand statistical methods and they know which ones exist to support their analysis. Now, just like in any reality of life, different people will have different levels and different depths of expertise. Now, I'm not expecting everybody to be able to define which clustering method is best used. Should I use a k-means? Should I use a DB scan? What should I be using on this model? That's not what I expect. That's not what we should expect from all of our people. Some, of course. But in general, what we would like to have is that they at least know there are statistical models out there that can help them. They know that there are different methods that can be applied. They know what a clustering problem is. They know what a classification problem is. They know the difference between the two. But again, going at deeper levels, that's where we have advanced analytics people. That's where we have data scientists, etc., etc. They also know how to therefore use all of that data in an effective, visual manner to be able to recount that story they're trying to express and to embed their discoveries, the data elements that they found, and those insights from those data points into their business processes. I almost want to say, most importantly, and for those of you that know me, you've seen a lot of my talks on GDPR and on ethical data usage. Most importantly, it's about leveraging data in an ethical way, respecting the data and respecting the people who share with us their data assets. Don't forget, that data does not belong to you. It belongs to the people who have given it over to you. But it goes further than just GDPR and data governance. It goes with also leveraging data in an ethical manner to make decisions. Because we can twist data. There's a great book, How to Lie with Statistics. But there's also an ethical way of leveraging data in order not to try and twist it to say the story that we want it to say, but rather to tell us the truth. To share a trusted message with our management, with our colleagues, with our employees, etc. After all, data is pretty much at the core of everything that we do. Data is the lifeblood for artificial intelligence, for business intelligence, for corporate strategies, for digital transformation, how we experiment, developing foresight, and literally every other letter in the alphabet is fed via data. And if data is so important, then why don't we teach our people how to leverage it and use it? So how do we go about doing this? Well, it's relatively simple. Okay, it's not that simple, but it's perfectly doable. I've done it before, and others have done it before as well. I'm not inventing anything new here. But if you want to have a quick framework for data literacy, here are some of the things you should focus on. A lot of it is about planning and communication. Of course, you're going to be educating people. But it's also running a gap analysis to know what works, what doesn't work, where we are, and where do we have to go. For me, the most important part of this framework and of building a data literacy program is to understand and realize that there is no one-size-fits-all model in this context. Different places within the organizations, different teams within the organizations, and different people within those teams are going to be at different levels in terms of data lit. And it is your responsibility to tailor the program to make sure that the program that you are delivering, the classes and the trainings are relevant to everybody. And then to measure success and keep going at it. People will forget stuff, but it is your job to. When I talk about tailored programs, here's an example of the ones that I had created not too long ago. A program on descriptive and self-service analytics, one on dashboards and data visualizations, and then a little further deeper for those that were more into the whole data science space, a fundamentals on analytics with introductory sessions on statistical concepts, on data mining tools, on methodologies in terms of the algorithms that are available and how to use them, and of course, as I mentioned, ethics and governance. Now, a lot of companies that I've worked with in the past and worked for in the past, and even myself, to be honest, we spent a lot of time focusing on how to train people on a tool. This is the tool that we use. This is how we do it. This is how we build the report within the tool. You use this tool and everything will be better. Not always the case. I mean, it made them good with a specific piece of software, but if they still don't know how to grab the data and how to embed it and analyze it so that it helps them with their business processes, then what's the point? You've just trained them on a tool, but you haven't taught them how to use the data in order to improve the business. Well, that's why I feel that it's not about software. It's about the people. It's all about the people. They are the truly most incredible appreciating asset that we have in our organizations. And if we invest properly in their education, in teaching them how to leverage data to its fullest, it will be paid back hundredfolds to us. But if you don't focus on helping them understand the beauty of what data can do for them, well then, you're just going to continue spending those $98 billion and get an 87% failure rate, which frankly, I don't think any of us are good with. And that's not what we're here for. We're here to learn about data and we're here to use it to make our companies better. So just to finish this off, I've spent time with those programs. I've had fun building them. And I went out and collected feedback on those different programs. And I can tell you that literally 100% of respondents of the surveys that were sent out after any of the training programs says that their analytical skills improved, that they felt it was relevant, the content was relatable, that it was applicable to their reality, because most importantly, the most effective aspect of a training is when it is tailored, when it is adaptable, and when it is built around the use cases. Hey, some of them even said that they found analytics to be fun and couldn't believe that they found analytics to be fun. Ultimately, what I am trying to tell you is that if data and AI are going to be what makes your company grow and expand in these very, very special times, well then being literate as to how to leverage this data, how to leverage artificial intelligence is really the only way you will survive. Now it's possible. It can be done. I've done it. Others have done it. Just make it fun for your people. So go out and build a data literacy program. I really appreciate your time today. I wish I could be there so that we could go off on a side and continue to discuss this topic. Unfortunately, that is not the case. But please feel free to add me onto LinkedIn if you want to. I am happy to guide you towards resources and materials that I've used. I'm happy to continue the conversation, and it has been an absolute pleasure being with you guys here today and keynoting at this fantastic event. I hope you enjoy the rest of the show. Have a wonderful day.
I work as a data scientist in AstraZeneca, and my team is basically an internal consultancy which we work with in AstraZeneca, and our primary job role is to look at the data, derive insights from it, advise and suggest strategies which will help AstraZeneca invest and also spend smartly. Data and science, they both are at the heart of AstraZeneca, and AstraZeneca, being a scientific company, understands how valuable data is. AstraZeneca has started to apply data science and AI across multiple functions, and our transformation programs are data focused and data science driven. Our data scientists sit very closely with business, and they try to scope and influence the projects, and I think that is the major strength AstraZeneca has in data science and AI.
In my opinion, AstraZeneca is one of the world's most exciting biopharmaceutical companies because in the recent years it has fully embraced artificial intelligence and data science across its R&D and operations. The most exciting part of my job is its impact, because the drug development and discovery process can take a very long time and can be very complex. So AI and data science in particular has the potential impact in reducing this time and complexity, and therefore deliver real impact. The drug development and discovery process involves dealing with enormous amounts of heterogeneous data. Knowledge graphs can help us obtain this data by integrating them together and in supporting us deriving new insights from the graph. What made me choose AstraZeneca was first and foremost its mission. AstraZeneca has a clear mission of delivering life-changing medication to millions of patients every day. Another reason why I chose AstraZeneca was that AstraZeneca continuously reinvents itself, and currently it's investing heavily in expanding its AI and data science capabilities.
AstraZeneca is a great place to do data science and AI because of the volumes of data that we've got, the complexity of data we've got, and the use cases that we have to address here. And we can see that adding value to patients' lives and adding value to the organisation. AstraZeneca's vision for data science and AI stretches across the whole organisation. It's enterprise-wide. It's not siloed. The aim is to break down old silos and to give us insights across the whole of the enterprise. Within AstraZeneca, I can see the future of data science and AI being all about connecting data sets, about taking disparate data sets from across the organisation and bringing them together with powerful data science techniques to provide cutting-edge, innovative insights to accelerate drug discovery, to give us insights about our finance processes, to start predicting behaviours and to start prescribing interventions and outcomes through all of our business processes. I think that AstraZeneca is an appealing place for a data engineer to work, just because of the volume of data we've got, petabytes we're processing regularly, the complexity of the use cases that we've got, the value of the use cases to patients' lives, the technology we're using, we're in the cloud totally, we're a cloud-first organisation. The people that are here, they're clever, they're nice, smart, trusting people, and it's a great team to come and work with.
Hello, my name is Nick Deborah. I'm an independent educator and consultant in the fields of data visualization and dashboard design. And when I do talks at events like the Data Innovation Summit here, I like to start off with a positive message, something that's maybe even a little bit inspirational and uplifting. But I thought, no, in this case, let's just keep it real. Because this is reality. Most dashboards fail to meet organizations' and users' expectations, traditionally very low levels of user satisfaction. And indeed, within virtually all of the organizations with which I work, users complain that dashboards have too much information on them, or not enough information on them. They're either missing information that they need, or they just don't look cool enough. And then on the other hand, you have developers who are complaining that users don't even know what they want, or they ask for ridiculous amounts of data to be on the dashboard, but it all has to fit on one screen. And oh, by the way, make it so that it can be printed as well. And they just all want something different. Lots of conflicting requirements. And so the end result here is unfortunate. It's kind of the dark little secret of the dashboard world, which is that the graveyard of abandoned dashboards is unfortunately well populated. So when our dashboard kind of flops with users, our first instinct is often to focus on the visual design, the visual presentation, right? The thought is that making the colors or chart types more visually engaging is going to improve user satisfaction. But when we make changes like this, well, they might revive the interest of users for a short time, but it won't last, right? Usage rates and user satisfaction levels are going to drop back down again very quickly. And this is why making design changes like this is kind of like trying to fix a poorly written document by using fancier fonts or page layouts, right? It's not going to change the fact that it's poorly written. There are more fundamental issues. And so the problem with this dashboard was not that it was visually boring or that it wasn't visually engaging enough, is that it wasn't doing a good job of answering the most common types of questions that users of this dashboard might have. So questions like, is everything okay? Does anything require my attention in here? Or what's the relationship between our expenses and our headcount? Or are we achieving our strategic goals, right? So making this dashboard more visually engaging isn't going to make it any better at answering any of those questions. It's not going to make it any more useful to users. We need to look deeper at how we organize the information and even how we decided what information to even show in this dashboard in the first place. And so to figure out how to make those deeper improvements, we might turn to dashboard experts and ask them questions like, is it okay to put filters on a dashboard? Or, is that a bad practice? Or does everything need to fit on one screen? Or is it okay, for example, to have information kind of below the fold, or maybe to split the information up onto multiple tabs, right? Is that a bad practice? Or should we have one dashboard per role, like a dashboard for the CFO and a different one for the head of HR? Or should we have these kind of multi-role dashboards, for example, an executive dashboard that's designed to be used by the entire executive team? And so if you've ever done any kind of research into dashboard design best practices, you'll quickly find that experts disagree on all of these questions, right? If you ask different experts, you're going to get different answers. But don't worry, it does get worse, because most of these experts don't even agree on what a dashboard even is in the first place, right? If you've been paying any attention at all to this field, you know that this is just a decades-old debate. Now, if you were to pick just 1,000 random people in 1,000 random organizations and show them a bunch of different types of information displays and ask them to point to the ones that they would call dashboards, you'd actually probably see a pretty consistent definition emerging, which is that a dashboard is pretty much any display with a bunch of charts on it. If it's a display, it's got a bunch of charts on it, that's a dashboard. And so in that sense, the way that most of us use the term dashboard is kind of like sort of analogous to a term like document, right? Where it's a sort of umbrella term, in this case, for pretty much any set of pages with a bunch of words and images on them. Well, to most of us, that's a document. And so what that means is that, as I said, it's kind of this umbrella term. It includes many different types, everything from patent applications to movie screenplays to news articles. And that's why it doesn't really make much sense to talk about document writing best practices, right? The best practices for writing patent applications have little to do with the best practices for writing poetry or long-form journalism articles, right? Instead, we talk about best practices for writing different types of documents. And so now coming back to dashboard, well, if a dashboard is any display with a bunch of charts on it, it is also going to be an umbrella term for a pretty wide variety of different types. For example, this dashboard, as the creators called it, is essentially kind of a filtering interface for a large data set. You can see the filters along the right-hand side there. This dashboard is actually static, and it's designed to really kind of educate a potentially large audience about the refugee crisis. This is kind of a typical KPI executive dashboard that might be intended for an audience of just one person. This dashboard is supposed to tell me how my workout is going. This one tells me how fast I'm going. And so we have all of these very different types of displays showing different kinds of data for very different audiences. And most importantly, they all serve very different purposes. And so if we talk about any particular or specific dashboard design best practice, what are the chances that that particular best practice is going to apply to all of these different types of displays? Well, 0, or something close to 0 anyways, right? It'll apply to some of these types of displays, but there are very few best practices that apply to all of them. And so really what would make more sense if we were to talk about best practices for designing different types of dashboards. But the problem is that we don't have any, right? We basically just have this one word, dashboard, that we use to describe all of these very different types of things as if they were all part of the same category. And I think that ultimately that's why, or one of the main reasons anyways, why dashboards have been letting people down for at least 30 years. I mean, we called them something different in the 80s, but they were basically dashboards. And so we need a different approach, right? We need, one might even say, a reboot. Hopefully a lot of you have seen this show. It's a great British sitcom called The IT Crowd. But yeah, I think we need to change the way that we're designing dashboards. And I think that that reboot, that reset really starts here. We need to stop talking about dashboard design best practices and talk about best practices for designing different types of dashboards. And so I started thinking about this a couple of years ago. And at the time I was wondering, as you're probably wondering now, like, aren't there like thousands of different types of displays with a bunch of charts on them? And then just after, through working with many different companies, looking at hundreds, probably thousands of different dashboards, I found that in fact, no, there aren't thousands, there are about 13, which is actually a pretty manageable number. And so I've organized them into essentially a taxonomy of displays that unfortunately most people call dashboards. At the highest level, my taxonomy has two categories. There are what I call dynamic data displays. And so these, as the name would suggest, are displays that are based on live data. The data might be updated every 10 seconds, it might be updated once a month, but essentially live. And then we have static data displays, which again, as the name would suggest, are displays which are based on a static snapshot of data that may never be updated, or if it is updated, it would only be updated on kind of an ad hoc basis. And if we look at some of the properties of or best practices that are associated with dynamic data displays, we see, for example, really these are the kinds of dashboards that most of you probably deal with. They're for enabling employees, customers, partners of an organization to essentially interact with the organization's data. And so these are your HR dashboards, your sales dashboards, that kind of thing. They tend to have, and in my opinion should have, a subtle conservative visual design. Typically not a lot of storytelling because it's usually not possible, right? These are displays that are based on live data, and so they look different every time somebody looks at them. So it's kind of up to the user to figure out what the story is. They tend to be interactive, sometimes having fairly complex levels of interactivity. And the primary purpose of this type of display, it's all about answering data-related questions. Questions like, is everything okay? Or how many widgets did we sell in Germany in Q4 of last year? Those types of data-related questions. Now, because there are such a wide variety of different types of data-related questions people can have, I have several different types of displays in this dynamic data display category. There are monitoring displays, of which I have 4 subtypes, performance displays, item displays, and what I call canned analysis displays. And I'm going to show examples of each of these in a moment. I'm going to give you kind of a whirlwind tour given the time constraints. And then on the other side, we have our static data displays. And if we look at the characteristics and best practices that are associated with those, we find they're actually all different than the dynamic data displays. For example, yes, they're used inside organizations, but also used outside in things like training programs or marketing campaigns, public awareness campaigns. as opposed to a kind of a conservative design. In this case, we actually want a more kind of slick, eye-catching design. You'll probably want to have a graphic designer involved in this kind of dashboard. Typically involves storytelling. That's definitely a best practice here. And we can do it because this is a snapshot of data that's not updating, so we can tell a story around it. Tend to have pretty simple interactivity, often none, maybe just a set of static charts. And the primary purpose is not so much about answering data-related questions as opposed to causing some kind of desired change in the mind of the audience. For example, we might be trying to persuade them of something, or simply to explain something to them, or possibly just to get their attention. And so I have 3 types of displays in the static data display category. So already we're starting to see pretty significant differences in terms of design best practices depending on what type of dashboard we're actually talking about. So let's dive a little bit deeper. I'm going to start with showing you a couple of examples of what I call monitoring displays. And so monitoring displays at the highest level, they basically enable people to spot new developments that require action currently. And so it's really for, what do I need to react to right now? Secondarily, to maintain situational awareness. So awareness of kind of what's normal and how that's changing over time. The catch is that we have to allow users to do these things in as little time as possible, because how often do they need to scan for new developments that might require action? All the time, right? They never stop. And so it has to be quick, because this is something they're going to be doing every day, week, month. And that's a challenge. It's very difficult to pull off, because nowadays there are often hundreds or even thousands of metrics that could require the attention of even a single user within a single role. And so as a result, most dashboards actually do a really bad job of this, right? Typically, lots of numbers, but no indication of what actually requires attention, just kind of a wall of numbers, or whether the numbers are good or bad. Basically, how should the user feel about these? And so, for example, typical dashboard that might look like this, at first glance looks fine, but there's nothing on here to tell me, basically, is there anything on here that I should pay attention to? What should I pay attention to first? Or are there any crises here? What on here is good news or bad news? No indicator. And so it's going to be very slow for me to visually scan this. And yet, as we saw for monitoring, it has to be quick. Something like this is actually showing about 10 times more information than the dashboard that we were just looking at, but it's actually going to be much faster to visually scan, because I have those dots to basically tell me where I should be paying attention and where, what is good and what is bad on this display. Another reason why many dashboards fail at monitoring is that they attempt to serve very different roles. But the bottom line is that, especially when we're talking about monitoring, different people need to monitor different types of information. And so if we try and create a single dashboard for all roles, or for even 2 or 3 different roles, we end up with kind of a one-size-fits-all dashboard, which in reality, though, as with t-shirts, it's invariably one size fits no one. It basically doesn't serve any role particularly well. And probably the biggest problem with most monitoring dashboards is that they try and do a whole bunch of things other than monitoring. Things like answering analytical questions, or looking up specific values, or storytelling, or performance improvement. But these are all very different tasks that require very different types of displays. So as I mentioned, there are 4 types of displays that I think are required for really successful monitoring. And I'm just going to quickly show you some examples of each. And so the main type are what I call status displays. And so it's basically all the information that a single role, in this case maybe a VP of sales, might need to respond to on a daily basis. Now, in my consulting work, where I design dashboards for clients, I found that actually what's happening much more often now is that all the information that a given role might need to respond to no longer fits on a single display. And so we end up with many status displays showing different aspects of the business. And this is actually too much information for somebody to look at every day, week, or months, right? They're just going to spend all their time on status review. And so instead, this is where the second type of monitoring display comes in, where we basically take all the metrics that are essentially behaving abnormally, and we pull those together on what I call an alert display. And so this is actually pulling information from potentially tens or sometimes even hundreds of thousands of metrics, and just showing me the ones which look like they actually require attention. Now, when I spot something that does look like it requires attention, probably because it's been flagged by one of these dots, well, I'm obviously going to want to kind of diagnose it. I'm going to want to figure out why is it behaving as it is. Oftentimes, our instinct is to try and put that information directly into the dashboard, but each one of these numbers has many, probably dozens, maybe even hundreds of like child metrics and other associated metrics that would be useful in diagnosing it. And so instead, I suggest that we put that information on the third type of monitoring display, which I call a metric diagnostic display. And so this is basically its own dashboard, but all it does is show everything we know about one metric. And so I can basically diagnose it. I can figure out why is it behaving as it is. And then there's one last, fourth type of monitoring display, which is important, which I call a metric introduction display. And so these are actually often just slides that we show people when they're being trained on the dashboard to give them background information, which is often static information about metrics, like where we get the information, how often it's expected to be updated, that kind of thing. And we basically put it on these separate displays so that it doesn't go on the displays that people are looking at every day, week, or month. So that's it for monitoring displays. The next category of displays are what I call performance displays. And so at a high level, performance displays allow users to assess how well the organization is achieving its strategic goals, identify causes of poor performance, and most importantly, identify ways to improve performance in the future. And these are actually very different tasks than monitoring tasks. And so if we were to contrast monitoring versus performance, well, the primary purpose of monitoring displays is really about troubleshooting. It's kind of reactive. It's just, is there anything out there that I need to respond to? Whereas when we're in sort of performance improvement mode, it's all about making changes, being proactive. Typically, monitoring displays we're going to look at a very high frequency, whereas performance displays really only when we're having performance review, performance improvement meetings. Typically, we need a lot more metrics on a performance display. As we've seen, it could be, maybe even thousands that we need to actually represent. Whereas for performance displays, if we've done it right, there's going to be fewer than 20 carefully chosen KPIs. And as we've seen, monitoring displays should be role specific, but performance displays are for the whole team. So it gets us all on the same page, so we're working towards the same goals, which means that the way that we choose which metrics to include is going to be quite different. For monitoring, it's all about any metric that somebody might need to respond to. For performance displays, it's all about choosing meaningful indicators of how well we're progressing towards our strategic goals. And so I have two types of performance displays. There are what I call KPI overview displays. And so these are all of our carefully chosen KPIs that tell us how well we're actually achieving our strategic goals. And then at performance improvement meetings, we would then look at KPI detail displays. So each one of those KPIs has a detailed breakdown that shows us how well it's doing and guides us, most importantly, on how we can maybe improve this metric in the future. And so I tend to think of the difference between monitoring displays and performance displays as being monitoring displays are kind of like sonar screens. We're scanning this huge ocean and just looking for blips, little metrics out there amongst the thousands that require attention. Whereas performance displays are more like report cards. They don't come out very often. They don't contain a lot of information, and it's all about how can you basically improve performance in the future. But unfortunately, almost no organizations understand this important distinction, and they just have the dashboard, which is intended to serve both of these purposes. And so this is an example of what I call a Swiss Army knife display, basically a display that tries to do too many things and therefore ends up doing none of them well. The next type of displays that I want to show you are what I call item displays. And so at a high level, item displays just simply enable users to interact with potentially large data sets, maybe patients or transactions or customers. And so if our data set is actually not too large, we can use the first type of item display, which I call a disaggregated item display. Disaggregated meaning not grouped, right? And so in this case, we only have about 25 or 30 records. In this case, they're hospitals. And we can basically show all of the information. We don't have to just show subtotals or averages. We can show everything. But what if instead of 30 hospitals, we had 10,000 customers? Well, we're not going to show a 10,000 row table. And so then this is where the second type of item display comes in. You've probably seen lots of dashboards like this before, which I call an aggregated item display. Aggregated because we're looking at totals and averages of large numbers of items. I'm not looking at individual customers here because there are thousands of them. And then the final type of dynamic data displays are what I call canned analysis displays. And so these are displays that allow potentially complex analytical tasks to be performed by people who maybe don't have a lot of analytical or statistical sophistication to perform because they've been packaged up behind a simple user interface. And so an example of a canned analysis display might be something like this, where in the upper left here, we can see that there's a setting for the minimum wage, and then somebody can change that to whatever they want and see how that parameter is going to impact the rest of the business. There's lots of complex business logic happening behind this, but as a user, I don't have to understand any of it because it's been sort of packaged up behind this relatively simple user interface. So those are all the types of dynamic data displays. When it comes to static data displays, now I actually don't talk too much about these because as we saw, typically you want a graphic designer involved here, you want somebody with like a visual artist, and well, I'm not that guy, right? I'm not a visual artist. I know a lot about visual perception, but it's not the same thing. But people tend to call these types of displays dashboards, and so I have included them in the taxonomy. We have what I call persuasion displays, which of course, as the name would suggest, are displays for causing people to adopt a certain point of view or take a certain course of action. In this case, it's advocating for more paternal leave in the US. We also have explanation displays where the goal here is not to persuade, it's really just to educate and bring somebody up to speed on a particular topic or situation. And then we have engagement displays. And so in this case, these are displays which are really just designed to get attention. And so in this example, this is showing some potentially dry data, some insurance or mortality data. And you can put in your ethnicity and your gender and your age, and I guess it'll tell you how you're going to die. And so really the interactivity here is more to get attention as opposed to for more kind of analytical purposes. But wasn't my talk supposed to be about the real reasons why so many dashboards disappoint users? Yes, it is, so let me recap. So as we've seen, there are a variety of reasons why dashboards fail. I've talked about a few of them. Probably the number one reason is that most dashboards try to answer too wide a variety, too many different types of data-related questions. They also, especially when it comes to monitoring, they tend to try to serve too many different audiences. And also when it comes to monitoring, they tend to not flag metrics that require attention. And so then we end up with a wall of numbers. So what can you do? What do you do to address at least these problems? Well, first step is we want to avoid making what I call those Swiss Army knife dashboards, and instead break dashboards up into purpose-specific displays. We also want to avoid making one-size-fits-all monitoring dashboards, because as we've seen, we want to make dashboards that are role-specific. And when I say a role, that's not a person, it's more like a job description. And so we might have, for example, a monitoring dashboard for a regional manager role that has 50 people performing it. And we also want to avoid the wall of numbers problem, right? Where it's just a wall of numbers with no indication of where I should be paying attention or what's going well or poorly. And instead, we want to visually flag metrics that require attention on dashboards. This is a whole other topic unto itself, but if we can pull it off, it's really going to make a huge difference in terms of user satisfaction and the overall usefulness of our dashboards. Now, as you can imagine, there are a lot of tips and best practices that go into actually accomplishing these things. And this is why I'm actually in the process of writing these up, at least my recommendations in a book, which unfortunately won't be out until the middle of next year. However, I have started teaching these skills in online workshops, the next one being this coming November. If you're interested, of course, you can visit my website, practicalreporting.com, and find information about that. So thanks very much for watching. I hope that you found this to be interesting and enlightening. And now I think we're going to have a bit of time for some questions.
Hey there, welcome to Data Innovation Summit, and welcome to Microsoft. If you want to learn about the latest and greatest within the data and AI space, congrats, you're at the right place. During these 2 days, Microsoft subject matter experts will share their expertise and best practices on how to leverage data and AI to engage customers, empower employees, optimize operations, and transform products. You will also hear directly from our customers and partners about their first-hand experience making data-driven innovation happen on Azure. Why Azure, you might ask? Azure is the most trusted enterprise cloud that enables you to innovate at scale and innovate with agility. We offer a wide spectrum of technological innovations. It's not all about speed, performance, and scalability. Azure is also the industry leader to empower data scientists and developers to innovate responsibly with our Microsoft AI principles and responsible ML capabilities. So go ahead and embark your data innovation journey with Microsoft.
The moment an infant opens its eyes, the building blocks of creativity begin to take shape. Everything we see, hear, smell, taste, and touch determines how we think, feel, and create. It's how our minds work. It's what makes us who we are. Just by tapping out the right sequence of keystrokes, we breathe life into the void. The internet connected the minds of the world, and overnight the only limits to what we could make were the scope of our imagination, the physics of the transistor, and the speed of light. Or so we thought. While our minds fluidly process a complex and ever-changing river of information, our programs inhabited a world of boxes, rows, and columns. No incremental improvement, no workaround, no framework could cut the gridlock that entangled our code and choked our progress. It's a problem you can't unsee, and solving it became our defining obsession. So we broke the boxes. We made something new, flexible, intuitive, fast. We built it for the curious, the driven, the playful. Those who see an unsolved problem and dare to create a solution that doesn't fit in any box. We built it so our ideas can reach the world faster, so we can meet the needs of tomorrow's customers better, so we can move as fast as we think. At its core, a development experience that makes data natural in every context, reducing the friction between imagination and implementation. An adaptive, intelligent platform to serve any workload, from the most demanding transaction processing to advanced analytics to rapid prototyping. A modern foundation to build the future on that allows data to vary, to change, to flow, to adapt to whatever happens next. Because we did not come this far to stack boxes. We were all born to create.
Customers are forcing businesses to transform. They want to engage on their own terms and seamlessly navigate through digital and in-person touchpoints. But above all, customers want to be recognized, to be known. Not tomorrow or next week, but in real time. Unfortunately, most businesses can't deliver.
Please hold while I check 5 different systems to understand your relationship with us.
Sound familiar? It's time for you to get to know your customers and to reimagine a customer experience built on connected customer data. Reltio Connected Customer 360 powers all your touchpoints with rich profiles that are continuously updated in real time. The Reltio platform connects the dots of siloed customer data scattered across all your applications You can manage billions of trusted customer profiles packed with thousands of searchable attributes, including transactions, interactions, and third-party data. You can unlock the power of relationships between people, products, organizations, and locations. You can drive hyper-personalization and support connected interactions with real-time insights across all touchpoints, all while simplifying compliance with privacy laws, consent, and communication preferences. You can use insight-ready data to power machine learning and AI investments and bring big ideas to life. Reimagine customer experience for the future. Deliver it with Reltio.
Hi everyone, my name is Josefin Rosén and I work as AI and Analytics Advisor at SAS Institute. We are very happy to be one of the partners of this year's Data Innovation Summit. You will find us in the program during day one, where my colleague Wendy will talk about how to accelerate the analytics lifecycle. You will also meet me during the interactive technology and practice sessions. If you have any questions or just want to get in contact, please reach out to me. You will find my contact information below here.
Our appetite for data has never been bigger, but connecting data across an organization can be a daunting task. As the dynamics of your data change within your organization, so does the complexity you face when trying to deliver value from data at the pace your business requires. All too often, the solution leads to a complex data architecture where you spend more time managing infrastructure at the expense of finding untapped potential within your data. Snowflake allows you to build a modern data architecture with our leading cloud data platform that eliminates the complexity, cost, and constraints inherent with other approaches. Available as a service on leading cloud providers, Snowflake eliminates architectural complexity so you can run many workloads with the elasticity, performance, and scale required by the modern enterprise. What makes Snowflake unique? In one word, architecture. Built entirely from the ground up for the cloud, Snowflake's architecture is comprised of centralized storage for virtually unlimited amounts of structured and semi-structured data, multi-cluster compute for running multiple workloads without resource contention, cloud services to automate common administration, security, and database tasks, and a cloud-agnostic layer to deliver a consistent experience across cloud regions and providers. This unique architecture makes Snowflake applicable to a wide range of workloads, including data engineering by leveraging Snowflake's ability to streamline data ingestion and integration, as a data lake by using Snowflake as your data lake or alongside an existing one, for data warehousing with unlimited performance and concurrency, to streamline data science to simplify and drive performance for complex workloads, for building data-intensive applications that require an analytics workhorse at their core, and streamlined data sharing between consumers and providers. Thousands of companies, including McKesson, Instacart, Square, Caterpillar, and many more, are seeing performance, scale, and productivity gains utilizing the Snowflake Cloud Data Platform. Snowflake has over 1 exabyte of data under management, and hundreds of thousands of users execute hundreds of millions of workloads every day. The next step should be an in-depth conversation with you to help us understand where you would like to go and how Snowflake could enable you to get there.
Tableau Desktop helps you see the stories in your data. It's visual analytics anyone can use. Drag and drop to find trends and outliers. Effortlessly drill into your data and use quick table calcs like running total to see the bigger picture. Connect to the data you care about, whether it's a spreadsheet, database, or big data. Access data warehouses, cloud applications, and cloud databases from a single application. Mix and match from different sources. Tableau brings all your data together in one simple view. Sort, highlight, drill down, or filter your data in seconds. In this view, we can easily spot underperforming products. With Tableau, you can keep on asking questions in the data until you discover the root cause. Change your perspective to discover something new. With a click, the scatter plot transforms into a tree map, highlighting that Western Asia has several unprofitable regions. Use drag and drop forecasts to spot trends, identify opportunities, and ask questions like, will I sell more next year? Add calculations to extend your data. Transform your data into powerful interactive dashboards. Then customize them for different devices. Share your analysis securely on Tableau Online or Tableau Server. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau makes analyzing data fast, easy, and beautiful for everyone. It's designed to help you be smarter, so you can make better decisions faster. Tableau. Answer questions at the speed of thought.
Our appetite for data has never been bigger, but connecting data across an organization can be a daunting task. As the dynamics of your data change within your organization, so does the complexity you face when trying to deliver value from data at the pace your business requires. All too often, the solution leads to a complex data architecture where you spend more time managing infrastructure at the expense of finding untapped potential within your data. Snowflake allows you to build a modern data architecture with our leading cloud data platform that eliminates the complexity, cost, and constraints inherent with other approaches. Available as a service on leading cloud providers, Snowflake eliminates architectural complexity so you can run many workloads with the elasticity, performance, and scale required by the modern enterprise. What makes Snowflake unique? In one word, architecture. Built entirely from the ground up for the cloud, Snowflake's architecture is comprised of centralized storage for virtually unlimited amounts of structured and semi-structured data, multi-cluster compute for running multiple workloads without resource contention, cloud services to automate common administration, security, and database tasks, and a cloud-agnostic layer to deliver a consistent experience across cloud regions and providers. This unique architecture makes Snowflake applicable to a wide range of workloads, including data engineering by leveraging Snowflake's ability to streamline data ingestion and integration, as a data lake by using Snowflake as your data lake or alongside an existing one, for data warehousing with unlimited performance and concurrency, to streamline data science to simplify and drive performance for complex workloads, for building data-intensive applications that require an analytics workhorse at their core, and streamlined data sharing between consumers and providers. Thousands of companies, including McKesson, Instacart, Square, Caterpillar, and many more, are seeing performance, scale, and productivity gains utilizing the Snowflake Cloud Data Platform. Snowflake has over 1 exabyte of data under management, and hundreds of thousands of users execute hundreds of millions of workloads every day. The next step should be an in-depth conversation with you to help us understand where you would like to go and how Snowflake could enable you to get there.
Welcome everyone to Data Innovation Summit 2020. We have another panel here with 3 great guests. Please introduce yourselves. Kent?
Hi, I'm Kent Graziano. I'm the Chief Technical Evangelist for Snowflake. I've been working in the data space for well over 30 years. Got my introduction to data warehousing and analytics by working directly with the father of data warehousing, Bill Inman. Co-authored a book or 2 with him. Also an expert in the Data Vault methodology and architecture, having co-authored the first 2 books on Data Vault with the inventor of that methodology, Dan Lindstedt. Been with Snowflake for a little over 4.5 years now. Just been having a great time traveling around the globe, speaking to customers and industry audiences like this one about the future of analytics in the cloud and what we can do these days with all of the great technology we now have compared to what we had when I started quite a long time ago with my first little data warehouse.
Cool. Mutsars?
Yes, hi, my name is Rick Mutsas. I'm a principal architect for Informatica. Also, like Kent, spent a better part of 25 years in predominantly data warehousing and analytics. So, yeah, Bill Inman, Dan Lindstedt, very familiar names. Data Vault methodology picking up rapidly now, especially given the way you can automate all of those processes using AI and machine learning. So that's a nice segue into the topic of today. I've spent 20 plus years on the technology with Informatica. So yeah, you could call me a diehard Informatica fan, so you will. And yeah, I'm helping many organizations make their move to the cloud with all these new shiny cloud technologies. And how do you really implement that in your organization? It's hard enough for most IT organizations to keep up with the technology, let alone introduce new technologies like AI and ML to business users. So how do you do that really? And that's what I'm trying to help organizations with.
Cool. Dan?
Yes, hi, Dan Sommer here with Click. So I'm, compared to Rick and Kent here, sounds like I'm a little bit of a junior. I only have about 15, 20 years of experience in the space. So my background is essentially, I spent best part of a decade at Gartner. I was the research analyst there for BI and analytics markets, i.e. where the space is heading, which technologies are growing, et cetera, et cetera. And then I just spent 5 years now with my current employer, Click. This summer, it passed 5 years. And here I head up the market intelligence team. And I like to sum that up as kind of looking at the macro, i.e. are we heading in the right direction? Are we seeing the forest for the trees? The micro, so things like pricing analysis, And then competitive dynamics, i.e. the supply, and the demand, what our customer is looking for. So that the kind of confluence of those is the team I'm heading up.
Cool. Well, let's zoom in a little bit before we zoom out and take the macro view. I'd like to hear all three of you what your thoughts are what the latest trends are from this past year in specific, and perhaps also in light of COVID-19. What kind of technology have we seen advanced in this past year, and what have we seen regressed? I think also it'd be interesting to hear in terms of customer demand, if that matches what kind of technology advancements we see. Kent, why don't you start it off?
Sure. So we've definitely seen a major uptick in adoption of cloud. I mean, and especially with the pandemic, everybody working remote, the clouds turned out to be kind of the savior for data analytics, because we didn't have to worry about having people go in and out of data centers anymore. We can accelerate the time to value because it's so much easier to spin up resources on the cloud. In Snowflake, we were, of course, seeing this all over the place. We've got an uptick in people getting into a consolidated cloud data platform, which is what we provide. But from a COVID perspective, we actually had a customer in, where are they? I think they're in Hungary. Starschema went and collected from Johns Hopkins and the CDC and the World Health Organization, Italian health agencies, collected all this COVID data, put it into what Rick and I would probably call a curated data mart. Did a little scrubbing, put it into a form that would be understandable by data scientists and analysts alike, and put it into a shared data place on the Snowflake data marketplace. And we've had over 1,000 customers access that to do augmented analytics. Right. So it turned out it wasn't just healthcare. That's one of the things that surprised us. It wasn't just healthcare companies that wanted to access this data, retail companies, because they're trying to figure out their supply chain. It's like, where are the spikes? Where are we needing to anticipate certain kinds of demand, like for the PPE that the healthcare workers needed? How can we get it there faster? And being able to use that, and that combined in using some machine learning type systems to start projecting and forecasting, then based on what Starschema has collected from all the authorities, then take that and forecast that. Where's the next problem going to be? Is it going up? Is it going down? How does that impact our supply chain? Financial companies are looking at these, as well as retail companies, and of course, healthcare and insurance providers are trying to do all of these. And so I've seen, in the last 6 months, right, this confluence of data coming together in the cloud, having everybody's still looking for, Rick, you'll remember this from Bill Inman's, like, single source of truth, right? Well, now we actually have half a chance of putting that together because we have that scale, right? Before we couldn't get servers to scale, we'd run out of room. And then the data scientists are having to pull data from 15 different places to get the story together. Well, now they can get it all in one place. And then being able to share that data on top of it, like what Starschema did. So they're making all this data available. So now the organizations don't even have to go out and find the data themselves. They can just connect to it via our data marketplace, and it's a read-only view of the data. And now they can augment their data with this shared data, and we get augmented analytics. And you start throwing things like auto ML on top of that, right? And some of the other products that are out there now that where auto ML is starting to be getting a big thing, like Data Robot and Data IQ, two of our partners that people are really working with. And so you combine that with something like Informatica and master data management and data quality tools that you've got in that world to get all that data into one place, and then really start taking advantage of it in a much more agile manner. But like I said, the time to value is like, it's shrinking. They're able to get results, which in a pandemic like this, that's critical, right? That's mission critical now. How fast can we get this data, and how fast can we drive intelligent decisions and projections and forecasts from that data? And so all of this it's coming together. It's somewhat miraculous, right? I think the timing is just just right. It's serendipitous for the world that we have these technologies available, that we can start really doing something with it that's significant for the global population.
I suppose that's the best euphemism you can come up for what's happening right now in the world. There's lots of upsides always, that people are looking inwards. What do you say, Rick? Both things that are trending up and also things that are trending down. I'd be interested in hearing what you see that has been taking a back seat, so to speak.
Yeah. Well, I think what's really, really important now is that given there's no physical distance or a physical presence for most people working with data, it's really getting the understanding of the data. What am I looking at? It's really fundamental if you want to make the right decision, that you really understand the data that you're working with. There's so much data available anywhere. Whether that's in a Snowflake appliance, whether that's in a public data store somewhere, you really need to understand what am I looking at, especially when you're feeding machine learning algorithms. I mean, if you have a simple math, then everybody can understand if you feed X is 10 and Y is 20, that the result Z is 30. But now what happens with the machine learning algorithm, you feed data into it, you teach it, you learn it, you train it with data, and then you hope that at some point the model is trained well enough with good quality data, that once you put in a real data sample, you get a real valuable output out of it, and you can trust that output. I mean, if you throw in 10 and 20 and you get the result 17, yeah, there's no way to correlate that if you don't really understand the model and if you don't really understand the data that's coming into that model. Similar, data provisioning, Kent already mentioned it. Data provisioning is really important. Self-service is becoming even more important now, I would say, than a couple of years ago. So that's really due to the vast amount of data, the vast amount of tools available. IT is overwhelmed by trying to get their heads around all this new technology. And you need to understand that most database administrators, they perfectly understand how an Oracle database works or how to optimize a Teradata appliance. But now they're moving into a Snowflake appliance. How does that work? It's completely different paradigm. It has so much more power. So you need to adjust your head to get around that and to learn how to work with those. And we see organizations really struggle with IT organizations being overwhelmed and like, oh, but my business is ever more demanding, and they don't want to wait 3 months to get their data approved. So data provisioning capabilities are also really going up. Trending down, I don't see a lot of trends going down. I see demand for data and good quality data going up. But I on the flip side, I do see that there's because of the trend, everything is going to the cloud. The demand for on-premise technology is significantly decreasing. We see that in our software sales. There's a complete shift from our on-premise based tools into our cloud-based tools. They're skyrocketing. So yeah, that's a definite trend, I would say.
Dan, you're the king of trends. Does this extend? What we've heard now from Kent and Rick is that it's quite a tech-heavy kind of transformation. Does that extend into the organization, or would you say that in the tech is where a lot of that change is happening?
So I mean, first of all, I concur with much of what Kent and Rick is saying here. Number one, increased usage of SaaS. What used to be kind of linear has reached a tipping point, and organizations can't run their business when people are physically distanced. We see that self-sufficiency is critical, i.e., you can't open an instruction manual and start reading it, but it needs to be super intuitive, the software. And have collaboration features built in, because you can't sort of lean in together physically and do it. So that has to be very intuitive in the software. Definitely increased demand for shared data, as was alluded earlier, intuitive visualizations and storytelling, as everyone's an armchair epidemiologist right now. Staff and contractor reductions, so that means that we need to sort of a quicker time to value is also super important. But then there's midterm and possibly lasting effects of this as well. For example, cloud budgets, they will stay intact and grow. That's just there to stay, but you're going to see bigger sort of data migrations to the cloud and more, even the most resistant countries of the world, perhaps here in Europe, for example, you're going to see larger hybrid and multi-cloud transitions. And I think never waste a good crisis. It's sad to say, but I think many, and to your point about technology there, whether technology is driving this, I think many CEOs are looking at the new normal after this is done, and it's not going to go back. You're going to cut down on real estate, for example. Definitely, and what we're seeing is the biggest outcome that customers are looking for is essentially improving and redefining processes. And if you've laid off a bunch of back office people, for example, I think things like robotic process automation and process mining will cover for some of those layoffs. And that's one area where AI is increasingly being applied. But the bigger sort of question mark to kind of tie to what Kent and Rick said is we need to deal with a world that is increasingly distributed. And so therefore, I think we've solved a big data problem. The big next problem that we have to solve is the wide data problem, where data is in multiple different places. You have to bring the data to the right place. Metadata is increasingly important. And harmonizing data from multiple different data sets, because that's usually where you can invent sort of the next business models, to your point about technology and business models. So I think there's a bunch of technological underpinnings that are happening, which is leading us to this perfect storm of a third generation of technologies and value that can be provided from it.
All right. There have been a lot of startups that have really taken the opportunity to take some of these new technologies and roll with them. And as a consequence, we've seen also a lot of mergers and acquisitions relating to these startups. Some of them come from within the companies, where companies have their own little accelerators within the companies, and sometimes it comes from startups on the outside. Have you seen that with your customers, Kent, where people have relied on Snowflake to provide sort of an enterprise foundation and then incorporated some of these new outside companies to build on top of that with these new AI techniques and whatnot?
Yeah, we're seeing a little bit of that. Some of the like you said, a lot of startup companies actually early on with Snowflake. We had a lot of small tech companies in Silicon Valley that have then gone on to be acquired. And I've actually seen a couple of Snowflake customers get acquired by Microsoft, right? And so they actually, Microsoft acquired a company that was successful because it was working on Snowflake, and then able to take the processes and analytics that company had developed already, sort of, I'll say like an incubator, and just suck that right in. Even Snowflake, we've acquired several small tech companies ourselves. So our new UI out called Snowsight came from a company called Numeracy. And that's now an app on top of Snowflake to enable our customers for self-service, to Dan's point, to make it much easier for them to analyze the data and really, again, accelerating the use of the data. And so definitely seeing some of that is happening for sure out there. And I think we'll see more of it, right? As we start to see which of these new companies have legs, right? That are getting adoption, and it may even be only in a particular vertical. I expect to see that sort of thing. And so even like, well, Qlik, I'll use Qlik as an example. You guys acquired Attunity this year, right? So we had that merge year where before we had, thought really a lot about Qlik as reporting. Well, now we have Replicate and Compose, right? And so they've expanded their footprint by getting these other key technologies that are going to help their customers achieve this goal. And so
yeah, exactly. So yeah, sorry, I didn't mean to interrupt you, but perhaps I can fill in here. So I mean, Since you mentioned Click, I mean, we've tried to move back in the value chain. We spoke about this increasing world of distributed data. So then it's no longer enough just to do analysis. You have to do analysis and synthesis. You have to synthesize data sources that are in a bunch of different places. So we see that as the panacea, working with partners like Snowflake, Informatica, Data Robot, and many others within sort of a modern stack ecosystem, but also being able to do a lot of that end to end and see synergies there. Essentially, so being able to sort of move data from raw to transforming it to analytics ready. We spoke about metadata, to then essentially do analysis on these distributed data sources and take action on it. Those are sort of the steps in that value chain. But on the startups point, I think it's interesting to see that, yeah, I do see a lot of mergers and acquisitions going on right now. Click, you mentioned we acquired at Unity, but we also acquire a lot of companies in our ecosystem that have built on top of our open platform. So we also acquired an alerting company. We acquired a company that does sort of pixel perfect reporting, etc., and it's integrated from day one. But we also see a lot of less viable companies that may struggle, as perhaps some of the investors are getting cold feet. So I do think that we'll see a lot of both big and small mergers and acquisitions. Today I heard that, I'm not sure if it's true, so pardon me if it's not, that Microsoft is looking at, for example, acquiring the American part of TikTok. So we'll see these mega mergers as well, but we'll also of sort of very mature startups, but we also see an opportunistic approach from companies acquiring really small startups where their investors may perhaps have getting a little bit of cold feet.
Right. Well, I think you can extend this sort of concept and analogy even further, and for companies that might be working in, say, retail and might not be interested necessarily in purchasing an IT company, that they might still be willing to make a sort of investment in a technology that a company might be developing in order to gain a technological advantage over their competition. Rick, what do you see in terms of those types of investments into sort of groundbreaking technologies when it comes to AI? Is that something that only the big companies afford themselves, or where does that happen?
Well, I don't have a very clear view on it, but it is interesting to see like technology, like that's processing engines like Flink. Flink is a real-time data processing engine as compared to Spark, for instance. Well, we all know that Spark is the norm, but it's interesting to see that a company like Alibaba then acquired Flink to be part of their ecosystem, which is supposed to compete with the Amazons and the Google Clouds and the Azures. Whether they will be very successful outside of the Asia region, I don't know. We hardly see them when we talk to our customers in Europe predominantly. Well, at least that's the region I'm focused on. The Americas see a lot of uptake for Amazon and Google. Europe is very strong. Microsoft is very strong in Europe, I would say. Google's coming up, but we hardly see any Alibaba for that matter. But it is interesting to see that those large ecosystem vendors are acquiring Salesforce with their acquisition of MuleSoft. It brought them some capabilities that they needed to complete their platform. To us, we're sometimes competing against MuleSoft. So all of a sudden, because their Mule's focus is on supporting Salesforce, to us that was a benefit because, well, we saw them a little bit fade away. So yeah, it's a gain for one and it's a loss for someone else. So it's really up for grabs, I would say. But it is interesting to see these smaller companies be acquired by large large ecosystem vendors.
Yeah, and not just in your own industry, to your point. I mean, that's definitely happening since every company is now an IT company and everything's getting digitized. But we also see, like, if you're only acquiring technologies in your own segment, you're just going to be a fast follower. But if you're acquiring interesting technologies in other segments where there are perhaps similar sort of dynamics going on, I'm thinking of telco or financial services, for example, then that's even more interesting. Perhaps looking at, the American giants would would do well looking at, for example, Alibaba and Tencent and these Chinese players that are very cross-vertical and use, for example, messaging and payments. Those were two separate technologies before, and now they're sort of integrating those. So I think we'll see some cross-vertical acquisitions as well.
Yeah, and we've certainly seen that at Snowflake. I mean, earlier this year, it was pretty well publicized. Salesforce's venture arm invested in Snowflake. So to your question about them investing in a technology, and it was a year or so ago, Capital One, their venture arm, invested in Snowflake as well. And so those are two that I can actually talk about that have decided, that they not only are they using our technology, but they want to help ensure that it evolves and does help provide them that competitive advantage. And so they in turn have invested in the company in addition to just, purchasing the software. And so that was interesting for me. I mean, this is the first, I'll say, big startup I've worked in my career. I've had one other startup I worked with, which was fairly small, that eventually got acquired by Oracle. But this is much bigger, what Snowflake is doing, and to see this sort of cross-vertical investment, right? And on the merger side, again, you look at Salesforce acquired Tableau. Google acquired, what was it Google got last year? Was it Looker?
Looker, correct.
Yeah, Looker. So there's been a couple of those as well. There's some, I'll say, consolidation from that perspective, but Salesforce buying technologies that are, specific to, I say, helping their customers, right? They're again similar to what you've done at Qlik with expanding where your presence in the value stream. Salesforce is doing the similar things in acquiring MuleSoft and Tableau, so that they can better help their customers get the value out of their platform, out of the CRM platform itself. So yeah, there's a lot of interesting things happening. And I think with, again, what's happening with the pandemic, there's some economic impacts, right?
Yep.
And I don't think we've seen those yet. Those are coming. I think in the next 6 months, we'll start seeing those from a business perspective. We'll see, and like you said, the CEOs, they're having to forecast what's the new normal, right? And so there are those business use cases that nobody probably foresaw 6 months ago, that CEOs and CIOs and chief data officers are all now thinking about. It's like, okay, how do we deal with this? How do we make sure that as a company, we remain competitive? And as a company, we have the workforce that we need, and that we are still treating that workforce well, that they want to continue to work for us, that they're, the whole attract and retain your workforce with this, the new normal, with so many people being remote. How do we manage all of that? And so all of that requires data, right? And so we're back to that. How do we do that? How do we accelerate that? And improve the processes. To your point earlier, Dan, right? It is not just the technology. It's like we use technology as a way to improve the business process, to improve the business decisions, and improve the customer and constituent outcomes is where we're really trying to go.
I'd like to spin back to something that Dan was talking about before, which has to do with that you said we're all software companies. And that's become sort of a maxim that people have spoken. And I'd like to hear to what degree you think that is true or not, especially when it comes to data and advanced analytics. Only one person today has spoken in absolutes. They said that you have to be on the cloud, otherwise you're old news. And I thought that was sort of refreshing, because everybody speaks in vague terms, and you need a little bit of this and a little bit of that. Would you be able to commit to any sort of absolutes when it comes to these things? For example, do you have to be on top of advanced analytics and AI to be relevant? Or does that only apply to certain industries nowadays? What do you say, Rick?
No, I think that that applies to any industry. If you're not implementing AI and machine learning strategies to help you make better decisions, to help you build better data pipelines, to help you get a better understanding of your data, you're falling behind, and then you're losing the game, especially in this world of digital transformation. Digital transformation is all about how can I get to my customers faster, especially in this new world of after the pandemic. Customers realize, organizations realize, they need to retain their customers. So having that 360-degree view of their customer is critically important. Being able to retain your customer by doing a next best offer, by better predicting what a customer will do in its course, being able to better predict when machines are going to fail so that you can lower the cost. It's ever more important, I would say, now compared to yesterday.
So it's always fun with someone who's a little bit contrarian. So it's good that we have absolutes and binary viewpoints. I'm going to be the one taking the other position. I do think that there are opportunities in having a leg in both worlds. Both when it comes to the data side, there are all kinds of regulations. Sometimes they're contradicting one another. So we have this mosaic or maze of different regulations in different countries, and you have to handle that. So then it's good to have optionality. We certainly see, GDPR is perhaps even sometimes in contrast with the U.S. Cloud Act, for example, that stipulates that if your data is in a data center owned by an American company, they have the right to pull that data. So then you might need optionality, for example, having your data in a private cloud or even on premises, for example. So that's on the data side. And when it comes to AI, there are lots of opportunities across the spectrum there as well. Fun fact, there's still reporting companies out there with huge margins and sort of living well off sort of perhaps a shrinking base, but still. We see even companies using mainframes still, and consultancies having huge amounts of margins in delivering services for them. When it comes to AI, every company and analytics, every company has a reporting factory that churns out the reports that people need on Monday morning. I don't think that that's necessarily going away. There's a huge opportunity of sort of pulling some of those into more interactive dashboards, and perhaps even sort of reporting insights before you build a dashboard. And you do that through moving further back in the value chain, in the data value chain, and finding insights there. So, there are different ways of addressing this AI paradigm. Not everyone needs to address the data scientists and the data science labs doing the most advanced stuff. But you can also sort of build in a lot of under the covers type of algorithms and machine learning into just plain old reporting or analytic workbenches as well. So I think there's a lot of goodness across the whole spectrum, both when it comes to data and when it comes to AI and analytics in this world.
Yeah, and to add to that, I think we should not forget the on-prem world either, because as you rightfully said, the move to the cloud is not something that happens overnight. Unfortunately, for some cloud vendors who wish that were true, but we have an example of well, it's been a while back, but the Dutch Ministry of Defense was trying to consolidate all their applications from 14,000 to a couple of hundred. It took them 10 years before they could really switch off the first application. Moving to the cloud is complex. It's not so moving the data is simple. That's just a copy and paste. But all the dependent processes, all the processes that need to be realigned, that takes a hell of a lot of time. And that's a huge investment, both in time and as well as man hours. So let's not forget that. That's also where AI and machine learning can help. They can help understand all the data pipelines, all the flows, which ones are the most important, which data has not been touched for a year, so that I don't have to migrate all of that. But still, the on-prem world is really important and to keep attention to.
Right, but yeah,
I'm going to put you on the spot for a moment because I know that Snowflake is a big and very capable system. I mean, one of the things you could answer is, does every company need something that capable of processing massive amounts of data in order to be relevant?
Yeah, and it's interesting because there was a Forrester study that I quote all the time from a couple of years ago where they did a survey, and their survey came up with this number, which to me is kind of bizarre. 73% of the people they surveyed said they were aspiring to be data-driven, which I look at the other side, that means 27% aren't. Right? Or are you saying 27% already are data-driven? But I said, I don't want to be working for that 27% that aren't aspiring to be data-driven, because regardless of cloud or on-prem, that's the competitive advantage, right? Is making good use of that data. And so to that point, we just saw a number earlier. Inside of Snowflake, we see really small companies taking advantage of it. And so this gets to your earlier question about us being, is everybody becoming a software company? Is everybody becoming an IT company? And I say no. They actually don't want to do that. We need to help them get closer to their core competencies, which means being less of an IT company, less of a software company, but still a data analytics company. And so you can take with something like Snowflake, you can have, because it scales, right? And it goes very small and you're only paying for what you use, you can start with a very small budget and a very small company that has no expertise in the infrastructure, or like Rick and I with a zillion years of data warehousing. They don't even know what, I've had customers who don't even know what a data warehouse is, never heard of Ralph Kimball, never heard of Bill Inman. They just know they've got these log files from their website and they need to look at their customer behavior. It's all JSON data. They need to get it into a platform and start running queries on it. And some of them are jumping right to what I call citizen data scientists and using things like AutoML, right? So they may go straight from 0 to AutoML with JSON data in Snowflake. And it could be a very small company, but this is now allows them the time to take advantage of the data and actually grow to become a large company. And then likewise, the massive companies that are looking at, we've got petabytes of data, and there is no on-prem system in the world that can handle it. We spent 10 years trying to make Hadoop do it, and great, we got all the data, but we couldn't get the analytics out because it was too freaking slow. And so now we've got to get it into something more high speed. One of our customers spent a couple of months loading. They had 15 years of web logs, right? All JSON data. They were loading 1 trillion rows a day for several months to get all that in and be able to merge it with their relational data that had been in a big on-prem system. So they took the big on-prem system, and as you said, Rick, it took a couple of years, and they got all that up into Snowflake. And then they started now backloading in 15 years of really customer behavior data from their website, web logs. And a couple of people asked me, it's like, that must cost a lot. Well, it costs a fair amount of money to load that much data, but once it was loaded, then their cyber analytics team could take a look at it. And again, they're applying machine learning now to all of that data to drive better outcomes for their customers because they have all of it. So it's on both ends, right? We can go from the very smallest, and again, that's the beauty of the cloud, is you can go from the very smallest to the largest workload you can imagine. And I do see a lot of customers taking on-prem Hadoop and on-prem databases and putting that all into Snowflake so they can get that single cloud platform now. And they can make all of it accessible to the citizen data scientists, to the professional data scientists via dashboards for their analytics within their finance department. All of these use cases now start coming to life, and the vision that I think Bill Inman and the fathers of industry and data warehousing back a couple decades, that vision of having that single source of truth is now coming true, with the addition that we can now actually democratize the data. Like we've been talking about that, Rick, probably 2 decades, democratizing data, right? Yep. And now we can do it. Now we can do it. And it's not restricted. It is not just the Fortune 1000 that can do this now. It can be a startup that just spun up a company in Silicon Valley last week, right? they got their first website up. Well, now they don't have to have a couple $1 million and a bunch of guys like me and Dan and Rick to help them do it. Right? They can get going with their CTO, who's also their developer and programmer, and start loading that data in and get to it and try to beat their competition, right? And try to keep that investor interest up that Dan mentioned earlier. So the investors are going, hey, yeah, this thing's got legs. Let's keep investing in this company. Where if one of their competitors is in that 27% of the Forrester survey that wasn't aspiring to be data driven, they just thought, hey, we've invented a great mousetrap here. We're going to go, start a company and we're going to get it, and we're just going to be hugely successful because we built this really cool thing. But they're not really looking at the data. And that's going to be the differentiator, is how effective are companies in using the data that they have. And then the next piece of that is how effective are they at using other data that they don't necessarily have, because that's been a vision in data warehousing for 3 decades, is being able to augment your analytics with external data that your organization doesn't have, but data that nonetheless happens. And so, back to my star schema COVID, use case that we talked about earlier, of putting all that data up there and making it available to thousands of companies that now don't have to go find it on their own, don't have to spend IT resources to acquire the data, cleanse the data, format the data, and then merge the data. All they got to do is plug in and start doing their analytics.
As one warning, word of warning, and I don't want to sound patronizing, but one thing that's really, really important is that even especially if you're combining data from all kinds of sources across the globe, be vigilant in understanding the data. Really know what you're looking at, because especially with these COVID, there's been a huge debate on how do you count deaths. When do you count something as a COVID death? And if you don't do it right, you get like misrepresentation. I think it was in the news that Mexico had a real odd way of counting COVID deaths. So probably in reality, it was Iran. Sorry, it was Iran. Was today in the news that they counted it wrong according to international rules, and if you then correct it according to these international rules, they were now in the top 4 or top 5 of most COVID deaths. Whereas if you look at the John Hopkins data now, they're kind of somewhere in the middle. So it's really important to have that sense of what is this data actually mean before you start combining it. Yes, data is globally available everywhere, but please ensure that you understand what you're doing with the data, especially with machine learning algorithms.
Which brings us to data literacy.
Data
right?
literacy, yeah.
And I don't know if I'm one day I'm frustrated, the other day I'm happy, because
we started
we're all
off
discussing data right now, and arguing with data in my world is one of the key tenets of data literacy. You have to argue with the data all the time and argue with each other. But sometimes I get disillusioned because it feels like we're just sort of in our stovepipes and we're refusing to budge. And it's very rare, unfortunately, to see that people are sort of shifting positions, increasingly rare. So I don't know what you guys think about that, but definitely data literacy is huge.
Oh yeah, and for all those reasons, what Rick just said. Yeah, you got to understand the content.
Well, I was going to say we have time for one more question.
Yes.
Yeah.
Well, let's end it on that note. In terms of data literacy, I'd like to hear from all 3 of you a short note. This past year has given people the opportunity to focus inwards and rethink their processes, but also we've seen a tremendous investment in certificates, training, and data literacy in general. When it comes to data literacy, where do you think companies should be putting their efforts? Where should they be looking at and upskilling themselves in short terms? I'd like to hear from all of you. Kent?
Well, what we're seeing is, of course, you have the classes and the certificates, and Claudia Imhoff's been talking about data literacy and critical thinking for a couple of years through TDWI and other venues. And you have people that are, I'll say, expert in teaching people about this, but we're seeing a lot of internal communities of practice developing. I think we used to call those centers of excellence, right, in the BI world. And so we're starting to see that. And part of that is companies are going to have to invest internally. So you need some coaches, right? You're going to need coaches, you need experts to teach people how to think about this properly, how to ask those questions, how to ask unbiased questions about the data. That whole bias in machine learning is a major issue, but you've got to have people that can guide them. But you need the internal people in the organization who understand the company's business problems and understand the data, right? That they know what the policies are. They also know what the politics are, but within the company, and can kind of traverse all of that. So it's a little bit, it's beyond the, I'll say, the typical data governance and what we think of as data literacy. I mean, it all is kind of coming together. You need the coaches, just like we did in Agile, right? We had Scrum Masters, right, to help keep the teams on track. You're going to need somebody like that from a data literacy perspective to help guide the organization, but you're going to need the internal people to become experts on enacting those policies and those processes, and putting together those, I'll say, for lack of a better word, data catalogs, so people understand that, how was this number derived? What's the right way to think about that number in context of all the other data we have, in context of our business, of our actual business, in context of our customers, in context of all the regulatory, privacy, and compliance that we have to deal with, right? What do you use? What don't you use? When do you use it? When don't you use it? What needs to be obfuscated? What needs to be masked? Who gets to see what? And what happens if some of the data necessary for understanding the context is actually private data that you can't show to someone else? Now, there's a whole nother ball game, right? Is how do you give them the context if you legally can't give them the context?
Yep.
So go ahead.
I think I fully agree with Ken, by the way, and I think one of the key things that companies need to invest on, apart from everything that Ken said, is building up this catalog of knowledge. And whether you do that in Excel, it's probably not the best tool to do that, or whether you buy something like the enterprise data catalog from Informatica, I don't really care. Well, I do care, but as long as you start to invest in some piece of technology that will help you gather that wisdom of the crowd, because everybody has a little bit of knowledge in their heads around the data that you use on a day-to-day basis. But wouldn't it be nice if you can bring all of that together in a centralized catalog where everybody can go and look for data and find ratings based on their peers? What did my peers think of this data? This data was rubbish because the key elements of this data set were empty or were of bad quality. I don't want to use this data. I refer to another data set that I'm going to use for my analysis. So really collecting all of that wisdom of the crowd, I'd like to call it. That's, I think, really key, and that's what you need to start to invest on, so that everybody can benefit. And you really need to do that in some kind of tooling to cater for the scale of data that you have.
Yeah, I'd like to tie it to both what Kent and Rick said here. Number one, we spoke about cultural challenges. Gartner did a survey with CDOs, and apparently, cultural challenges to accept change is the number one roadblock for them to drive a more data-driven organization, followed by poor data literacy. And it's kind of ironic because none of those have anything to do with data. It's much bigger than data. It has to do with culture and people. So I think, changing the culture is super important, like you said, and you really do that through kind of right-sizing data literacy for the right people. So you do have your, what I call activists in an organization. Those are your application developers. Those are your data scientists, your architects, etc. You should enable those people to have some sort of a driver's license, or what I call a culture of de-silofication. They can go in and break things and take data from different places in a trusted fashion, and essentially, drive innovation with the knowledge that they have. And once they do that, you celebrate them and you shine a light on these activists because they really are changing things with data. If you shine a light on the sort of the best and the brightest data people in your organization, then you are driving a culture where data is important. And following that, data literacy, to Rick's point here, super important is essentially this notion of democratizing it to more people. And you do that through putting data literacy programs in place, putting assessments, and seeing where people are and what they need, what they can improve on. And if you shine a light on the activists, many people want to become like them. So that's increasingly important. So I completely concur with this fact that don't just focus on the most skilled people in the organization, but teach the basics also to sort of the other 75 or 90% in the organization that are, they just want to have a data point to sort of go about and do their business. They're not really data people per se. So that's super important as well, together with just encouraging exploration, doubt, and questions, as we spoke about earlier, arguing with data, because critical thinking and bias busting is perhaps the most important thing that you can have.
Those are three really excellent answers to the question of how to skill up your organization now in 2020. The future is uncertain, but I think what's certain is what you need to be preparing and investing in now to give yourself the most opportunities moving forward, and that's in analytics and advanced analytics and AI. All right, thank you three for your time today. It's been a really interesting panel. Audience, I hope you took a lot of notes, and I will be seeing you in the next session. Welcome everyone to Data Innovation Summit 2020. Here I am joined by a guest from Teradata. Please feel free to introduce yourself and say what you're going to talk about.
Hi everybody, nice to be here. My name's Martin Willcox. I'm Teradata's Vice President of Technology for Europe, Middle East and Africa. Great to be here.
Nice. So we were speaking a bit earlier and you were telling me that Teradata really has a big focus on the operational aspect of machine learning, putting machine learning into production. Can you tell me a bit about the nomenclature that you use and how you speak about these processes?
So we're big believers that machine learning is going to be ubiquitous, even the basis of competitive advantage in very many industries. But what's interesting when you look across large organizations today is there's a little bit of a gap between levels of investment in some cases and levels of return. There are a lot of organizations doing some really, really good and innovative work in innovation labs, but a lot of that work never actually gets deployed all the way to production. And obviously there's no return on that investment in general until we get into production, until we're integrating the insight that's created, the predictive insight that's created from those models with operational processes, with operational systems. And we think in general, a lot of organizations are making a similar mistake, if I can put it like that. We see a lot of organizations over-rotating, focusing too much on the model training part of the process. And model training is great, right? Because it's where we get our inner geek on. And we can play with, this fascinating array of new technologies, and we can debate the merits of, tried and tested approaches like logistic regression and random forest with, some of the newer approaches, support vector machines and convolutional neural networks, and we can have a great time. But in the end, as I say, there's no return on investment in general until we're in production. And we spend a lot of time training models, too much time training models. And that is a drag on productivity. And productivity is a concern to a lot of organizations because they don't have as many highly qualified analytical resources as they'd like. And it's also a drag on time to market. So our analysis, we start to talk about analytics 1, 2, 3. 1 for data preparation and feature management, 2 for model training, and 3 for model scoring and operationalization. And I guess the heart of our observation is that we would like to encourage more organizations to invest a bit more time and energy in step 1, a bit more time and energy in step 3 than they're doing today. And the organizations that we see doing that well, have better productivity, faster time to market, and I think this is really important, they're creating less technical debt. And I think that's going to become a real challenge for ubiquitous machine learning. A lot of the organizations that we work with today have somewhere between 500, 5,000 predictive models in production. I think you fast forward for the next 5 or 10 years, that number's going to become between 150 million and 750 million in a lot of organizations. And obviously at that point, then how you manage that estate, that huge estate of predictive models, becomes really, really important. And a simpler estate, a lower maintenance estate, becomes really, really important if my back of the envelope maths is right.
So Teradata is a pretty well-established incumbent in the field of data processing, data analytics. You've been around a long time. You have very big, mature products for doing that sort of thing. What you're describing now, is that something that's disruptive, especially with respect to your product portfolio that you're known for, or is it a very seamless transition?
A little bit of both, I think, is the honest truth and the short version. So if we're talking about ubiquitous machine learning at scale in really large and complex organizations, then I think there's 2 things that we've got to think about. We've got to be able to scale vertically, and we've got to be able to scale horizontally. So what do I mean by that? Well, there are some use cases, I think, where we get a better model by building a model from more observations. I look at some of our mobile telecommunications customers in the US, for example. One in particular, Verizon, who've gone public very often and talked about this. They train propensity models on over 1 million observations. They score those propensity models for the entire US adult population, essentially. So on about 250 million observations. They've got the lowest rates of churn in telco in the US. So that's a great example of what Google perhaps a couple of years ago was referring to as the unreasonable effectiveness of data, right? Relatively simple algorithm plus larger training data set gets you a better result. Right. There are a whole host of other use cases, though, that we see, hypersegmentation use cases in particular, but not exclusively, where actually you get a much, much better result, much higher predictive accuracy, if you build very many models rather than one big model. So increasingly best practice in grocery retail, for example, for demand forecasting is 1 product per store SKU combination. So you take a large European grocery retailer with, say, 3,000 stores, 50,000 products, that takes you to a requirement to train and score at least daily 150 million predictive models. Now, those models aren't large. They're trained on a couple of thousand observations, maybe, scored on tens to hundreds of observations, but there's a lot of them. And so that's also a scaling challenge, but it's a different kind of scaling challenge, if you like. So from that perspective, you've got to be able to do 2 things really, really well. You've got to be able to process very, very large volumes of data with extreme performance. And you're absolutely right. Teradata is very good at that. That's kind of, that's the foundation, the core of the product, if you like. But you've also got to be able to support very high performance, high localized access to data as well to support those hypersegmentation use cases. And it turns out that the Teradata architecture is very, very good for that as well. We've got this logical hash-based file system, which means we've got very high performance access to localized data sets too.
Let me ask you something, and I'm curious to hear how this plays into your categorization, the 1, 2, 3 step categorization of machine learning operations. You can use machine learning and advanced analytics to generate new revenue streams for your business, or you can use it to optimize existing operations and reduce costs, or perhaps increase efficiency or something like that. Does the how mature a company is at these 3 stages sort of affect what they are able to act on, what they can really, let's say, capitalize on at any given moment? If they come up with an idea, if they're not mature at step 1, like you were saying, or not mature at step 3, does that mean that they're only relegated to doing operations optimization? Or So how does their maturity in these 3 steps affect their ability to capitalize on machine learning opportunities?
Yeah, I think that's a really interesting question. I don't know that I could generalize so much on that, but I think you are touching on a really, really important point, right? Which is when you look at some of the use cases for machine learning right now, in very many cases, these are very familiar business problems, right? Demand forecasting in grocery retail, not a new problem. Fraud detection for online payments, not a new problem exactly. So there's a whole class of well-established business use cases, if you like, where we've just got better mousetraps than we had 5 or 10 years ago, right? We have superior analytic technology, we have bigger training data sets, we have more detailed data, so we can create some new and interesting features and variables that we couldn't a few years ago. But we're solving substantially the same business problem, just better, cheaper, faster. You're also absolutely right, of course, that in some cases we're completely re-engineering business processes. And I think that's really, really foundational. I think, and a really, really foundational thing to think about and to understand. I studied physics at university, but if I could do it all again, I might do history or I might do economics. And I think there are some really interesting parallels. There's a guy I like a lot called Brynjolfsson, professor at MIT, who's written a lot about the sort of modern productivity paradox. And I think it's really striking. If you look back to the sort of late 90s, or late 80s, early 90s, organizations were also spending a lot of money on information technology at that point, right? Client server, new networking technologies. But at the level of the whole economy, productivity was actually decreasing. And Brynjolfsson's argued that we're in a very, very similar situation right now, right? Which is organizations are spending a lot of money on advanced analytics, on machine learning and AI. But at the level of the whole economy, in most of the developed economies, productivity is flat or falling. And that's a pre-COVID thing, right? That's not even a COVID thing. Right. So you've got this apparent disparity between inputs and outputs. And I think if you think back to the late 80s and the early 90s, what did it really take before we really started to see the benefit of those investments in technology? Well, I think it was Michael Hammer and Thomas Davenport and the business process re-engineering crowd, right? They basically told us we were doing it wrong. They basically said, look, you haven't been given these new technologies, these fantastic new technologies to automate the existing business processes. You've been given these technologies to completely replace and rethink those business processes. I think Hammer actually talked about in the famous HBR article, he actually talked about obliterate, don't automate, right? And when the BPR crowd taught us to rethink those business processes, streamline them, create them around the customer and think in terms of end-to-end business processes, then you see this huge surge in productivity in the mid to late 90s. And I think probably if we want to realize the full potential of ubiquitous machine learning and AI, we have to be similarly radical this time around, and we have to rethink some of those end-to-end business processes in the same way that we did in the 80s and the 90s.
I think that's a pretty good segue. You were talking about how some of these processes are getting more mature now, and what we've observed here is that in the past year, a lot of machine learning use cases and models and processes are becoming commoditized, that you're able to purchase APIs for certain types of very common machine learning processes. Can you tie that back to your Teradata offerings, where in this 1, 2, 3 setup, a large important part is structuring the data and making it available so that companies can actually capitalize on these well-established business practices now that are getting more and more common, you know, cataloging metadata and features and that kind of thing.
Yeah, I think that kind of comes back to that whole analytics 1, 2, 3 story, right? I mean, you could argue at a certain level, the algorithms have always been a commodity, right? It's just maths. You can buy a decent textbook and they're all there laid out, you know, in pseudocode or with examples in C++ and Java, right? So the algorithms have always, to some extent, been a commodity. Scalable high-performance implementations of those algorithms, not quite so much. But in a sense, the algorithms have always been a commodity. And what is it that distinguishes the leading organizations from the laggards in this area? It's data. It's their absolute focus on capturing as much detailed data as they can, on managing it appropriately, and I think in particular on reusing it. I think this is really, really key. We've talked a lot about data science for the last few years, right? And we've looked a lot to the scientific disciplines to recruit some of our best and brightest talent. And I think in general that's been a very, very positive thing. But because we've been very focused on science, we focused a lot on repeatability. And that has led to a tendency in some organizations for us to build one data pipeline for each machine learning process that we want to deploy in production. And actually, when we work that way, it encourages us to go all the way back to the source systems or all the way back to the data lake and go and get essentially the same data and to create essentially very similar variables every time we want to build a new model or a variation on an existing model. And I just think when you stand back and you look at that, it's really, really inefficient process, right? We are creating lots and lots of data silos. We're creating lots of technical debt around those data pipelines. And there's just a better way of operating most of the time. We'll never get to the point where, I don't think we'll ever get to the point where we will never need to create new or different features to build a particular type of model. But some of the leading organizations are already at the point where, because they've taken a much more intentional approach to capturing and managing data for analytics, they're reusing 80% of variables across different models and different model families, and only innovating and building new features for the remaining 20%. And that gives you this huge increase in productivity and this huge decrease in time to market, which is also incredibly important for a lot of organizations, right? So I think that's very, very important. And your question was also about, commoditization and APIs. And I think this is really important from a Teradata perspective as well. Our advanced analytics strategy a couple of years ago was to try and own the entire process, if you like. And an explicit goal of this analytics 1, 2, 3 piece has been to not create silos, but to compartmentalize and to enable us to focus on what we think we do best. And we do a very good job of model training in some respects, but there are an awful lot of technologies in that particular segment, and some of them have got real strengths as well, right? So our focus going forward is much more to try and really help with data preparation and data management, and in particular with the creation of structured, curated collections of features and variables, this feature store concept, to really focus on operationalization, because we're really, really good at that. We've got this hugely scalable, high-performance platform that in the organizations that we work with is mostly already connected to the operational touch points. And then to be much more open to working with established and new partners around model training in particular. We want to support and enable our customers who already have made investments in very many different technologies for model scoring, in bringing the power of those technologies to bear on the data that they've already captured and managed in Teradata.
I've seen in many cases that customers change the way they collect data once it's sort of apparent to them what the data can do for them. And both web services and even operational automation doesn't collect the type of telemetry that might very well lend itself to being analyzed with machine learning or automated and that kind of thing. And so is that something that you're experiencing as well, that companies are realizing that they can collect more data than they had been doing, and that's sort of opened up by a renewed focus on the data structuring, the feature engineering, and the cataloging of all that data?
Yeah, and I think it cuts both ways, right? So there is an awful lot of data available to a lot of organizations, much of which has high predictive value. But I think over the last 5 or 10 years, in some parts of the industry, we've almost had this view that, data management is the hard, the time-consuming, and the expensive part of this whole process. So let's just not bother. Let's just throw everything in a data lake, and the organization will be smart enough to figure it out. And that, that has what's the expression? The road to hell is paved with good intentions. Sure, we did that. We did that for a lot of good reasons, right? We were trying to reduce time to market. We were trying to support data democratization. But in very many cases, what we created has become unmanageable. We have lots of redundancy, lots of duplication, and to your point, sometimes the only person that really understands the meaning of a particular data set stored in the data lake is the person that put it there in the first place, which does not help when it comes to reuse. And reuse is how we kind of improve productivity, how we reduce time to market. So, yeah, I am seeing a renewed focus, a renewed emphasis on data management in general, but specifically on data management for analytics, right? On this idea of trying to reuse variables that have already proven to have predictive value for one use case in neighboring and adjacent use cases. You know, the other thing that's really interesting, in a sense, this is nothing new, right? You know, in Teradata, when I've been in Teradata for 16 years, I think, and when I joined, the kind of the two analytic gods at Teradata were Dr. Judy Beyer, who's now retired, and Bill Franks, who no longer works for Teradata but is still very active in this space. And they were talking about the benefits of enterprise analytic data sets 10, 15 years ago. I think Hadley Wickham wrote a paper called Tidy Data, advocating a much more structured, managed approach to capturing data for data science. I think that paper's probably must be at least 10 years old. Forgive me if I've got that wrong. I'd have to go back and check, right? So I think a lot of the intellectual groundwork was done quite a long time ago. It's just become more urgent because, to your point, we're now dealing with larger and more detailed data sets than we were previously, right?
Right. Well, it seems to be, for the time being, nearly insurmountable a challenge where the people that are dealing with day-to-day operations are the ones that have the insights on how to use data, but maybe don't have the skill set to be able to, you know, sit and do feature engineering, pick the right models and that kind of thing. And so being able to let them do that easier is really going to enable organizations to capitalize on AI. And I want to use step number 2 just as a stepping stone to get to step number 3 and ask you one question about it, which is that, you know, a lot of the reason deep learning is getting a lot of attention, well-deserved in my opinion, is that a lot of the output from it is very visceral. It's very easy to look at images and see, you know, what a deep learning model can do with a picture, whereas abstract data is a lot harder to understand. But many of these really big, neat models are quite expensive, quite sophisticated, and the teams that are outputting them have gigantic, dedicated research teams. Do you think that organizations that don't work primarily in information and IT will also be, you know, developing these kinds of things in-house in step number 2? Or do you think that it's better and that we will see more pre-packaged models and techniques that companies will be using and putting into production?
Yeah, what is it that the Chinese say? You know, prediction is hard, especially about the future. I think that the short answer is it's difficult to be certain, and I think it will be probably the situation will be different in different industries and even in different domains within those industries, right? I think that I'm a big believer in general in Occam's razor, in this principle that you know, everything should be as simple as possible and no simpler, if you like, to quote Einstein. So do I believe in the power of some of the newer and computationally more intensive techniques for particular use cases? Yes, absolutely. And is the world a better place for some of the work that's been done in the last couple of years around deep neural networks? Absolutely it is. Does that mean that we should automatically reach for the most complex, the most sophisticated solution? No. You know, no for a couple of reasons, right? Firstly, it's not about getting our inner geek on, right? It's about developing a cost-effective, practical, easy-to-deploy solution. And you know, if logistic regression is good enough, logistic regression is really simple to deploy, really simple to interpret, really simple to maintain. And we just said that technical debt is potentially going to become a huge problem at the point we've got tens, hundreds of millions of models in production. So, you know, I'm a great believer in use the simplest, most robust, most scalable tool that's available to you. And when it's no longer good enough for that particular use case, for that particular domain, absolutely go look for the more complicated solutions. I think the real challenge in very many cases comes back to what are the problems that we're trying to solve? If we go back to earlier in the conversation, probably to realize the full benefit, we've got to be prepared to re-engineer some of our operational business processes. And we've got to rethink the boundaries of those end-to-end business processes. It's the end-to-end business processes that are the most difficult, though. Because if we're talking about optimizing an end-to-end business process, then almost by definition, we've got to have an integrated data foundation to do that. Otherwise, we just end up spinning the plates faster in one particular step of the process. And that, I think, is the challenge sometimes. If we want to kind of outsource some of the advanced analytics, how do we outsource the optimization of that end-to-end business process? Sometimes it's easier to outsource specific point problems, and this can be huge value in that, right? So I'm not arguing against that, but I think it's harder sometimes to just kind of turn over an entire end-to-end business process to an API.
Right. I think that leads us quite naturally to our step 3 of this entire chain, where you want to put the model into production. And one thing that I enjoy very much about this domain is the hacker mindset. A lot of the tools that are making these techniques visceral and popular are open source tools, often held together with duct tape and that kind of thing. What role does Teradata's solutions, what do they fill in a world where you can go to GitHub and download a model hosting tool and sort of try and hack it together yourself? Sort of where does that fit with respect to Teradata?
I'm trying to think if there's a Teradata as duct tape metaphor here. I'm not sure how our marketing department would feel about that, honestly. So maybe I won't go there. I think there's a couple of things, right? So the first is that R and Python in particular are clearly hugely important for data and related libraries and packages, right? Yeah. Clearly hugely important for advanced analytics, data science, machine learning, and are going to be. I think SQL is also as important, but I think R and Python are clearly very important. So better support in high performance parallel database products for R and Python is incredibly important, and that's been a focus of Teradata's R&D for the last several years, continues to be a focus of Teradata's R&D. The kind of duct tape metaphor is apt though, right? And it's interesting because that is the way a lot of organizations work at the moment, and I would argue that it's part of the problem, right? Because if we're talking about operationalization at scale, both in terms of scale of organization, scale of data, we're talking about integrated detailed data across multiple subjects, areas, and domains, and potentially we're talking about scale of models as well, right? Tens, hundreds of millions of models needing to be scored every single day. Then honestly, probably duct tape doesn't really cut it, right? We have to have a more thought-through approach and a more thought-through set of tools. So we've been talking about analytic ops for the last couple of years, which is our kind of framework for thinking about how to do that deployment, how to do that operationalization, how to bring kind of DevOps principles, if you like, to model management, model configuration going forward. And I think that's a really incredibly important area of focus. For me, you can tell a lot about an industry by the things it doesn't talk about, right? And one of the things that we don't like to talk about very much, our kind of dirty little secret, if you like, is that these fantastic predictive models that we're building, they have a half-life, right? They have shelf life. And in some cases, adversarial situations in retail finance where we're trying to do fraud detection, right? That shelf life is really short, right? We do some analysis, we discover that bad actors are defrauding us. We develop a set of predictive models to try and identify how they're defrauding us. We close down that set of fraudulent activities. What do the fraudsters do? They find a new attack vector, right? That's what they do, right? And then we have to kind of go through the whole process all over again. So beyond just model management and efficient deployment in production, I think as machine learning becomes ubiquitous, as we've got very many of these models in production, just to use your expression earlier, telemetry around the models, right? Where are those models deployed? Which version are they running at? When was the last time they ran? What are the results they produced? Do I think the results are still accurate? Is the model's accuracy starting to drift? How badly is the model's accuracy starting to drift? Is that now a problem? Do I need to re-engineer the model? Do I potentially need to retire the model and build a new model? Doing all of that at the kind of scale that we're talking about a couple of years from now is a huge challenge, right? When you've got 500 models in production, 5,000 models in production, you can do that on a spreadsheet. You're not going to be using a spreadsheet when you've got 750 million models in production, right? That ain't going to work.
Yeah, well, I think what you're describing are a lot of best practices that we've had from software engineering now are seeping into even the data analytics field. And on the one hand, a lot of these hacker and duct tape setups, grab the next best thing, like a web developer tool, and then try to apply data science to it. But it sounds like what you're saying, and also something that's reflected in my own experience, that having a holistic approach to data science operations has its merits and perhaps leads to greater success. What are your final recommendations to organizations that are beginning to scale their advanced analytical models for production? They've already tried it. They know it's good. Maybe it doesn't have the big returns that they're looking for, but they're on the journey and they're started, and now they want to scale it out big time. What's your advice to them?
So I think the first thing that I would say to those organizations is recognize that ubiquitous machine learning is first and foremost a data problem. And it's first and foremost a data problem for a couple of reasons, right? Firstly, machine learning is the ultimate expression of the garbage in, garbage out principle, right? The quality of the models that we build and the quality of the predictions that they produce is absolutely and directly a function of the quality of the data, the quality and the appropriateness and the relevance of the data that we've trained them on, and the quality, the appropriateness of the data that we're scoring them with. So that's the first reason that ubiquitous machine learning is first and foremost the data problem. And the second reason that machine learning is first and foremost the data problem, at least for me, is to go back to your point, right? If the algorithms become commoditized, even if some of the applications of those algorithms become commoditized, what have you got left that differentiates you from your competitor? Your data, right? There's a reason that Google, that Facebook, that the big US web giants keep pushing into so many different business domains. And it's not necessarily because they want to own those business domains, but they absolutely want to own the data. They want as much data about their customers as possible, because that's in the end their USP and the basis of their competitive advantage. So yeah, first and foremost, think of ubiquitous machine learning as a data problem. When you think of ubiquitous machine learning first and foremost as a data problem, think about the repeatability and the reuse that we've been focused on around the algorithms. Think about that for the data as well. How can you avoid creating one data pipeline, one new data silo for each new machine learning model that you develop? That kind of feature store thinking is the basis for improving your productivity, is the basis for improving your time to market, and it's the basis for reducing your technical debt. And those three things are hugely significant. And then I guess the last piece of advice I would give is think very, very hard and very, very early about how you're going to operationalize. I've seen some teams do some really fascinating, innovative work that's never left the lab and will never leave the lab except as PowerPoint, because we hadn't thought early enough, do we have the data that we need to score this model in production? Is that data of the required quality? Is it going to be available quickly enough to make a prediction in time to be useful? Is the technology that we're using to train the model anything like the technology estate where we're going to be scoring the model? Because if it's not, then potentially we've got to rebuild the model in order to score it in production. Unless you've grappled with those kind of those feasibility concepts early on, very often you get yourself into real trouble.
All right. Those are a couple of really solid pieces of advice. Thank you very much for taking the time today. Hope the audience took notes, and we will see you at the next video. Goodbye.
Trifacta empowers everyone to prepare messy and diverse data faster. It's a data preparation platform built for the speed of modern business. Start with a flow where the elements of your data preparation project are managed. Add new data to a flow by connecting to a source or dropping in a file. Trifacta presents your data visually for intuitive exploration. Easily spot patterns or data quality issues that may need to be addressed. Preparing data in Trifacta is interactive. Immediately see how a potential transformation will impact your data to ensure you're making the right choice. In this case, we've standardized a date format. With each interaction, Trifacta offers an intelligent suggestion to guide you on how best to clean and structure your data. Use the toolbar to kick off common tasks, such as joining two data sets. Trifacta guides you to select the right common keys and how best to execute the join. All of these transformations are automatically tracked as part of your recipe. When you're finished, click Run Job. Schedule workflows to run on a regular basis for repeated production use. Publish your output to any file format, database, or application for broader use. With Trifacta, you can bring together more data faster, whether you need to prepare data for analytics, machine learning, or standard reporting. So, what data do you need to wrangle? Get started with Trifacta today.
Hi Dexter, welcome to the 5th edition of the Data Innovation Summit. We are really glad to have you with us today. To start with, please tell us a bit more about yourself and your role at Shopify.
Hey, so thanks for having me. I started as a data scientist at Shopify for close to 2 years, and then I actually switched now where I'm a backend developer on a team called Shop, which our home team is actually in Stockholm, Sweden. So.
That's great. And you presented on the machine and deep learning stage on the topic of finding bias in your systems. And as we know, bias, unfortunately, is a large issue for AI and machine learning. Could you tell us what are the steps with dealing with it?
Yeah, so I think just recognizing it, I think a lot of people are kind of complicit in not even looking for it in their systems or believing that it's not worked into whatever they built. I think, so first, just recognizing it and finding the types of bias, and then just finding ways to mitigate it. So when you know that your system is biased towards something, you can try to actually like fix your model in some ways, but it always will have some sort of consequences because it's really hard to define kind of what fair is. But I think just limiting the impact that like a model actually has is one of the biggest steps. And I think just like if a model really is being used for like really big factors in someone's life, like an example is like approving someone for a loan or something, that might be an indicator that like you need to do something very simple so you can understand every step of its decision, or it might be a good place where you can have a model augment like a human as well.
And what are the implications if bias is not tackled properly?
So I think like some systems there is like, it will barely have implications.
No.
Others, it can be a lot like larger. And I think for like being an industry, it's a lot more of just like, do you want a product that supports all users and is like inclusive and doesn't discriminate? And that can, for some companies, that isn't a priority. Other companies, it is. But I think it really could like, there's like so many things that could go wrong. You could actually just like segment out a lot of users that would be great for your product. But you could also just be like straight up discriminating and like have something that is doing something like discriminating on race or something like that. And the implications of that are a lot more for a company because then you're getting into legal issues and things like that.
So these are some helpful insights for taking with them. But what about avoiding bias? Can we avoid bias in machine learning models? And what are the precautions that have to be taken if we want to avoid bias?
Yeah, so I'm like a pretty firm believer that you never actually can remove all bias because someone is still making the decision of what is biased and what is not, and what is fair and what is not. So I think being aware of how models have this, there is techniques, like very technical ones, which like a few of them I talk about in my talk, but you can like de-bias word embeddings and things like that help a little bit. But it's very specific and it's very like, if you go and you fix one specific thing, like you find you have like some sort of natural language model that's biased towards gendered words, you can go and fix that specific things. But then there's all kinds of words that are used from different, like if English is your first language versus your second, like the way you speak, like there's all kinds of ways your model will still discriminate. So there really isn't like a permanent fix for this. Like you have to keep actively doing this. And like most of the time your organization will not like make money from making a model that is less biased. Like the thing is that you could have a model that's like 95% accurate and the biases are helping it. And it's really hard to make a like business case of why you should remove that, because it can degrade the quality of your performance. Because lots of times models will kind of like pick up stereotypes that we do. And like stereotypes aren't always true, but it can still hold true more for one demographic. So you still are making these predictions that are biased and it's helping your product. So it's really hard to sometimes understand when you should like actively try to remove these things. But I think it's very hard to define. And I don't like being like, don't consider myself someone that should be defining like what is fair and not fair. Like I think that that's where government policies and things like that need to come in to regulate models. Because I think if you leave it to each individual data scientist to decide like what is the fairest and not fairest, that's a really like dangerous situation, because everyone has a different idea of what a gray area is. But I do think that just like engineers take ethics courses, data scientists, I think a lot of the time get away without doing that. If you did like a degree in mathematics or like computer science, you often don't take an ethics course. And I think sometimes it's so easy to get really excited about a problem and just like a prediction task and the data you'll use, like all these things, that sometimes you forget like what are the actual ethical implications of it. And it's just like, it's so easy, I think, for any technical role to remove yourself from the bigger picture. And I think that that's one of the things data scientists and just like engineers in general need to always focus on, is like, what are the bigger picture of using this model and what are the implications of it, instead of just like focusing on the individual task.
Yeah, as you said, so, and there's always a gray area. So you can always say which is which. But moving bias aside, let's talk a bit more about the recent developments in AI and machine learning. Could you give an outline of the most important developments in machine learning and AI, and provide your future outlooks of what we can expect in the next 1 to 2 years?
Yeah, very, okay. So I think there's a lot of like, the last 2 years have really been huge for natural language processing, specifically like looking at pre-trained architectures and leveraging them. We're following a lot of the things that have happened in computer vision already, where there's a lot of these mainstream models we can pull in. But now in like NLP, we have like BERT, we have like OpenAI is doing some of the like most interesting work on text generation, every model that they release. And I think a lot of people are very worried about like having these models that could write like fake news stories and things like that. But I think there's a lot of really cool things coming out of it, like being able to just like, I think we still are like so far from having like models that you can, every like NLP use case is typically very specific. Like you're still training on a very specific task, and we're starting to get models that are just like really good at generally like understanding questions better and parsing that out of text and like creating structured data out of like text data. So I find that really interesting. But the other area that I like think is interesting is like work being done to de-bias models. And there isn't like a lot of work on it. Google actually publishes quite a bit of interesting stuff on it. But I think that there's a lot of room for improvement there. And I would like to see a lot more improvement, even just like tooling to actually find out when there is bias in systems. Because I think, again, like everyone's pulling in these like really amazing large models, but no one really understands like how decisions are being made. So I guess, sorry, the keyword is interpretability. And I think that that's, again, like, I think the last year, it's been a really hot word. Like everyone's suddenly talking about it, where before it was just these black box models. But I think that it's a very tough problem. I think we're like so far from it. I have like no idea what the solution will look like, but I think that that's one of the areas we'll see a lot of growth in, because as these black boxes are starting to make their way into more decisions in our lives, and we don't understand how they do fully impact us, I think there is going to be more regulation, as there should be, on how these decisions are being made.
Thank you for giving your insightful answer and predictions. It's really inspiring to hear some of the stuff. And that was our last question. And I would like to thank you for being with us at the Data Innovation Summit and for taking the time to do this interview with me.
Yeah, thank you so much.
Hello, Richard. Welcome to the 5th edition of the Data Innovation Summit. We are really glad to have you and Semarchy with us for this special edition. It's not the first time that you are participating in one of our summits, but it's the first time that Semarchy is our partner. So to start with, please tell us a bit more about yourself and Semarchy.
Yeah, hello, Ivana, and hello, everyone watching. Yeah, it's good to be talking to you. I rather hoped to be in Stockholm, but unfortunately, that's not to be. So I'm talking to you here from my home in near London. Yeah, I'm the general manager for Semarchy Limited, and from our offices here in the UK, we look after business, obviously, for the UK, Northern Europe, and the Nordics. And Semarchy we position ourselves as the intelligence data hub company, providing software for master data management, reference data management, and generally in the data management sphere. So that's something about us, and I'll tell you a few more in a moment.
Great. Then today you presented on the data management stage, introducing Semarchy's Intelligent Data Hub Master Data Management. Could you sum up the main key points that attendees took away from your presentation?
Yeah, sure, Ivana. I think that there were a number of points in it, but I think one of the key points is the complexity of a master data management solution. And I think it's very easy to assume that it's simple. People presume that it's simply about people, places, and things. But when you add in the other complexity of information in an enterprise or in an organization, information from call centers, information about contracts, sales forecast information that surrounds those people, places, and things, it actually becomes a very complex network of information. So I think that one of the key takeaways really was that by joining all of that together in what we would call a data hub, then you're really able to take action and analyze that information and build on that to increase to achieve the results that you want to achieve from your systems.
Talking about MDM, it is constantly evolving and becoming more accessible through available MDM tools and software. Could you please give us some interesting examples of your MDM projects and how you help organizations excel in this area?
Yeah, some interesting ones, and I'll not give names, but it should be fairly easy. One of my favorite ones actually is a worldwide, a global maritime shipping company, and they use our software to interface to their SAP systems, their wall-to-wall SAP for their ERP systems. But then taking Semarchy software, they then interface to that to provide information on the goods that are being shipped, on the vessels that they're on, where the actual containers on those vessels are, and even down to where they are on the oceans. So that's a really interesting one. And another one, a major Swedish automobile manufacturer. People may be able to guess who they are, but they're using us primarily for customer information. But then that customer information, as I mentioned earlier, with the complexities, links through to information on from the dealerships, on the servicing of those cars, the components that they've used. The cars themselves, as you know these days, they have methods of locating them where they are on the roads or where they are in the country. And all of that information is linked together into one global hub, so that when you or I, as an owner of one of those vehicles, corresponds or communicates with the manufacturer, they know everything about you instantly, rather than having to look in multiple different places. So again, that's another interesting use of our software that goes way beyond what I would call basic MDM, and is a genuine data hub.
Yeah, thank you. These were some really interesting case studies. But from your perspective, what are the biggest and most common hinders or challenges that organizations face when it comes to master data management? And what are the implications of not solving these challenges?
Well, there are many, and I've been working with master data management for something like 15 years, and prior to that, data warehousing, and obviously the challenges are quite apparent to me. If I answer the question the other way around, the implications of it clearly are that the company or the enterprise does not benefit from that solution being implemented as quickly as it could be, and I would say that all these applications are implemented for a business purpose. There's usually, I would say, one of three reasons. One is to increase the profitability of the company. One is to improve the productivity. And thirdly, for compliance and fraud issues. So the implications of not doing it are that you don't benefit from the productivity or the profitability, or you're exposed to compliance and fraud more quickly. Some of the key reasons I think is that it's very difficult to prove the value, the return on investment, the ROI. And I think one of the constant challenges we face is that we talk with the business community or the business user for the requirement, and how do we prove that ROI to convince the budget holders and the business to actually spend the money to implement the system. So that's kind of the implication, and if we could solve that problem, then I think we could move forward more quickly.
Yeah, great. So these were some really relevant implications you mentioned. But where should firms begin to approach them? Could you give us some advice on how Semarchy helps companies tackle these challenges?
Yes, yeah. Again, I guess one of the things that we've tried very hard to do with the Semarchy XDM platform is to make it agile, and that's an often overworked use. Everybody speaks about agile. But the quicker that you can implement something, the quicker you can prove whether it works or not. And there's an expression: if you're going to fail quickly. And I think that using the agility of our platform, you can implement a proof of concept or a proof of value, as we call it, in a matter of weeks. Then using that proof of value, you can quickly identify the ROI. So the budget holders then believe in the concept and are able to move forward. So I think that probably one of the quickest ways is actually not to spend months or years talking about it, but to actually get on, get involved, and build a quick proof of value.
That's a good advice for companies. But considering that MDM is becoming more mainstream and moving to the cloud, what can we expect from a technology point of view in the next 1 to 2 years, let's say?
Okay, it's an interesting one. And I've been, as you may have guessed, I've been in the computer industry a long time, and trying to predict the future is always unpredictable. 5 years out, it's impossible to know. I think in the next 1 to 2 years, as you say, the use of the cloud has become much more prevalent. Only 4 to 5 years ago, the finance sector were very reticent to use the cloud, but now it's becoming much more acceptable. And let's face it, a lot of cloud installations are more secure than people's own on-premise computing. So I think we'll see a lot more use of the cloud. we'll say move towards product as a service, and in some cases software as a service. But also surrounding that, I think that there's room to expand to link the data hub in the area of communication. So I think linking it to closer with emails, chat groups, channels like Slack, so that the data hub itself then becomes something that people can communicate and interact within the organization. And also then that will lead to, I think, improved functionality in workflow areas. So I think that the whole concept of the data hub is going to become more collaborative over the next 1 to 2 years by incorporating these type of features. And yeah, it should become the comprehensive place where people go for their information and how to do things, the analysis and driving the business.
These are some really exciting future outlooks of yours that we will see how they turn out. Well,
we hope so.
Yeah, we hope. So thank you. This was our last question for the interview. And I would like to thank you for being part of the Data Innovation Summit, you and Semarchy, and for doing this interview with me.
Thank you, Ivana. It's a pleasure. Thanks.
Expanding an existing multi-year silicon carbide wafer supply.
welcome. I have three interesting guests here with me today to talk about strategies for monetizing data, analytics, and AI. Would the three of you please introduce yourselves? Go ahead, starting with John.
Good afternoon, good morning, good evening. This is John Olson, calling in from New York. I work for Reltio. I'm a VP of our sales and operations in the European region. Been with Reltio for about 5 years now and have 20 plus years experience working in the data management and business intelligence space.
Awesome. Glenn?
Hi guys, I'm Glenn Fitzgerald. I am the Chief Technology Officer for Fujitsu Products Business in Europe. I've been with Fujitsu for, I probably think, longer than you've been alive, Robert, nearly 40 years. I've been through a lot of roles in Fujitsu, but at the moment I'm concentrating on a thing we call in Fujitsu the data-driven transformation strategy, which is all about monetizing data, using the AI and similar technologies to extract value from that to solve customers' problems rather than because it's fun.
Outstanding. Stuart?
I'm Stuart Squires. Hello, everybody. Coming to you from the north of England. I'm Consulting Director for Comma Group, and I've spent the last 22 years or so working on data projects under various banners. So there've been data quality improvement, data governance, data management, but all really helping companies get their data right so that they can then, well, that forms the basis of turning it into a data asset and making something valuable and eventually monetizing it.
All right.
Just pause at that moment, pause at that point to say, North of England, represent.
All right. Well, part of my background is in telecom. And in telecom, we've been speaking about data monetization for a very, very long time. And we see that in the telco industry, to a certain degree, it's become turned into a utility that's taken for granted. And these monetization or new revenue streams haven't really materialized in the way that many had hoped, many organizations had hoped. Can each of you present some good sort of cases of organizations that have been able to monetize new services or data itself, even in the recent past, ideally companies that you've worked with?
For sure. I don't know if you want to take it in any particular order, Robert. I'll start as I've opened my mouth first. There are several. The key to all of these is understanding two things. It's the problem that the customer wants to address, and making sure that data exists in sufficient levels of detail and in the right place to apply the analytical techniques to a positive end. Several examples. One example of a company we worked with, which is a hospitality company in the United Kingdom that owns a lot of restaurants and pubs and things like that. And they had the usual targets for a business in that industry, especially in these times of improving efficiency and reducing cost overhead. We, as Fujitsu, were in the position of having been the provider of their POS services for a long period of time. And therefore we had an enormous amount of data about those tills, their life cycle, the possible problems and errors, faults that had developed over time, faults that developed quickly. We had that data to hand, and because the customer had given us an imperative to reduce cost, we applied, in this case, an AI approach to all that data to produce a predictive maintenance application that said, instead of waiting for a till to break, we will apply the knowledge we have, notice that that till in this place is beginning to return some of the error codes and status reports that indicate in the past it might have a break in the future, and send somebody to maintain that till before it breaks. Because all that data was at hand, that was a relatively simple thing to implement. And the immediate benefit to the customer was that they could then begin to implement in proper the fact that they eliminated pen and paper from their hospitality estates. Everything was done online, which means it can be properly tracked, which means it can be properly backed up, which means it's properly auditable in the security context. Several benefits as well as just cost. So that's an example that drives this point of having to have the data to hand to make valid use of it in seeking a customer outcome.
Right. So John, I'd like to hear from you. You have the opportunity of going either for new revenue streams and new business models or optimizing existing ones. Which one is more ready at hand when it comes to monetizing data in your experience?
Well, you know, in this time, I think a lot of people are focused on customer experience, digital transformations, you know, digital initiatives, and how do we create new business models to support the new world that we live in. I mean, I can give you, you know, a good example of some of the work we've done in luxury retail, for example, where, you know, that there was a quote by one of our customers that said in the last 10 weeks, their e-commerce business has grown more than it's grown in the last 10 years, and which makes sense, right? Nobody can go to the stores. They so you have to go through, you know, e-commerce channels. So they need to adapt to that. But there's a massive change in that industry, you know, as far as millennials and, you know, who's buying their products, and the white glove real-time treatment that they want. And this varies by countries around the world. So you have, you know, Instagram and Facebooks and YouTube and influencers that are promoting their brands, and they need to take advantage of that and give them their customers the white glove experience that they expect when they walk into their stores. So if somebody, a Japanese, you know, individual goes into a store in Paris, you know, there's an expectation that you know who I am and you know what my preferences are and you know what potentially what size shirt I wear. So there's that cross-sell, upsell monetization that is going on, but it's also, you know, reaching out to, you know, get new buyers and bringing them into your community and getting more of a connection with them so you can monetize the new business that's coming in the door as well.
Right. Stuart, what about you, the cases that you've seen?
I'd quite like to come back to something that Glenn, well, the area that Glenn was talking about, hospitality. And yes, this is stereotypical to Englishmen from the north talking about pubs and restaurants. But we do quite a lot of work in the pubs and restaurants business. And one of the areas where data is always troublesome, and it ends up in the till, is allergens and nutrition. So making sure that the data about allergens and nutrition is correct. Because if it isn't correct, then somebody can walk in, have a plate of food, have something that they're allergic to, and something bad can happen. Right. So you've got a choice as a business. You can either manage that data yourself and have nutritional lists, or you can outsource it. And there are companies out there that specialize in making sure that the nutritional information about ingredients and cooking methods are correct. And they take the accountability for that, but it comes at a price. So the collection, the working with the vendors, working with the manufacturers to make sure that that data is accurate comes at a cost, but it's a cost that companies can make money on. And when you feed that into a master data management system or a ingredients and recipe management system that eventually squirts its data into the tills, then you've got that provenance, you've got that trust in the data, and somebody's made money out of it. So I think that's a very good example.
Well, going back then to what Glenn said, he said that one of the prerequisites that they had in place was high quality data. And many things are required for successful data and AI innovation strategies. You need good data. You need skilled individuals, highly technical individuals. I've found that oftentimes you need one individual, but perhaps you can do it with many, that have a vision for what kind of an outcome you want. And then you need the ability to do change management. Which one of these are the most challenging to tackle in your experience?
At the moment, skills, without a doubt. This is both in terms of the use of modern analytics techniques and in the application of machine learning or neural networking, and in some of the other, perhaps at the moment, slightly more fringe technologies, like annealing and quantum computing, or binary chain technologies and things like that. They're relatively new technologies. There's no stream, in my experience anyway, of qualified graduates coming out of universities and so on and so forth. Majority of the people who are skilled in this way have skilled themselves. Often they're involved in startups. Often they're invested in the startup. And it's a difficult thing to educate. If you think about, generally speaking, sales and pre-sales communities, even the IT professionals at the moment, many of them don't have mathematics backgrounds. Mathematics backgrounds are important to understand this kind of technology because, let's not forget, perhaps the most badly named technology in the history of the world is artificial intelligence, which is actually neither artificial nor intelligence. It's just statistics. So finding people who can apply those skills in a business context is very challenging. And certainly in terms of my business across Europe, probably the most significant break on it at the moment is finding the right people.
Okay. And so this skill gap that we find, is that something that applies only to the technical resources, or is there sort of a data literacy gap in the, because to me, it seems like a chicken and eggs scenario where you want to build an organization, but you're not necessarily equipped with the vocabulary to express your needs. John,
and you're quite right. Yes, it is.
Yeah.
Sorry to talk across, but it's clearly you need different levels of that capability in terms of architecting and delivering a solution, and in terms of being aware enough of its potential to be able to sell it, but both are lacking. Yes.
John, what's your experience with people that want to expand their organization with these types of skills? Is that the major hurdle in your experience?
Yeah, I mean, I guess, yes, I agree that skills are probably the primary thing that needs to be addressed. But, you know, it all starts with sort of a top-down, sort of an executive sponsor or a vision of what you want to do and where you're trying to go. You know, our experience, we deal mostly with global 2,000 companies that, you know, are large. They have a lot of data. They have a lot of, you know, channels in which they do business through. They're typically mastering a lot of different domains. They need to understand a lot of relationships. And we're on this modern data management platform, which is big data and, you know, machine learning, and it has a lot of this newer type stuff involved. So getting the skill sets to support this modern infrastructure is important, but I think there is a divide still between business and IT. So the business is very much into, how do I get quick results? And maybe they'll lean towards, you know, some, you know, best of breed point front end solution that they think is going to get them where they want to be within a few weeks or months, where, you know, IT is more complicated than that, because, you know, we have very advanced relationships with our distribution network or our customers, and that all the data quality behind that and sustaining that and that whole data governance is extremely important to make sure these data-driven applications are powered with you know, clean, reliable, trusted data. And that's really sort of where we fit in. It's more the data management layer, so we can feed the machine learning tools so they can do their jobs effectively.
I'd like to follow that tangent a little bit with you, Stuart, where the question is, you have the opportunity of pursuing an AI strategy by buying industry packaged solutions, or trying to build up skills in-house, developing your own models, developing your own infrastructure and all that kind of thing. Among the successful projects that you've seen for monetizing data, have they leaned more towards the developing things quickly in-house and skilling up, or have they started with, you know, low-hanging fruit, industry-proven solutions, that kind of thing?
That's a very good question. And as a data guy, not having the data in front of me to answer that exactly, This is going to be more opinion, really, and an observation rather than statistical fact. One of the important things for any of this is making sure that whatever initiative you're doing is aligned to some business strategy, some burning platform, something that's going to actually add value. You can have teams with brilliant people working your way, doing some absolutely superb work, but they're not actually delivering any value. There's a dog somewhere in the background.
Right.
I don't know whether it is me.
I think that's probably my neighbour's dog. Sorry, not much I can do.
Sorry, I lost my thread then with dogs. So yeah, it's about finding a business problem that it is worth solving and people see the value in it. Because yeah, you can fix a whole lot of small things and get really happy about it and say, yes, look what we've done. But if it's not actually added value to anybody, or it's not added any value to the asset of your data, then you've wasted a whole lot of time. Now, that hasn't answered your question of whether it's better being outsourced or insourced, buying something off the shelf. If you have a specific problem to solve, and there is something that you can pick up off the shelf to solve it, and you don't have to invest in a team of data scientists, then that can be a very good way of getting started. And maybe even if you start proving value out of that technology and out of the governance and the management that you can put around that almost that flow of business demand, a cloud of scientists. I don't know what the collective noun for data scientists are. A body of people who actually deliver value, and then you can repeat that. Then starting small, starting external, it could be the best way to go.
I think Silicon Valley probably has a cool word for a cloud of data scientists that I don't know about quite yet, but
I think you'll find it's an argument.
Got it. Well, I mean, the thing with picking something that's in-house or developed, as a ready-made solution, sort of presupposes that it's a problem that's already solved. Maybe it's well established. And when I compare what best practice in machine learning and databases are, the field of databases is a very mature field. It's very reasonable to talk about what best practice is, whereas in machine learning, we're sort of building the ship as we sail. And in this case, one of the questions becomes, if you think that AI is supposed to provide a competitive advantage, meaning your competitors don't have it and you do, so you're marginally better, there's two questions that follow. One is, are there things where AI can't help? Where everybody's so excited they're just trying to do AI on everything, and it's just not a good idea. And then are there other areas where it's obvious that the fruit is low hanging? Glenn, maybe you can start by saying areas where you think that people are trying to apply AI, but it's a bad idea to begin with.
Okay. You can point at many examples of this type of thing that have failed, because they do. It's new technology, and quite often the problem is that the data doesn't exist in insufficient quality or amount. But more often than that, coming back to something that my colleagues have said, it's that where there isn't a clear view of an outcome, where there isn't an executive sponsorship behind some change, because it's very rare that a change occurs inside an organization that's trying to employ AI technology that doesn't have other implications of change for the organization. A particular example that I was involved in quite recently was at a large bank, and that bank had got a reduced cost imperative from its board. This was not retail banking, this was investment banking in Canary Wharf. And we were talking to their credit card arm, and their credit card arm was wanting to apply AI to the fraud detection on credit card transactions.
Right.
Perhaps counterintuitively, the problem they have really with that is false positives. So they usually detect real fraud. They quite often detect stuff that isn't real fraud, but is the card carrier deciding to go on a short break without telling them. And they stop the transaction, and it annoys the customer who uses his other credit card, and they lose the business. So we were involved in that, and that was very successfully applied because they had the data, because they had the expertise, because they had the defined outcome, which is, now you're going to say, well, why are you talking about that? Because I asked you about failure. Well, the reason I'm talking about that is because while we were having that conversation, a chap from another department happened to walk past the door and hear what we're talking about and come to talk to us about what he wanted to do, which was around automation of insurance underwriting.
Right.
Now, I don't know much about this, but insurance underwriting is apparently a relatively mechanistic task. You have a risk set of tables, you have actuarial tables, you have previous experience inside an organization. You combine all these things together, and an actuary says, yes, this is risk worth taking, or no, it isn't, and if it is, the premium will be this much. Sounds like, sounds like something that would be relatively simple to apply automation to, because they have all the data, they have a clear desired outcome. But what they hadn't anticipated was problems that weren't technology related in nature. The problems were to do with what would happen to the insurance underwriters who were replaced by this system, and the impact of that on the organization, and the fact that they weren't going to just accept that, and politics happened, like politics often does, and it was killed in birth. So I think often the reason is only concentrating on the narrow focus of technology, and not understanding that this kind of change affects a business in its entirety, and you have to count for all of that before you start fiddling with these things.
All right. Well, it sounds like all of the things we spoke about before, the good data, the skills, and the vision need to be in place in order for it to be successful, that they are the prerequisites. And then even then, it's not clear.
Well, that's not always enough. No.
Yeah. What about you, John? I mean, are there things that are, I mean, we know that there are many ways to fail, but are there any sort of areas that are inherently not suitable for AI?
Sorry, just distracted there for a second. So I was going to, not suitable for AI. So the way that Reltio looks at this is, you know, we're a master data management solution. So we're all about, you know, pulling data together, cleaning it up, organizing it, and sort of preparing it for the business, whether it's marketing, sales, or your compliance needs. We get into consent and what have you. Now, we use machine learning and artificial intelligence a couple of different ways that are sort of centered around what we do. So one is around data quality. So how can we, you know, make sure we understand the data quality score of a particular customer, and should we be focused in that area? Or, you know, maybe a ranking profile of all of our customers, and who, you know, maybe our top customers, we need to be focused on those versus, and to sort of prioritize the workload for the data stewards. We also use it in a different way, where we pull in all behaviors and interactions, so we can write algorithms to figure out what the next best offer should be for a customer, or to provide a salesperson with, you know, this knowledge of the relationship, so they can have a more effective meeting. So we have like a life sciences customer that has 10,000, reps out in the field, and they use the Reltio mobile application, so they can walk into a clinic and understand the relationship that their firm has with a doctor or a hospital or a clinic, and be able to have, you know, a constructive conversation about, you know, what products, you know, he can sell them, and how much business they've done, and so on. So, you know, we keep it very constrained to what our use case is. And now we believe that, you know, a data lake or some kind of operational system or analytical system needs clean, reliable data. So garbage in is garbage out. I think we've all heard that. So we want to make sure the data that goes into these lakes or, you know, BI tools is good, so you get, you know, the results out of those systems that you need. So we've all heard about the data lakes and that have become swamps, and people have tried to do machine learning and artificial intelligence on top of those. And it seems like a lot of them have boiled the ocean, and has resulted in, you know, not, you know, great results, and they sort of lose momentum and executive sponsorship.
Right.
So we try to keep it very confined to what, you know, we do and what kind of value we can bring the business.
I think all four of us walk around with a giant hammer of machine learning, looking to hammer things in. I really do believe that AI, in principle, should be able to be applied everywhere. But I'd like, Stuart, you look like you want to add to that notion.
Yeah, well, it was adding to John's data quality notion, and he actually moved on to some of the things that I wanted to say. So thank you. But I was thinking about the actual value of data and data as an asset, and in terms of how Reltio and other companies use artificial intelligence to improve data quality and therefore increase the value of an actual data asset. And if you can quantify how to value that data, then you've got a target. If there's a market there who value that data, whether they want to buy it or whether you want to reduce your costs of producing it and looking after it, that's a really good aim to have. And I use an analogy of a diamond. So the size of a diamond, the carat of a diamond, that drives its potential value. So if you have a bigger diamond, it's going to be bigger, it's going to be more expensive, more valuable than a smaller diamond. But there's the other measurements of a diamond. There's the clarity, so what imperfections are in it, the color, how pure is it, what's the other one, cut, so how it's presented. So and it doesn't matter what market value of diamonds in general are. If you've got a diamond of a particular size and it's a better cut, it's a better clarity, and it's a better color, then it's going to be more valuable. Now, there's two things around that. One is you can't clean a diamond to make it more better quality. You can clean your data. So if there's an intrinsic market value of your data, then you can improve and increase its value in a marketplace. You can't really do that with a diamond. But it comes to the definition of what is good, what is valuable. We see a lot of companies who concentrate on sorting out their data debt. So understanding what's valuable to them within their business, and that might be adhering to rules that are baked into their existing systems, their existing processes. So they're building this thing that's valuable for them. But that might not actually be an asset that other people want to buy. What's the definition? What's the clarity, cut and color set of definitions that everybody in the marketplace values? And what we've been seeing at the moment, and even Gartner brought it up as one of its trends for this year, the data marketplace, where organizations are teaming together with regulatory bodies or industry bodies to define what those definitions are. Is it clarity, is it color, is it cut that makes this data perfect? So then you've got something to aim for. So you're either aiming for that perfect data in order to sell it to somebody, or you're saying, well, I don't want to spend any money on looking after this data, and I know there's an intrinsic value of data that has these measures, so someone can provide it for me. And that's the monetization that the data pools, the data marketplaces are using. And it's not a new thing. There's been data pools for a long time, but there really is an acceleration at a industry specific level. So be that the electrical distribution industry or the building industry or allergens and nutrition.
I want to push back a little bit here and hear what your thoughts are on the following. I'm of the opinion that the ideation and coming up of a way to operationalize data is really the hard part. My favorite author, Asimov, said that many people often came to him with an idea for writing a book, some sci-fi idea, and they said, I know you're good at writing, so you can write the book and I'll just take half the profits. And the hard part is writing the book. It's not coming up with that initial idea. But in effect, we're seeing that a lot of companies are having trouble even coming up with the initial idea. What smart things can we do with the data? And then also operationalizing it. Glenn, where do you see companies, do you also see that companies have a hard time coming up with ideas, or are they full of ideas, but the execution is the hard part?
I think the ideas thing is dependent upon the company. And it is possible to run a series of profiles and questions and work with the company and work out where they sit on a thing we've called the data maturity index, right? Mm-hmm. So there are companies, and we all know who they are, who are completely in control of the data, who exploit it as much as they can and as much as they need. They're at the top of that curve. They need no help from us or probably anybody else. We'll leave them to that. That's fine. At the other end of the curve, there are organizations, there are companies to whom data management and data exploitation are probably not of great value. Quite often, organizations that are based in human service. If you're running a hairdresser's, then data is of limited value to you, unless you're talking about stuff like stock management and things like that, which is relatively trivial anyway. In the middle, there's a majority of organizations, and the majority of those organizations share characteristics of having a lot of data, not really knowing where it is, not really knowing what they could do with it if they'd found it, and in many cases being actively terrified of it. Data regulation, you mentioned, Stuart, but regulation and legislation is becoming more focused. It's becoming more draconian. Change is happening all the time. Recently in Germany, the law changed such that data about German citizens must no longer be held in Germany. It must be held in the federal state of their residence, which has given lots of people a bit of a heart attack, because that means the data has to follow people as they move. Work that out if you can. I've got to take his row out of this database and move it into that database. That's all fun. So I think that even if you can help a company to come to terms with its own data lack of awareness and knowledge, then what to do with that data is a variable pie. It doesn't seem to me to depend upon vertical or maturity of a business. It's largely to do with the clarity of the vision of the people that are driving the business. Even with all the data, it's not necessarily easy to have a good idea about what to do with it. But it's easy to have a bad idea about what to do with it.
You said something before about a maturity index.
Yes.
Does that mean that people should still sort of be thinking that there is a way to be methodical about coming up with ideas for how AI can help you?
Well, if you okay, so application of method to ideas is a philosophical question that you need to discuss with brighter people than me. Human creativity is not subject to method, as far as I know. You probably need Schopenhauer and Kant to discuss that with, rather than a poor old IT guy like me. But I can tell you from experience that where the ideas are good, they come from the people who are executing the process.
So from the organization.
From when the ideas of how to use data to improve a function almost inevitably come from the people who are working with that function on a day-to-day basis, because they know the thing and they know what needs to get better. So if you can talk to them, those guys, about this is the potential of data, this is what you could do with the data, this is how it might change your life, then it's usually the people that are operating it on a day-to-day basis that come up with the ideas that work. Right. That's just experience. There's no fact in that. That's just opinion.
We have a lot of introductions and a lot of workshops with people, and we just walk in and say, tell us what's going on. Tell us what is causing you a nightmare. What would make your life better? And then we take that away and process it. And then, because a lot of the people know what the solution is, or they know what they would like the world to look like. They just don't know how to get there.
And this process of applying that knowledge to the knowledge of other people around how to do it, and a third group of people that know why to do it, you put these things together, you get an outcome. In Fujitsu, we call this co-creation workshops, This is just Fujitsu's way of describing almost exactly what Stuart's just described. What's important is getting the various stakeholders and the various groups of people with the right set of knowledge in a place to have the conversation.
I think this industry bears many similarities with the internet revolution of the early 2000s is equally disruptive and requires that sort of ideation. And it's nice to hear that you're so humble about it, because I think it's really necessary, in my experience, to have these sort of unpretentious ideation scenarios and not really just rely on the center of excellence
to
come up with all the ideas.
I remember the most impressive thing I saw. We were at one of those workshops in Stockholm, and there was a young Polish lady who was with a very small Polish startup. She was really bright. And in an afternoon, she produced a neural network that could read architectural blueprints from nothing, with no idea of, before we started that meeting, of what architectural blueprints were or why they would profit from a neural network, which, as it turns out, is because blueprints are handwritten generally, and to turn those into something that you can use computer-aided design tools on to actually build the building, you need to translate one to the other. Neural networks are good for that. Took her an afternoon because somebody with exactly the right set of skills, in this case mathematical skills and an understanding of neural networks, was being fed with information from people who knew nothing about that, but lots about architecture and lots about how you could take that architecture and build computers to run the thing on. It's quite often an ecosystem activity these days.
John,
Robert,
many people. Sorry, go ahead, Stuart.
Reflect on something that you just said in terms of how we're reflecting the early 2000s and the dot-com boom or bubble. There were a lot of failures. There was a lot of activity, but the bubble burst. A lot of companies disappeared. And I think we've not got to be afraid of that happening again. And that's why startups are so important. And people like Glenn's Polish lady is so important, because they may stumble across something that is so valuable.
But
you may stumble across 100 other things that fail.
Right. So in order to not be stuck like a deer in headlights and be sort of paralyzed by this getting started, John, I've come across many companies that have simply told me, yeah, I mean, we know AI is interesting, but it's not really for us. We don't have enough data. We don't have any data at all. And I know I've seen tattoo artists that have made tools that help their customers describe what tattoos they want using a fun AI-driven visual assistive tool. So you could argue that even small businesses stand to benefit from clever implementations of AI and data management. What do you say to those customers that say we don't have any interesting or enough data to get started with these types of technologies? Oh, you're muted.
Okay, thank you.
There we go.
So interesting question. I mean, maybe not the right question for me or us, because we, like I mentioned, only focus on 2,000 customers. So having enough data is typically not a problem. They have a lot of sources. They have, there's been a lot of M&A activity. There's lots of businesses within the business. So data is the volume of data is typically one of the major issues that they have. How do we monetize data? How do we, there's this new term of data is the new oil, right? How do we, cash in from all this intelligence that we have about our customers through all the different channels that they interact with us and seeing their behaviors and trends and stuff are. So, I was going to come back to a point you were talking about earlier about how do we operationalize this data and how do we do smart things with the data. We have if you look at, our customers and you go into their investor presentations and you see the CEO talking about what their vision is and where they're going, you are normally going to see something about customer experience, about digital transformation, about, putting something in place that's going to make them more competitive and improve their, connectivity with their customers. So we sort of play on that to a large degree. So when we're bringing this data together and we're cleaning it all up, the whole MDM part is the blocking and tackling. That's the table stakes. Everybody absolutely needs to do that. It's really more of what outcomes do you need to do, whether they're operational or they're analytical. So we're feeding analytical systems so you can do, you know, advanced analytics, ML, you know, just reporting on, you know, financial aspects. But most of our customers are operational, so it's real time. So an example would be a Subway, which is the sandwich shop. You know, we are integrated into their mobile app. So if you get out of work at a certain time, you may get an alert saying, hey, maybe you want to pick up a sandwich on your way home. They already have your preferences. They already know exactly what you order every time you come in. Do you want to make any modifications to this? We'll have it ready for you when you drive by. So, you know, we're working with large systems integrators where they go in with digital platforms to put this in. And we, you know, we're not a campaign management system. We're not a machine learning system. We're not a CRM, but they have all the pieces sort of connected together so they can drop it in and you know, immediately get a business. I mean, in Subway's case, they use one of our partners to sort of manage their digital business. And, you know, Reltio happens to be the foundation for the data to power systems like Adobe and Salesforce and other applications that they use.
Right.
So, not sure if I answered your question, Robert. I'm sorry, but I didn't have much to say on small
Well,
companies.
this is an area where you can segue quite easily between a number of topics. It's not entirely clear what if there's a silver bullet to success. It seems like you need to pick the best a little bit from everywhere. So, you know, with that said, this year has been a pretty special year, and it seems like the circumstances will remain, if not the same, at least changed for at least the coming year. So with that said, could you guys give a little advice to people that are looking to monetize their data this coming year, especially in light of the circumstances? Stuart?
So I think I've laboured the point enough that, in my opinion, you'll struggle to monetize your data if it isn't of a good quality. And we can almost use this remote working new paradigm as an excuse to improve how our processes work. Because a lot of processes in a lot of businesses, a lot of big businesses and a lot of old businesses, they rely on the water cooler conversations. They rely on talking to your friend to get a piece of data to be updated. And we've lost that. We've lost that. So using that as an excuse to make your processes more robust, so that when you do go by, you're not stopping the water cooler conversations. That's half of what makes going to work a good thing. But the quality of your data out of the other end of your sausage machine isn't dependent on your water cooler conversations. And also, we've seen a lot of our customers, they've taken the advantage of not being able to trade to sort out some of the data, just throw bodies at fixing data quality. So not artificial intelligence, just intelligence to sort of out.
I really like that idea of taking this opportunity to change your processes now that people are interacting differently. What about you, Glenn? What do you say?
I think this is something that requires a crystal ball. You can see that there are significant changes in the area of public policy. Some of those significant areas in the changes of public policy are going to have serious consequences, and those serious consequences you can help to ameliorate by the application of database technologies. I'll give you people aren't in offices. The people who paid for the offices that people aren't going to anymore are working out that actually maybe I don't need 16 floors on that tower block in Canary Wharf anymore, and I can save myself how many millions a year it is in that hire, which is all very good if you're the company that is not going to do that hire anymore and is going to use remote working technologies and better data management technologies and better collaboration technologies to maintain the productivity of the workforce in that environment. And I take very much Stuart's point. We have lost the water cooler conversations, and they aren't replaced by video conferencing. There needs to be a replacement for that, and that you begin to see some collaboration technologies that are perhaps moving in that direction, but they need to get better. But if you're the guy who's got an empty skyscraper, it's a completely different conversation. So from the very basic of that guy having better building management systems, so that he at least isn't heating empty space, or at least not heating it just enough to stop it degrading. In terms of the response of the businesses around the foot of that skyscraper that depended on footfall at lunchtime for their business, and that footfall isn't there anymore, what are they going to do? They've got to reach out to the people that used to use them in their new environment, and that requires exploitation of customer relationship material. It requires innovation in reaching those customers with new things. I did see one that this is all anecdote, of course, but there's a Jermyn Street, which is in England, where people get very nice shirts. And there were many outlets for Jermyn Street shirt makers around Canary Wharf, and they're all empty now. So Jermyn Street have taken to podcasts directed at consumers and saying, look at this nice shirt, who happens to be wrapped around the torso of somebody who's considerably more attractive than you, but we won't mention that because you'll think it is you, and you'll think it's great and buy it. So it's about innovation and adaptation, because it's not going to go back to the same as it was before. Some of the stuff I've seen from UK government suggests that at least a third of people who've started working remotely will continue working remotely for the majority of their time. The serious impacts of that to society, we're still working those through.
Right. John, what about on your side? Predictions for the coming year, advice? Muted? Let's see if I can go ahead and help out here. You're muted on your side.
Thank you, Goran. Apologies. I'm trying to be polite during when I'm not talking.
Yeah, good.
You know, so our business actually has accelerated through this period, and it's interesting, right? Because we're sort of, for the most part, infrastructure, and it's not, it's a very complicated, expensive, sort of time-consuming task to sort of put in a data management platform to support the enterprise. But we are extremely busy right now, and you think industries like life sciences and healthcare and financial services, and surprisingly, retail and CPG are doubling down right now, because I think they feel like this is a time where they can do things to come out stronger on the other end of this. And as we know, technology, if you don't do anything for 6 to 12 months, that's light years in technology. So they are heavily investing in new technologies, including machine learning and artificial intelligence, to they're going to do a quantum leap over their competitors that are not doing anything during this time. So we are very, very, very busy, which, hey, it's great. I'm very happy I'm busy, even though it's July, August, and I want to take some time off. I'm working on 10 RFPs right now. I mean, I'm okay, fine. But, I think they'll be happy they did that when we get on the other side of this, because, they'll have not wasted all that time, sort of thinking about how horrible the world could be if things don't go the right way. They're just like saying, hey, we're going to figure this out. We'll get to the other side of this. And meanwhile, we have doubled down on what we need to do in order to change to the new world, right? It's going to change, right? We're going to have customer expectations, the way we interact with customers, the way they go and procure products, the way they, how they go to work. Everything is going to be modified, and they're making some, predictions and guesses on what that might look like. And they're just making sure that, they can get through it, and survive, but even be stronger on the other end of this by being proactive and, making sure data is going to be monetized.
I think we can say for sure that despite the circumstances, it doesn't mean that you can hit the pause button on your business. And it seems like a lot of organizations are taking this opportunity to do some housekeeping when there's less hustle and bustle of ordinary business. So thank you all very much for your input on this panel on monetizing data analytics and AI in 2020. Stuart, Glenn, and John, thank you. And we will be right back, everybody, with another session. Thank you very much.
Thank you, guys. Thanks for having us. Bye.
Thank you. Bye-bye. Thank you, Goran.
I think Goran's still with us.
Hey there, welcome to Data Innovation Summit, and welcome to Microsoft. If you want to learn about the latest and greatest within the data and AI space, congrats, you're at the right place. During these 2 days, Microsoft subject matter experts will share their expertise and best practices on how to leverage data and AI to engage customers, empower employees, optimize operations, and transform products. You will also hear directly from our customers and partners about their first-hand experience making data-driven innovation happen on Azure. Why Azure, you might ask? Azure is the most trusted enterprise cloud that enables you to innovate at scale and innovate with agility. We offer a wide spectrum of technological innovations. It's not all about speed, performance, and scalability. Azure is also the industry leader to empower data scientists and developers to innovate responsibly with our Microsoft AI principles and responsible ML capabilities. So go ahead and embark your data innovation journey with Microsoft.
The moment an infant opens its eyes, the building blocks of creativity begin to take shape. Everything we see, hear, smell, taste, and touch determines how we think, feel, and create. It's how our minds work. It's what makes us who we are. Just by tapping out the right sequence of keystrokes, we breathe life into the void. The internet connected the minds of the world, and overnight the only limits to what we could make were the scope of our imagination, the physics of the transistor, and the speed of light. Or so we thought. While our minds fluidly process a complex and ever-changing river of information, our programs inhabited a world of boxes, rows, and columns. No incremental improvement, no workaround, no framework could cut the gridlock that entangled our code and choked our progress. It's a problem you can't unsee, and solving it became our defining obsession. So we broke the boxes. We made something new, flexible, intuitive, fast. We built it for the curious, the driven, the playful. Those who see an unsolved problem and dare to create a solution that doesn't fit in any box. We built it so our ideas can reach the world faster, so we can meet the needs of tomorrow's customers better, so we can move as fast as we think. At its core, a development experience that makes data natural in every context, reducing the friction between imagination and implementation. An adaptive, intelligent platform to serve any workload, from the most demanding transaction processing to advanced analytics to rapid prototyping. A modern foundation to build the future on that allows data to vary, to change, to flow, to adapt to whatever happens next. Because we did not come this far to stack boxes. We were all born to create.
Welcome everybody to Data Innovation Summit 2020. I'm here with my panelists from Kaito, Solita, and CGI. Please introduce yourselves. Lasse?
Hi everyone, my name is Lasse Geers. I work for Solita. I'm a data business designer and principal consultant at Solita. I've been working with data and analytics for 15 plus soon 20 years, from traditional data management BI to modern big data and AI implementation as well. Currently been a consultant for 2.5 years, and my mantra is technology is easy, but the organizational change, that's the real deal.
That sounds about right. Matthias?
Yeah. Hi everyone, I'm Matthias Lindvall. I'm a VP for BI and Analytics in CGI. I've been working with BI and Analytics for the past 20 plus years. And I've been everything from a DBA to the value architect, helping clients get value out of their analytics solutions.
Excellent. And then last but not least.
Hi, I'm Nicola Holmes, and I work for Kaito as a senior data scientist. I've been working with data and AI for about 10 years now, starting as an automatic specialist mechatronics engineer. So I've been working sort of with the brains of things all the way through, right through to the bodies, and really focused on industrial data and industrial automation on a larger MLOps scale.
Excellent. So the theme of today's talk is how to use advanced analytics efficiently across your entire organization. And we've seen that some businesses have been more successful than others in really implementing AI across the entire organization. Can you guys give some examples from the past year of successful AI and advanced analytics implementations with customers that you've been in touch with, and maybe why you think they were successful despite the odds? Perhaps you can start, Nicola.
Well, I've worked with a large company here in Finland who has actually been working to slowly improve their IoT offerings with the allowance of advanced analytics such as AI, industrially influenced ML, and sort of be able to support those offerings for a larger scope for their clients. And what sort of they've done is they've recognized that MLOps needs to work with their DevOps for any software offering and actually be allowed to have the experimentation element there that works with machine learning elements and advanced analytics while not constraining them to a simple and more sort of traditional DevOps approach, while also not getting in the way of all the things that actually make a traditional CI/CD system work.
So what would you say was the key differentiator?
Willingness to actually recognize that it's something that can work with a system, but takes a little bit more freedom and understanding.
Okay, so an open-mindedness.
Open mind that ML isn't going to be a simple answer. If it was a simple answer, it would have been a simple question to begin with, so you wouldn't have needed advanced analytics.
Right.
Understanding that experimentation is part of this and a part of the whole procedure, and even how the algorithms themselves work is sort of key to being able to embrace and understand and get an MLOps system and something that is using advanced analytics, AI, ML, any of the applications of all of those, regardless of what you call them, where you identify them.
Right. I think a lot of people speak about ML ops or perhaps machine learning and advanced analytics like it's a destination, and it's not something you ever end up with. Lasse, what about you? From this past year, is that something you've also felt, that companies are starting on a journey rather than having implemented something that's finished?
Yeah, I've had the pleasure of, in the last year, being involved in so-called traditional industries like agriculture and paper and forestry, which, you know, industries that have been around for a long, long time. And it's, as you guys discussed, there's a lot of process changes that is involved here. It's not just the devices, the IoT devices, and then the algorithms, but there's a whole lot of process changes, organizational changes involved. And we've been helping define things like, what does it mean to be a business owner of an AI solution? Because if you don't have that, then the solution, this leads to the one of the answers to the question, the solution is actually very difficult to move into production if you don't have the business ownership behind it. So it's been really interesting to see the the difference between traditional industries adopting these new technologies and solutions, and how much it challenges their existing organizational structures and ways of working and processes and roles and responsibilities as well. That's been it's been a huge learning path, I think, for the last couple of years.
I'm going to want to circle back on that later on, because it's really nice that we have somebody both from an industry where they're, at least on the surface, you have tons of data ready at hand, so to speak, and traditional industries like the ones you're describing now, where even though there should be data, or perhaps there is data, a lot of times you're met with, well, we don't have anything interesting to really do machine learning with, and a lot of skepticism. And so, it's up to us to sort of ideate and then provide vision.
Well, I've seen everything from the more explorative approach of trying to reinvent your business model using machine learning and AI, which is hard. But if you have the right approach to it and you're open-minded and really getting into the new stuff, but you have to have your sort of infrastructure set up behind you when you do it, because otherwise you get into that sort of just doing the pilots and it comes out of it, and you don't have any lasting value. And getting the business and the technology workers to work together for implementing new business models and getting that AI capability out into the business and generating value for the company. We helped a client moving from selling very low value cleaning services all the way up to selling clean facilities that they only had to do the service when there was dust and stuff in the premises. So they could really up their scale and provide something that no one else could, and it was very quick. It took us 3 to 6 months to go from idea to actually selling clean premises to their clients. When you can do that and you have a company working together like that, then it's really effective. We have other examples where people have 2-year machine learning initiatives that still hasn't produced a single euro in value for those clients. So it's very much up to are you pragmatic, are you flexible? I really heard what Nicola said before regarding the sort of open-mindedness that's really needed all the way from top management to the...
I want to circle back to that again in just a moment, your anecdotes about situations where it didn't work. I think people think that's super interesting, but let's go one more round, because here, this segues back to what Nicola was talking about before, where you use the expression now to transform business processes and business models. And so in the industry that you work in, Nicola, I think a lot of people maybe are already of the idea, at least, that data can transform the way they work. Whereas in the traditional industries, they might be a bit more skeptical. Do they still think in terms of transforming business models, or is it merely optimization of existing business processes? So is it entirely new, or is it just sort of iterative and evolutionary?
Now, that depends on the division within the business. If we're talking about a traditional R&D department, you have people there who have 20, 30 years of in-depth experience in that industrial process. If they're embracing what the new powers of AI can bring, given that some of them have been using some of these statistical methods for nigh on 20 years, but they've got the computational power behind them, they see it as an optimization. They see it as something that will improve how they do their work, speed up how they do their work, and take something that could be a couple of weeks into a couple of minutes, allow them to get that insight and then drill down with their expertise. However, from the business side, they see it as something that is completely turning everything on its head. It's completely new. It's a little bit scary sometimes. And they want to know that whatever they're sinking in isn't going to disrupt what they're currently getting out of their experts, and actually is going to deliver something faster.
I do get the impression that a lot of people are they want to see the results before they commit to a project that gives results, and are a little bit perhaps afraid of taking that plunge. Lasse, especially in these traditional industries, how do you overcome that hurdle where people want the POC that shows value before they invest, which is a reasonable ask?
Yeah, it is. And it should be. I mean, all of this should aim to deliver some sort of business value. There's one thing you said earlier, you used the terms of optimization and then sort of discovery. One of the things you have to make clear from the start is your effort, your AI initiative, is it about optimization of your current business, optimizing your current business processes, or discovering some completely new business models or products or services, or something that you haven't done before? And I think a lot of organizations still sort of struggle because they haven't defined what it is that they're doing. Are they just optimizing what they have or creating something new? Once you start creating something new, you're going to challenge your existing ways of working and your organizational boundaries and everything else. And accepting that is sort of the first step. I think one of the key sort of success criteria there is to find the right people, the champions, or sort of, we call them half crazy product owners, but the people that have really thick skin and enough mandate and influence and impact to drive this through. We've seen that in large organizations, especially, that if you don't have these people who are willing to take the chance and actually, get a few punches, receive a few punches here and there, it's not going to happen without them. So that's really, really important to find those people.
That resonates very well with what we've experienced here, that you need these evangelists or champions. Well, let's put a pin in that one and go to you, Matthias, and ask you these cases that didn't succeed. And maybe you can say, did they have champions as well? What do you think made it so that the AI initiatives didn't succeed?
I would say that there is not one recipe for disaster, but many. As you said before, the team and the champion is, of course, very important. But I've also experienced projects where they have a champion, but they don't have the necessary technology experts available to do it. It's really hard when you have such a diverse technology that's needed to put this into operational excellence with the machine learning and everything. Then it's when you have to have such a huge team and such a diverse set of skills, and you never have them available at the same time, and then it's impossible. The champion is, of course, extremely important, and without it, nothing happens. But if it's equally important to have all the other experts available as well.
Provided that you have a team, you have a champion, you have executive buy-in and all of these things, we see a lot of companies that do successful POCs, allegedly, and then they never end up putting things into production. And I suppose at that point you could argue whether the POC was successful or not. But if you ask software vendors, I think a lot of times they say that the only thing necessary for putting things into production is to have a good ML ops tool stack, and then the rest will sort of take care of itself. Nicola, what are your thoughts on that? What does it take to actually put something into production? I mean, what does that mean?
To take something, especially if we're talking about a machine learning system, from a proof of concept which looks great in its little vacuum, and then making this as something that's going to work larger, it's not just the use of an MLOps stack, it's the consideration of how that model will flex and change with the flex and data changes over time. And it includes basically, so it lands up where your model is this little tiny chink that was contributed to and sort of built up during that proof of concept. And then there's this huge whale of work that has to happen before it each time, because you need to know if you can actually do your continuous training of your models. That's if you have a simple model, yeah, this is simple enough, but you also need to know that when it looks like your model needs to be trained, is that because of your data or because of your model? Is the ways that the data's changed, is it valid? Is it changed too much? Is it changing in a predictable way? Is it changing in an unpredictable way? It's one of these things is that, yes, it's important to have a good MLOps stack, yes, it's important to make sure that the problem you want to address is being addressed properly with the correct questions by the advanced analytics. But then you also have to work out every single other pin and needle in those haystacks that could possibly upset the balance. And then comes down to the core of remembering that no matter how nice you make the technology and no matter how many special things you put on the data, what comes down to the essence of AI and analytics, it's still statistical. And the statistical likelihood that everything is going to go bottoms up multiple times is pretty high. Because you're making an educated guess automatically on scale.
Right, right. Lasse, what about in your industry? Is it the same?
Yeah, it is. And there's sort of I have a personal issue with the, we're very focused on POCs. And I think that the problem we have with that is that a POC is very focused on testing the feasibility of what we're doing. So in other words, can we do it? Do we have the technical means and the skills to do it? And we ignore the other sort of innovation tests of desirability and viability because we're very focused on the tool. We're not enough focused on, does anybody actually use it? What is the impact on the business process? Is it also something that can generate some business value to us? So we're too focused on the tool. That's why sort of I like when companies more think about sort of from an MVP philosophy, because a minimum viable product at least wants to test, is anyone going to use this? And does it serve the purpose it is designed to do? So I think one of the problems with POCs sort of philosophically is that they're too internally focused on just the feasibility of something. And we should focus more on how are people using it? And what does it actually generate? What does it do in terms of business process? Because as Nikolai, I think you said sort of indirectly, is sometimes a simple regression model is all the statistics we need. It's more about how do we actually get it into production so that it starts generating value. And maybe a year later, it requires a more sophisticated model, but we're too focused on the sort of the cool technical aspect of AI.
I think the name POC, the term POC betrays the source of where the POC came from. It's usually more a technical experiment than it is an MVP is probably a much better idea, like you said, is to actually try and build a viable business-oriented product. Matthias, I want to hear from you. One of the challenges, I think, if we're going to expect businesses to express the technical, or not the technical, but the specifications of an MVP, they need to have the taxonomy and the understanding of the capabilities of AI in order to express that need, right? So data scientists can often hear of a problem and perhaps think of 2 or 3 ways of solving it using technology. But what we want is the business people to express their needs in a way that data scientists can understand so that they can perhaps come up with a good solution. And the question is, how do you staff up your organization so you don't end up with the emperor's new clothes? You have a person that doesn't know data science that's supposed to hire data scientists and then build an organization. How do you get past that chicken and egg sort of scenario?
Yeah, well, there is no easy way to the end result, so to speak. You have to have people you trust, and you have to build your castle from the bottom up. There is no way to jump ahead on scale. But just to make a small lapse back, we have to have considered how to run this in production for 2 or 3 years when we start building our models. I find a lot of clients are so eager to get going, and many have started the POCs, and the problem is that they have no plan for when to decommission models or to put them in production and do all that. And they don't have a team. They only have the team that's actually doing the ML implementations. And then all of a sudden you end up in the DevOps, which is good. But how do you transition that into a model that can run your predictive maintenance for you in your 15 plus factories across the globe? That's not going to happen if you only have a team of 4 people that are excellent at machine learning.
What is the sort of competence that's necessary for this to happen, Nicola? I mean, we're talking about mathematicians, and I have a bit of a pet peeve that everybody is a little bit too excited about statistics and PhDs and stuff, being that I have a computer science background, so I'm biased in that sense. But what kind of competence is actually necessary to have these long implementations, correct business plans, correctly implemented models and everything? Is it to have a huge team and to build up a competence center before you can even get started, or what's the right way?
I'd say it doesn't need to be a huge team, but you should have a dedicated team who handles your ML ops, who handles the relationship, as Matthias was saying, once you've actually got this model sort of developed to a certain stage by that little team of experts, those mathematicians, the PhDs. And then you actually have a dedicated team, which includes data scientists. It includes people who have a good understanding of if it's going on the cloud structure, cloud experts, cloud architects, engineers, somebody who is able to answer these questions. And instead of a large team, I personally recommend a multidisciplinary team. A team that they've got multiple skills. They can octopus out into a problem and they know how that connects to that. And if they don't know, they're comfortable enough with another member of their team to go, okay, I'm holding these two pieces together. Do you know where the duct tape would be?
So just can I understand if you're saying clearly now, you're saying it's a good thing to have a team that is quite distinctly multidisciplinary. Is that what you mean?
Yes.
One person that knows the cloud, one person that knows and all these different things in order to make it actually happen.
Yes, the best teams I've seen actually put these into productions. They're not necessarily the team who develops it, but they're the team who are able to understand how it runs, understand how it has to be deployed out, has enough business to know how the end user needs to receive things, and is actually able to either make things happen themselves or have the confidence and the freedom of ability to find who's going to make something happen for them, and that their responsibility is making sure that the production side of these models runs smoothly, runs well, and is continuous, to sort of reach that part of the continuous delivery and the continuous training. And I definitely say multidisciplinary. Like some of the best DevOps teams I've worked with, they've got some people in there who they're like, ooh, I really want to learn more about like the data science and the ML ops part of this because that's another passion of mine. So they land up branching out, and that little bit of extra competence they add out of their passion makes them excellent for managing an ML ops team or working on one, because they've got their know-how from their original competence and then they're spreading out. And then you may have a data scientist who is really interested in sort of all the process of things and may bring a little bit more computer science or a little more software engineering in. And that's what sort of is needed for something like this. You can have a huge team, but that's where I find the communication breaks down a bit.
Right. I really, I'm glad to hear something that I also echo as well, which is that these people that are willing to learn and try new things and dare to try new things is sort of necessary, because we're, compared to databases, we're not working in a field where there are established best practices for every single facet of things. It's a lot about doing it yourself, was what you said. I like that a lot. So what about you, Lasse? I mean, if a company's looking for best practice or looking for guidance, where should they turn to find guidance so that you don't end up like the emperor's new clothes and everybody's just patting each other on the back and saying it's good? Who can be an authority in these things? Is it the cloud vendors?
The dilemma here is, and I would agree with what Nicola said, is like you want a multidisciplinary team, you want people with different backgrounds. What I would add there is also people who have an understanding of sort of behavioral sciences. I worked a lot recently with ethnographers, for instance, and it's really changed my work, because now I understand why we as humans don't always make data-driven decisions. We should instead focus on behaviors and not so much decisions. But the challenge then companies have is, okay, I need a team with all kinds of different backgrounds. I'm not going to find one or two persons that have that, so I'm going to have to hire 10 people, and that's a huge decision to make. So how do you go about that when you either have to find a unicorn or a couple of unicorns, or then hire a large number of people? So I think currently the best practices and what we've seen larger organizations do is you combine internal and external, and you hire your own people for for the roles where you find them, and then you complement with either sort of contractors or then outsourcing certain tasks. I don't see currently another way of doing it, because the best approach is to blend different backgrounds. In terms of where do you get where do you find advice for this? I would say try out different models, because you're able to mix internal and external. So you can obviously then look at different consulting and other companies who can provide those resources and try out and see what works, and be ready to flex and adjust and learn as you go. Because just like the technology, also, the people in this case, there will be lots of changes and you'll learn as you go. So it's not just the data that you'll learn about how the people behave and how you influence your own organization.
That does lead into my next question. I was going to ask, to what degree should organizations depend on consultants for rare cutting-edge competence and that kind of thing? Matthias, I can imagine that a lot of larger organizations have this sort of, they take pride in having everything in-house, and there's a lot of, how do you say? Well, this is a very neat area to be involved in, so I think a lot of companies want to have everything in-house. In your experience, is that something that is feasible? Does it work well, or is it a good idea to blend?
I would say
even if you
blending
can
is the only way. You can actually go with only consultants for a while, but in order to make it happen for a lasting period of time, you need your internal staff as well. What I have not seen any company being successful with trying to build it just in-house. Those that I know that have tried have gotten nowhere. It takes forever to get all these competences on board in your organization, and most of the time 3 or 4 will leave for a more exciting project at a different employer before you get your project started. That's just the way of the business. So
and you're not talking about just small companies, but this is big and small companies.
Big companies, and even if it's a huge company where you have career opportunities in the company, they will leave inside the company for a different position, a different project, a different role. There is no way to keep a team intact unless you have them all at the same time, and that makes hiring them organically virtually impossible.
Right. Nicola, what is your experience on consultants versus tightly knit internal teams?
When it actually comes to the application of MLOps, I have only seen blended teams so far do well at this, for the exact same reasons, in that there is the loss of people in the company, people being more lured over to exciting projects. Because when you are dealing with, as Lasse very well put it, some unicorns, these are often people who are very driven and they want to find what is the most exciting thing that's going to stretch them and challenge them next. So you sort of need to get them while they're there. I do think it is important to have those internals, and that skills can be built with internal staff who are passionate about sort of learning more or sort of increasing their skills there. And I'd say that sort of the balance is nice. Like, obviously, as a consultant, I'm not going to say you don't need consultants. That would be shooting myself a bit in the foot. But I can say that you need to have, like, I've done some things where I've helped set up teams and then hand over the leadership of that team to someone internally, because that's the best way that it's sort of going to work for that company. You sort of need the decisions and the drive to come from within the company, and then those extra competencies that are missing can come from the consultants once it's full set up and running. Like, right. If a company doesn't have the ability to know how to set it up, call that help in and then take ownership of it.
Right. Well, this past year in specific has been very special for myself and for everybody else that works with data science. I'd like to hear your thoughts on how this working from home new reality has made the operationalization of AI and advanced analytics different. Has it made it more challenging or less challenging? Lasse?
Yeah, it was a good question. I had to quickly sort of post it on our internal Slack to see what kind of comments it generate. The first reaction I got from one colleague is that why why would this be any different to the AI and advanced analytics work than sort of any other fields of knowledge working? I mean, everyone has the same, we've seen the same changes in that less contact with people, sort of person to person. It's, we don't do the daily stand-ups at the Kanban board and all of that stuff. But at the same time, things like, meetings are probably a little bit more constructive and better managed because we take them virtually. But in terms of AI or data science specifically, I don't see it being that different to other fields of knowledge work that we do. There might be some compliance type of changes if your work requires you to physically be on the premises because of maybe the data cannot leave the premises, or there's some machines that you have to use that are on site. But other than that, I don't think it's a big change, and that's mostly because this whole field of data science has evolved through collaborative tools.
Well, let me give a little pushback here and hear your thoughts on this. Is there a difference between a team of 20 Java programmers and a team of non-homogeneous cloud database, model hyperparameter tuning experts and people that really need to communicate tightly but don't know anything about each other's topics? Is there a difference between the collaboration requirements of those different types of teams?
That's a good question. I have to say, honestly, at this point, I don't know. I think it might be too early to say if there's a difference there. But yeah, it's because the collaboration tools have been there all along. So whether it's your code repositories or your Slacks or other communication tools, so that's always been there. And people have used that. So I think that's helped a lot in this field. But yeah, I'm not sure if the multidisciplinary team is different to one that is just sort of single skill.
Right. Matthias, what about you? How has CGI seen the past year affect the way that you guys work? And I think it's interesting to be speaking to consultants here because obviously consultants start with the premise of not being necessarily a deeply embedded part of the team in the same way that a full-time employee is. So how has it affected you guys?
I would say that it's very, it depends on the project. I would say we have trouble with certain IoT style projects where we have to go out and collect data, where we have data gaps and all those things, because it's a very hard process once we have the data and setting up the streams and working with the machine learning and all that, then it's fine. Also, the process of finding business cases where the explorative process out in businesses is really difficult. When you're not allowed to meet, you're not allowed to have the first interview face-to-face and those things. That has slowed us down a lot. But once we are in the development mode, then I see that, just like Lasse said, we have the excellent tools from many vendors that assist us, and we're just as efficient as we always been. So I would say where we find the value is the issue. Some of the projects and some of the tasks where you really have to collaborate face to face, then it's difficult. Otherwise, we're just.
I think we're lucky that we already have a lot of the benefits of collaboration tools and processes that have been developed for a long time in the software engineering industry, and that we can just bring them over into analytics and AI and benefit from those. And if we think of it in terms of a process, a multi-step process, I'm curious to hear your thoughts, all three of you, on which of those steps people fail on when it comes to using advanced analytics and AI efficiently across the organization. And if I just define them, you have, ideation, technical preparation work, something that's machine learning focused or analytics focused, and then the operation of the output. If we think of those four steps, which one do you think, or have you, in your experience, do customers really have the hardest time coming to grips with? Nicola?
I'm sorry, but you're going to have to repeat the question. I had a drill start.
Well, there, from the ideation of an advanced analytics workload to the decommission of the model, there's many steps there. Do people get stuck, or do companies that fail, do they mostly fail because the data is not clean? Do they fail because their MLOps tools are insufficient? They can't monitor it correctly? Or do they fail because the idea was bad to begin with, right? Like where along this continuum why do projects fail? At what step is the biggest place where they get tripped up?
I'd say the step that I've seen the most projects from the widest a range of companies fail is it's not that the idea was bad, is that the idea was looking in the wrong direction and too big. They, instead of starting with something small, something adaptable, something achievable, seeing how that worked, and then building on it, they've gone, okay, I'd like the moon, I'd like it tomorrow, and where are we going to put this? And that's where they're falling. It's after the proof of concept when they're going to go in production, what they've wanted and what they think might be possible and what's being communicated lands up being something that is going to be 5 years in that next stage of development to make it actually work, but they want it tomorrow.
Right. Lasse?
Yeah, I was going to say, I've worked with enough companies to sort of be able to respond to that by saying it depends. So I don't know if there's one single step that is more difficult than any other. Some of them, it's really hard. You know, you have an IoT sensor that requires manual extraction of data or some other things. It might be the technology, it might be in your traditional ways of working or something else. But I think once you start drilling into that and getting to a few different levels below, sort of in your root cause analysis, a lot of it still comes down to the fact that it's in the ideation phase that you don't create enough business ownership and accountability to drive that thing forward, because organizations are still people, we're still humans, and you can get through anything you want in an organization, regardless if it's a good or bad idea, if you want to, and if you have the right people behind it. So to then say that, you know, this idea, we didn't get it into production because of so-and-so technology reason, it just means that at the bottom of it all, you didn't have enough business ownership or sponsorship or somebody who just pushed it through. That's how organizations work. I mean, it on PowerPoint, it looks different, but in the end, we're humans. And if you have a person who can get a change implemented in an organization, they will always be successful with that. So I'd say that's why it's in the ideation phase, because that's where you get your business ownership for that idea and you test it.
Matthias, you started off by talking about two companies that had not done well with their AI implementation, and perhaps that's a nice way to sort of tie this up. At which stage was it that made it so that they were not successful?
I would say that selecting the wrong business case. And I would say that some of that blame would go on us consultants. It's very easy for us to say when they ask us, can you do this? We always say yes. And that's horrible. We have to have the ownership of actually being able to create the value that the client is looking for, and have the honesty to tell them that this isn't going to work. This is too hard for you. This is the most advanced analytics case you could pick. Pick something easier so you can get it flying before you try to capture the moon. That's where we fail, and we fail with our clients. It's not their fault. I would say it's actually more our fault, telling them that we can do something that hasn't been done before and no one knows how to do.
I think that's a very good thing to sort of tie this up together on, because it sort of exactly lands on the point that you all are making, that if the consultants come in when the ideation is complete, so to speak, and all you're asked to do is to say whether you think it's a good idea or not, perhaps it's already too late. And it's very neat that all three of you have said that in your experience, the projects that have not done well is because of the ideation and planning, which was not sufficient for the remainder of the project.
Yeah, and there is also the issue that many clients do not want the consultants in the sort of strategy discussion. They want to handle that themselves. And then all of a sudden you end up with a short list of business cases, and they ask you only on those business cases, instead of having the discussion on, on how do we build a lasting ability to implement and run these things for the next 5 years. And many clients would most naturally go to having to do this for the rest of their organizational life, and trying to pitch out and have several different vendors doing bits and pieces of this, and how are you going to get that into a lasting ability? It's very difficult.
All right. I think we got a lot of really good bits of advices here, and I like the fact that ideation became a central focus of what we spoke about today. Thank you all for joining and for taking the time to join this session. To all the viewers, thank you for joining, and we will be seeing you very soon in the next session.
Hi, Nick. It's our pleasure to have you as the keynote speaker at the Data Innovation Summit. To begin with, please tell us a bit more about yourself for our viewers and the type of work that you do.
Sure. So basically, I'm an independent consultant and educator. Probably about 70% of my work is online, now online training, as with everyone else. I was doing many in-person workshops per year before, specializing, like I said, in data visualization and information dashboard design specifically. And then about 30% of my work roughly is consulting. So I've designed dashboards for about over 50 large organizations, for example, and I've consulted with many other clients as well.
Great. So the next question is connected actually to the online workshop stuff that you do. When you teach dashboard design training workshops, what would you say are the most common challenges that dashboard designers raise in your workshops?
Yeah, it's interesting because they're remarkably similar from one organization to the next. Like I said, I've consulted for over 50 organizations. I've taught far more than that. I've kind of lost count at this point. And yet the challenges that people report are all incredibly similar. The audience doesn't know what they want. They ask for too much information on the dashboard, or there's not enough information on the dashboard, how do I make this so somebody can take a screenshot of it or print it and it's still going to make sense? And so, like I said, there's an incredibly, people think that their organizations are always unique in terms of their dashboard challenges, but I can tell you that 99% chance they are not. Everybody is struggling with this, and it's been going on for probably more than 30 years, really.
So let's go back to your Data Innovation Summit presentation to connect it with the topic. Your topic presentation will focus on the real reasons why so many dashboards disappoint users. As you mentioned in your presentation, despite the fact that books and courses on information dashboard design have been available for years, many dashboards still end up disappointing users and organizations. So what do you think this happens?
I think there's certainly a combination of reasons. A big one, though, is in terms of how people typically try to solve the user satisfaction problem, right? Because as I mentioned, the user satisfaction is typically very low. And oftentimes people will really focus on sort of the visual aspect, right? They'll try changing the colors or maybe changing the chart types or the layout of the dashboard. But in my experience, this rarely works. Usually the problems are much more fundamental. in terms of, for example, how the information is organized onto different types of displays. And so basically getting the right information in front of the right people at the right time. And so those types of more fundamental problems are not going to be solved through the more sort of visual cosmetic part. I mean, that matters, right? Graphic design and color selection, those are important, but I don't think that that's why dashboards fail. Ultimately, they fail typically because they're simply not very useful to users. They just don't answer the questions that they have. Too many clicks to actually get to the information they need if it is actually there. And so most of what I talk about in my workshops is more around essentially information organization, how to organize information onto different types of displays.
Yeah, okay, to make it more useful for the users. What our viewers will find, I think, interesting is that you're the author of the upcoming book, Practical Dashboards, which summarizes your rich experience designing dashboards for over 50 large organizations. So could you tell us what is the message in the book and what you expect readers to take away from it?
Sure. Yeah, so kind of like we were just talking about, really, like I said, after seeing so many organizations struggle with dashboards, I found that the challenge is really around how the information is organized. And so probably about 80% of the book and the workshop, which I started teaching as well, is really about that, is about how do we organize information onto different types of displays. And so the course, both the course and the book, are really centered around essentially a taxonomy of 13 different types of displays, which unfortunately everybody calls dashboards, or not everybody, but certainly most people. And yet, when you kind of look at them through that lens, you really see that a display, for example, that's going to be used in a sales pitch to persuade somebody, and it's got slick graphic design, and they call that a dashboard because it has several charts on it, really has little in common with something like, for example, a status monitoring display for a frontline worker. You know, the best practices, the design principles, you know, there's almost no overlap. And so I think that's why there's been a lot of struggle in terms of, as you know, as an industry, when we try to talk about dashboard design best practices, we're talking about all these really different types of displays. And so I'm trying to basically bring some segmentation to that and say, let's talk about best practices for specific types of displays, which people call dashboards. And then they're quite different from one type to another.
Right. I believe our audience will find it really useful and helpful if they get a chance to read it. And one last question, Nick. What's your advice for companies just starting out with dashboards? What key points they should take into consideration?
Yeah, well, I guess kind of maybe to summarize some of the points that we talked about, you know, like basically don't sort of have the knee-jerk reaction of trying to fix dashboards strictly through essentially cosmetic or purely visual means. You need to look deeper. And so it took me a long time to figure this out. And oftentimes that's what people expect me to do when they bring me in as a consultant, right? Is I'm gonna make the dashboard prettier, or I'm gonna change the colors or something. Like, no, we need to go way deeper, because you have, for example, one dashboard that's trying to do like 6 completely different things for like 3 totally different audiences. Let's start there, right?
Yeah.
We need more than one dashboard.
Yeah.
Otherwise, we end up with what I call Swiss Army knife dashboards, because they're basically dashboards that try and do everything, right? They have all these tools built in, but none of the tools are actually very good, right? Like, does a Swiss Army knife does it have a good saw, or a good magnifying glass, or a good compass? No, they're terrible, right? It's because you tried to jam them all together. And so really the starting point is again, how do we break this apart into multiple displays that are going to be purpose specific and do a better job of meeting the user's needs?
Yeah, that's great to hear. Interesting. Thank you. This was the last question for this interview session. So I would like to thank you for doing this interview with us and for being with us at the Data Innovation Summit.
Well, thank you. It was a lot of fun, and I'm really looking forward to participating in the summit in August.
Trifacta empowers everyone to prepare messy and diverse data faster. It's a data preparation platform built for the speed of modern business. Start with a flow where the elements of your data preparation project are managed. Add new data to a flow by connecting to a source or dropping in a file. Trifacta presents your data visually for intuitive exploration. Easily spot patterns or data quality issues that may need to be addressed. Preparing data in Trifacta is interactive. Immediately see how a potential transformation will impact your data to ensure you're making the right choice. In this case, we've standardized a date format. With each interaction, Trifacta offers an intelligent suggestion to guide you on how best to clean and structure your data. Use the toolbar to kick off common tasks, such as joining two data sets. Trifacta guides you to select the right common keys and how best to execute the join. All of these transformations are automatically tracked as part of your recipe. When you're finished, click Run Job. Schedule workflows to run on a regular basis for repeated production use. Publish your output to any file format, database, or application for broader use. With Trifacta, you can bring together more data faster, whether you need to prepare data for analytics, machine learning, or standard reporting. So, what data do you need to wrangle? Get started with Trifacta today.
Welcome to Data Octagon live from Data Innovation Summit. In the upcoming 20 minutes, we will be conducting a tech news, this time with Reltio. Reltio is an enterprise cloud data management solution that offers enterprise cloud master data management platform for customers and enterprises who are looking into enhancing their customer experience. It's a cloud native company with a unique approach to the market. And today with us, we have Chris Lowe, Senior Solution Architect at Reltio. We will be looking at a demo of the product and as well discuss how customers are already using this platform, what are the benefits and what are the benefits of acquiring such a technology into your enterprise technological stack. So Chris, welcome to Data Octagon. It is unfortunate that we are meeting under these circumstances, but nevertheless, I'm super excited to have this 20-minute chat with you. So welcome.
Thank you very much. We're also super excited to be here. Great to be here with everybody.
Perfect. Can we start with a little bit of an overview over the company, the platform? We were discussing about the advantages of being cloud native and about the unique philosophy that you have when you started the company.
Yeah, absolutely. We are Reltio Software, founded in Silicon Valley. And our philosophy is very much around enabling our customers to better engage with their customers. So the most urgent priority that most organizations are facing is customer experience. So we've got a wide range of great customers who are doing some really interesting things using our platform. You mentioned about us being cloud native. We are 100% software as a service. That's led Forrester to recognize us as leading the charge for the 3rd generation of master data management. We enable organizations to bring together all of their data and master that. And in particular, we drive customer experience master data management. So that enables companies, for example, like Hewlett-Packard, to track every single printer that's been sold, whether that be to a consumer, to a business. That's somewhere in the region of 1.5 billion consolidated profiles. And only our cloud native platform enable them to A, load that amount of volume, and then B, to be agile enough to respond to new marketing campaigns, to make sure they understand their customers so they can engage with them better, whether that be to generate revenue, whether that be to ensure that customer service is great. So we're enabling organizations to drive an awesome customer experience for their customers.
Perfect. And I believe that in the upcoming decade, organizations will be competing actually on the customer experience, right? So how do you make this happen? Can we go through the platform itself?
Absolutely. Just to quickly talk to one of the logo off this, so Hyperion X, for example, an insurance broker, traditionally quite a slow-moving industry, and one that's been quite slow to embrace the customer experience. Hyperion seek to radically transform the way that they engage with their customers. So that will be multiple policies, selling with them directly or through brokers, a multi-channel engagement. It's very much about enabling customers to feel as though the organizations they deal with have almost got a telepathic experience. So Gartner, for example, have recognized that we're maintaining a lead in this field, and they anticipate us to maintain that lead for several years yet. Probably the best thing to do, though, is simply to show you a customer profile and show you what Reltio enables organizations to do. So let's move over to the software. So as a customer service operative, I might come in on a screen like this and see immediately a distribution of my customers. We can see a map here, and I can see geographically where my customers are based. What's interesting is to notice over here at the top left, what I'm focusing on customers, Reltio allows organizations to master all of their types of data. So as well as customers, you'll see that we've also got, for example, employees, we've got locations, we've got products, stores. We can help you master any type of data, and more importantly, show you how that data is connected to other data. And this is all part of powering that fantastic customer experience. We've got several design philosophies that are very different to other software vendors. One of those is that as we pull data in, we immediately index it and make it available, make it very easy to find that data. So for example, over here we have a search pane, and if I wanted to bring up the profile of a particular customer I'm interested in, well, I know that her first name is Chris or Christine. So as I search, you'll see that already Reltio is prompting me. So not just for names with that string in, but also some locations and even some employees. So I know that my customer, I'm not sure about the rest of her name, but I believe she lives in Chicago, and we started to narrow it down. And I think she's got an interest in hi-fi and technology. So let's just search on Beats headphones, and there we go, straight into a customer profile. Remember, I'm a customer services operative, and I'm now looking at information about my customer. So some of this is, I guess, information that you would expect to see: name, an address, and a photograph. Notice also immediately down here, we've got privacy information. So when large organizations pull together data about their customers, it's a huge challenge to remain compliant, to ensure privacy, to ensure that these consents are followed. Reltio acts as a layer on top of those different sources, and we hold that information centrally. So we can see that Christine has opted in for all of these channels. As we scroll down the screen, we can see other information. She's got a couple of different addresses. We've got some social media information. That's fairly typical. What's kind of interesting is over here towards the right of the screen, I can see the list of products that she's bought. But I can also start to see some metrics about that. So I can see information on the different categories of products she chooses to buy. And I can even see information about the different ways that she chooses to interact with my organization. And that's really interesting. That's part of Reltio tracking not just products and sales and customer data, but also real-time interaction information. I can see that she uses the mobile app a lot and doesn't really use the call center very much at all. But I've actually got more information inside this as well. I can see that Christine has opted to refer various friends and families. So now I'm starting to build up a relationship of who Christine is connected to. And that helps me understand my customer better. Down here, I can see the names of my employees, my sales advisors who've worked with Christine to make sure she gets great service. Down towards the bottom, I can see stores that she's been to. And then this pane here, recommended actions, this is really interesting. This then is where Reltio has taken all of that information and started to use machine learning to suggest or recommend the next actions. The first of those is that following an email campaign, we've realized that she's got a great interest in running shoes, in particular Nike shoes, and there's a likelihood that she'd be interested in a discount offer on that. So we've decided to send that offer out. Also, we can see that she's beneath that, she's visited a store. So now we're using Reltio to join together her web traffic, her use of the mobile app with her visits to physical stores. And we can see that she dropped by a store. So we're just going to send up a courtesy email to see if there's anything that we can help with. So there's a lot of information here. Some of it is fairly typical address type information. Some of it is more interesting, which is the products and the people she's connected to. This is a finished screen as a customer services operative. Now let's step back and see how Reltio built this screen using some of those quite unique design philosophies under the hood. So let's step back and see how we join all of that data together. Reltio sits on top of all of your enterprise systems, pulls the data in, and automatically builds a graph just like this. And there's a lot of information here. There in the very center is Christine, and I can see around her different pieces of data. I'm just going to quickly take some of these off just because that makes the screen slightly easier to read. So I can see, for example, she's connected to Andy DeFresney, and he's an advisor. So he's somebody who's established a great relationship with her, making sure she's getting a good customer experience. I can see also, for example, that she's connected to Michael Brown. That's her husband. So that's some information she's chosen to share with us. I can see that she's been connected, for example, to a couple of next actions. And as I start to bring in other pieces of data, I could see the different stores that she works with. I can see the products that she's bought. And we build this automatically. So notice that we're showing relationships between a customer and between some products and between some employees and between some predictions and possibly relationships back amongst those as well. So this gets built automatically as we bring data in. But where does the data that supports this come from? Let's take a step back again. So one of the key differences is that Reltio in real time will hoover up all of the interaction information between our organization and Christine. So that might be everything from an outbound email campaign through to she's chosen to share her social media details with us. Down here, I can see that she's made a purchase. So I can see there's a particular Ralph Lauren product she's bought at a physical store. And I can see also she's raised a support inquiry about a different category of product. So my customer service team will be working with that. So we pull together here every touch point between our organization, between my sales organization and Christine. And that helps me ensure that I serve her better, that customer experience is truly great. But how did the data get here into this set of interactions? Well, let's step back again and see how we join all of those sources together. So this is a fantastic screen. Inside this single screen, I get to see the whole of the data lineage, all of those different data feeds being brought together in real time to help me build up a profile of Christine. There's a lot of information on this one screen, so let's break this down. At one end of the timeline, I guess, top right here, we have a color-coded key of how different data sources have been brought together. And that color coding is important because I'll follow those pieces through the process. Over here on the left, I've got Christine's profile. So it's got this slightly light blue background to it, and I can see some of that information from the profile screen, names, address, etc., etc. So let's see how those different data sources are combined. So for example, using the color coding, I can see that we've got a point of sale from the physical store. So let's lock that, and that's in pink. And I can see this pink data thread flows all the way through. And I can see that from that point of sale, we captured Christine's name. I can see also that we captured various other pieces of data highlighted in pink. At the same time, I can see that she also chose to share some LinkedIn information with us. Again, that's something she's given permission to. I can see also that's supplied, for example, her name, and some other pieces of contact information, again being totally compliant with her privacy preferences. So the color coding shows me how the different data sources feed through. But how then do we determine which piece of information is going to be used to build her profile? This section here in the middle is what we call survivorship rules. So different pieces of data come through and we evaluate to see which piece of data is going to get stored. So let's use the example of Christine's first name. So here I can see that I've got 6 different data sources, all with different colors. I can see 4 of those data sources supplied a name of Christine. I can see that one of those supplied a name of Chris. And I can see that one of those actually had the first name completely missing. It was unknown. So based upon these 6 different values, which one will we bring across? Well, my organization has decided that's going to be a recency rule. In other words, the most recent value to come through is the piece that will be saved on her profile. And it's very, very easy to configure these. You can see examples of other types of rules here. So I might choose to use the oldest or the minimum. Down there at the bottom, I could use custom class if none of these built-in rules work. It's very, very easy. I don't need to cut code at all as a data steward to build up these pieces to then populate the screens that my customer services people will see later. To show you some examples of some other rules, I can see that for the middle name, we've used frequency, so the most frequent value. And I can see that for addresses, we've chosen to aggregate. In other words, we'll just keep adding extra details onto the list to build up a fuller view. All of this is possible without writing any code. Final example of a rule is a source system. So for a full name, we've chosen to base that on a source system. And here I can simply drag and drop to give different source systems a different priority. So I can see, for example, my call center system is quite high up the priority chain.
Welcome to Data Octagon.
Of that survivorship rule. That's a very different philosophy. Other systems typically will only let the winner through and will discard everything else. Why is this important? Well, if I work in compliance, this in a single screen enables me to explain clearly to a regulator, for example, how a set of values were arrived at. If I'm going to supply the data to a machine learning algorithm, this allows me to justify or to explain the values that flow through. If, for example, we later realize that there's been a mistake made and it's actually two different Christine Browns, because I've got all these values, I can split that out. I can perform an operation known as an unmerge, which is to split these back out. And again, traditional first and second generation MDM don't allow you to do that. Final thing to show you is that as everything goes through our system, we track all activity. So I can see here some edits. I can even get down to see individuals viewing profiles. We track this automatically, again, just to make sure that compliance and security are entirely happy. That's a real quick view of a consumer. If I may, I'll just take 2 minutes to show you a B2B customer as well, because there's some slight differences that I think might be interesting. So let's move over. Now I'm a customer service representative for a different company working with B2B customers. This is Caterpillar. Much the same layout to the screen. It is completely configurable. Allow me to show you two other things. The first is this Get Company Details button. So by clicking this, that enables me to enrich my customer profile. That actually is a call out to Dun & Bradstreet. So that allows me to retrieve other information. For example, I can see over here on the left, I've got the DUNS number. I've got information such as that customer's revenue, even some of the organization type and classification codes. That's been supplied by Dun & Bradstreet. In fact, I can even see here I've retrieved the Dun & Bradstreet hierarchy for my customer. Notice underneath that, though, there's a different hierarchy again. So my organization, as it works with Caterpillar, I have different teams. So whereas up here I can see that this particular customer is, if you will, in the middle of the tree, it's a mid-level node in the hierarchy. Here I can see that actually I regard it as a core customer, and I've got separate teams working with it. In other words, multiple hierarchies are possible in Reltio. Notice also when we track those relationships between customers, I'm not just now tracking with their contacts and with my account team that work with them, but even with their suppliers, in fact, even with their competitors. And all of that will be shown on that relationship graph. So it's a very, very powerful way to enable customers to work with their customers.
So obviously this is a finished product of the entire work that needs to be done, and this is basically how all the demos, right? So how quick can a customer come to this level when they can have like this 360 degrees view on a customer that you just showed us?
So this is another great advantage of being cloud native. It's very, very quick and easy for us to spin up an environment for a new customer. We have a program which is a 90 days to value program. So that's from a standing start to get initial data in, get a new environment up and running for a customer, and for them to start to find value in working with their customers. So there's many advantages of being cloud native, not just the fact that we take care of all the administration and running the systems for you, but also the fact we make it very quick and easy to spin up new environments. So 90 days is not atypical for our customers.
So looking at the one of the challenges in this area, especially on data management and master data management, it's always that you have in larger enterprises, telecoms or manufacturing, doesn't matter. They live in this multi-complex technological environment where you have hundreds of systems not communicating with each other and etc. How difficult is this, and how basically this platform can be integrated in such a technological stack, let's say, or environment?
So this is a challenge that we help our customers with all the time. They've often grown through acquisition. They've got multiple siloed data sets. We make it very easy to connect Reltio to other data sources. We have a very open set of APIs. We use JSON. That means we've got a very open set of connector frameworks. In fact, everything that I've just shown you inside the web browser makes API calls. So everything I've just shown you visually can be automated. Once we do that, as I say, we are a cloud native solution. So we take advantage of a lot of the underlying platform capabilities. That doesn't just enable us to make it easy to connect, but it makes us easy to perform. So we can start to work with your data in real time. And at the same time, we address a lot of the security and privacy concerns. So two large markets for us are healthcare and financial services. They're two highly regulated industries. We have HIPAA approved environments. So that again gives our customers and prospects the reassurance that their data, their customer data, will be secure and will be made available for them to start to get value from very quickly.
You also show that it's both compatible to B2C and B2B companies, right? And in a B2C environment, this and you had like a mixture between internal and external data sets. So we have everything from Pinterest to LinkedIn to internal ERP information and data. So, I mean, for a B2C company, and nevertheless for B2B, this can be a huge amount of data. So how can the platform like this basically handle such quantity of data?
So again, part of that is our cloud native infrastructure. So it enables us to scale very to huge volumes. We mentioned earlier Hewlett Packard. That's got 1.5 billion consolidated profiles. In fact, in HP's evaluations, we were the only vendor able to support such volumes. Another example of a customer doing great work is Subway. So globally, they are the world's largest single brand restaurant chain, the largest restaurant operator. They run their entire loyalty program through Reltio. So just two examples of customers running huge volumes through. Behind that, it's not just about the volumes, it's also about the performance. So our design philosophy was to, the traditional relational data model simply doesn't work. So for us, we've embraced a NoSQL data model. We combine that with our Reltio graph, which is updated automatically. We combine that with using Elasticsearch to make data very easy to find. And the final thing to talk about performance is not just performing the calculations very quickly, but enabling our customers to work with their customer data very quickly. So for example, they need to track some new metrics about their customers. In the old world, master data management world, that would involve adding new columns to a data table, dropping and rebuilding the schema, for example, recreating views. Our data model makes that very quick and easy. I wouldn't be exaggerating if I said that's the work of a few seconds or minutes. Why is that important? Because as the business world changes, the pieces of data you need to track, to work with your customers better, will continue to grow. As you move into the world of using AI and machine learning, these technologies devour data. They really like wide data sets. Again, Reltio's got an unlimited width of data. So all of these design philosophies come together. And again, that's why Forrester recognizes us as leading the charge into the third generation of master data management.
So scaling up to size of bigger sizes of volume of data is not a challenge though. Good. So lastly, how are you represented in Europe? Where can organization reach you at? Are you represented in the Nordics?
Absolutely. So we got a European office. We've got existing customers in the Nordics already. So our website obviously is www.reltio.com. We would have loved to come to Stockholm to meet people in person. We got a not just a sales presence, but also a customer success and a technical account presence in Europe. So the team here are ready and very keen to speak with prospects, not just to explain what we've done for other customers, but to understand your requirements and think about how we can take customer experience into new directions. This is a huge challenge, not just in the current coronavirus impacted world, but the organizations typically fall into one of two camps. They're either leading the charge with embracing customer experience, or unfortunately they're lagging behind and needing to catch up. So our goal is to enable all organizations to deliver an awesome customer experience to their customers.
Perfect. Thank you, Chris. Thank you for everything. And yes, let's continue. Thank you.
Wonderful. Great to be here.
Thank you. Bye-bye.
Bye.
Hi everyone, my name is Josefin Rosén and I work as AI and Analytics Advisor at SAS Institute. We are very happy to be one of the partners of this year's Data Innovation Summit. You will find us in the program during day one, where my colleague Wendy will talk about how to accelerate the analytics lifecycle. You will also meet me during the interactive technology and practice sessions. If you have any questions or just want to get in contact, please reach out to me. You will find my contact information below here.
Welcome everyone to Data Innovation Summit 2020. The panel we have today is how to adapt your data strategy for the rise of artificial intelligence in business. And I have three really great guests with me today. Please introduce yourselves. Chris?
Hi, I'm Chris Hillman and I'm the Data Science Director in the EMEA region for Teradata.
Excellent. Yuan?
Hi, my name is Johan Löv. I work for Microsoft covering global accounts, specializing in data and AI.
Excellent. And Pelin?
Hi everyone, Pelin Özbozkurt. I'm the Data Science Director working for Colin EMEA.
Excellent. So let's get it off and get started right away. Why don't you guys tell me a little bit, in your experience, what the identifiable characteristics are of a modern data strategy? What are the things you can point at and say, these are things that you see in modern data strategies? Chris, what do you say?
Yeah, okay. I mean, there's certain things that are, standard, like governance and privacy and all of this kind of thing. But, I think we see now that you have to take into account the advanced analytic processing needs as well. So it's not just a case of the old world of like standard reporting. You've really got to start looking at what those needs are for the advanced analytics, and that includes the technology capabilities. And I think the other thing that we see a lot is having to take account of how literate people are with the data. So there's a key thing that's data understanding, and if you don't get that right, it's not just a case of serving up data and saying it's there, you can use it. You really have to understand how much people understand of the data before they can use it.
Right. Yuan, what do you say? Data literacy is one of those topics. Are customers able to explain what they want when they're talking about what they want from a modern data strategy or a modern data platform?
Yeah, I think I would start from a different angle. And we see a lot of discussions around setting up the modern data platform in a different way from a governance perspective, moving away from the the more traditional operation model with one central team being responsible for ingesting everything into one data platform. We still see the one data platform approach, but a lot of organizations are looking into a more federated approach, or what sometimes is called the data mesh approach, where you break up the central approach and have an approach with a combination of data publishers being responsible for onboarding data to the data platform, and data product develop teams being responsible for creating the contents and the applications. And what Chris was talking about, the ability not only to build BI solutions, but also to create advanced analytics on top of it.
Does that mean that an advanced AI and analytics platform is very much defined by the tech stack that it lives on? Or is it as much culture and other things?
I would say it's a combination. The change in the operation model and the movement into the federated data mesh approach, I would say it's an organizational one, but it's still a data platform approach, and you still need to have a platform to build things on top of. So I would say it's two things really.
Pelin, what would you say are the key characteristics of a modern data strategy?
Well, I guess in order to answer that question, maybe we should ask, what are we going to do with the data, right? Data is going to be at the center of business decisions, and business decisions today must be flexible, agile, and innovative in order to keep up with the challenge that we are having today. And I believe that should reflect to the data management data strategy. So, for example, think about flexible. So I think that's the most important critical feature that we should have, and it refers to many different things. For example, flexible data strategy could be something related to cloud adoption. So we see, for example, some of our customers have completed their cloud journey, and they are doing all this data management strategy in cloud. Some of them are still at the beginning of their journey, and they need some hybrid solutions. I think it should be connected way in terms of getting more value out of it. And I think another important characteristic is having an agile data management, that you don't need to think about where to store data, how to get data, which type of data you have. And these are all connected to creating an innovative solution. So I think these are all the keywords that are connected to each other that should reflect to data strategy of organizations.
Right. Well, I think a lot of companies now are hearing that they should be investing in advanced analytics and AI, and some of them are having trouble verbalizing exactly what they need. Sometimes it's because they say, we don't really have enough data to do anything interesting. Or even many people on the panels today are saying, you don't really need advanced AI. Linear regression is enough to solve most problems that your business faces. Chris, what do you say to that? Not having enough data and you don't need advanced AI. I mean, is advanced AI a necessity?
Yeah, I mean, on the regression can do most of the stuff. I mean, as data science professionals, we do have to walk a very fine line between being visionary and being innovative and talking about the future, but also keeping an eye on what actually makes money and what works. So there is a very fine line there. But on the, and you have to just test things. Things have to stand on their own 2 feet. You can't say this is better because it's newer. It has to, the results have to be there, which often they are for newer techniques. But on the data availability, I mean, there's a very different between a data strategy and a data architecture, so the strategy is very much about use cases and business needs and things like that. And I think if that drives it, then the data will be found. I think if you do it the other way around and try and build it and they will come, doesn't really work for these kind of plans.
I think that's very nice, and we should frame all these great sentences that we hear today, that if you come up with a good business case, you'll find a way to find the data for it. Johan, what do you mentioned federated data stores and other things. Can you give an example of some customers that have been adopting, or what verticals perhaps have been adopting these techniques and finding use from them? Johan.
Yeah, so I think the most of the use case I've seen are from since I work in the retail sector, so of course it's from the retail sector, but actually also from Microsoft internally. We have adopted these kinds of more flexible ways of hydrating the data lake actually, yeah. But I think Microsoft is probably pretty advanced, I would say. The use cases I've seen, I think. Actually,
would you say that you're very cloud-centric with regards to your advanced analytics initiatives, or is it equally as much on-prem?
No, when I look at my customers in the retail sector, and when I look at internally, it's a cloud first. I mean, looking at the need to store, when you look at retail, there is a lot of data when you need to do data science, and I mean the data lake storage in the cloud is pretty much it's hard to beat that actually. And when it comes to Microsoft internally, we analyze for an example, all of the Azure telemetry in detail. Yeah. So I would say from my perspective, the cloud is a necessity. It's not possible to do it on premise in a flexible way, actually.
That's very nice to hear somebody say something. Yeah, it's very nice to hear somebody say it that concretely, because a lot of times there's a little bit of this and a little bit of that, but it's fun to hear somebody say something like the cloud is a necessity, because I think a lot of people are looking for guidance. One thing that right now is very transformative in my mind is deep learning. And it's because it can solve types of business problems that you haven't been able to solve before. And that's why AI is really seeing a resurgence now. And yet a lot of people are still talking about what you can do with linear regression or with decision trees and that kind of thing. And these are old technologies. Leo Bremen made random forest in early 2000s, and the other techniques we've had for half a century. So Pelin, in your mind, is there something really different happening that's making people suddenly be so interested in statistics? Or is it really deep learning that's driving all these things? Where is the balance between these really cutting-edge AI techniques and these more fundamental techniques that companies are now thinking maybe we should have this in place? Have they not had it in place before? Or how do you see all of that?
Well, I see a combination, to be honest. So sometimes with some use cases, some project, we really need to go back to the basics. So regression might be your rescue technique in some of the cases. But if you are interested in some more advanced, like image recognition, voice recognition type of techniques, then it's all about deep learning. It really depends on the type of data as well. Well, I guess the reason why data scientists are getting more interested in deep learning is the latest investments. Because I'm a statistician, and I know that traditional statistical models are sometimes, it's hard to get the accuracy when you feed the algorithms with more data. And today, with the AI investments, we have lots of data coming from everywhere, and data scientists naturally want to use that data to improve their outcomes. And that is where deep learning comes into the picture. So we can train the model as much as we want with more data, and we can just achieve more trustable, accurate models. So that's where the new investments are focusing on these days, and it's so exciting. But still, I believe, as a theoretical statistician, to be honest, it should be a combination in real life.
For sure. Let me follow up with one question, and that is, I think a lot of customers say, yeah, it's cool and all, this new advanced machine learning, but it's too advanced for us. We don't have that complicated business. Do you feel that these advanced techniques apply equally to all verticals, or are they more apt to some than others? Like in banking, where they've been doing statistics for a long, long time, are they prone to jump to the next level, or is is there a difference across verticals in terms of how ready they are to adopt these new techniques?
To me, that question is.
Sure. Yeah.
All right. Well, I wouldn't divide the industries in order to answer that. I think it's more related to what they want to achieve. So banks, for example, they have been doing data science for many years, but if they are looking for innovative solutions, then that innovation might either come from the data sources or it's the machine learning techniques that they are going to apply to the same data source. So it's just about what they would like to achieve. But for some industries, maybe I could say there are some regulations coming with deep learning. They may not be able to use that, kind of black box techniques. But other than that, I think it's all about the data science life cycle, that if they want to try new things, they will achieve new models.
Yeah. I think when trying out a lot of these new techniques, it's very easy for computer engineers to get excited and try it, in their playground, on their workstations, on spare machines and that kind of thing. Chris, Teradata has a legacy of doing statistics and very enterprise-ready solutions for advanced data analysis. How do you see the balance between what we've seen before, but are seeing again, that people are using these sort of homebrew tools, and how they live next to the solutions that Teradata offers? Are they supposed to be separate, or should they be done together?
Yeah, that's really interesting, because, I know it's really generalizing, but we kind of separate the life cycle into 3 different parts. So there's everything to do with data, there's everything to do with model fitting, and there's everything to do with deployment, production. And, the middle bit, the model fitting, the training, is the bit that gets focused on so much, because it's the interesting bit, it's the magic, isn't it? and to be honest, that's the bit where we feel the data scientists should be pretty much free to use the tools they want to use, because in one team you'll have an R guy, a SAS guy, a Python guy, and forcing them to use a tool they're not familiar with is just ridiculous, because that's their skills. So I think the way to keep the control and the governance is to have, the data part in an enterprise platform, and then have some, we call it analytic ops, but I think most people say ML ops, machine learning operations. Have some system of pushing stuff into deployment on the deployment platform. And then you get the best of both worlds. The data scientists can have their playground. And then it also gives you some kind of accountability through the process. So you know where the data came from, you know where the production was done.
So it needs to be both together, in other words. It's not an either or.
It has to be. It has to be. You can't have, the Wild West on the data side. And then again, you can't have tight governance on the model training tools, because there'll always be, these are smart people. They'll always find another way of doing it if you say they can't do it that way.
Yeah. Yuan, I'm very curious about, Microsoft has been deploying a lot of software as a services that build on these sort of open source and hacker tools, as I call them, Kubernetes and a number of other things, and you're putting them on the cloud. What sort of mindset do companies need to have in terms of the cadence of adopting these new technologies and being ready and knowing that they will have to reinvent themselves every X number of years? Because I think many people are hoping that they can make one investment in a tool and then keep it for 10, 15 years or something. And that seems unreasonable, or maybe not. What are your thoughts on that? Should people invest everything in Kubernetes as a way to virtualize their services and expect that to be the virtualization platform of the coming 10 years, or should they have another mindset?
Well, I guess the mindset that you need to have is that it will definitely change. It's a extremely fast-paced world with a lot of innovations in it. So, from a Microsoft perspective, we have invested in both the Spark technologies with Databricks and also the pipelining with Azure Machine Learning Services that actually helps you a bit with the process of doing the data pipelines, putting things into production a bit smoother. So I would guess I would think that the DevOps parts are definitely here to stay. There will be a lot of frameworks. There are a lot of frameworks, but I guess that you will need to worry less about how to set up your Kubernetes cluster in the future. So that's where I think the innovations are going, actually.
Is there a way of working that makes it easier to make that transition? If you know that you're going to have to reinvent yourself every 3 years, is there something you can do to set yourself up for not making it as painful every time you have to transition? I suppose you'd say that using the cloud makes things simpler. Is there anything else?
I mean, even if things change, so some things are. I mean, the model are still there, and I mean the coding is a bit is a bit similar. So from a developer perspective, I think you will still have the flexibility and the openness of the platform to choose if it is R or if it is Python. And your development environment. I think the things that will change is the way things are deployed and automated, and you shouldn't need to worry about that anyway. So I think that's one way to look at it, I would say.
Right. All right. Well, I think one of the things that these large platforms are doing is making it not only ready at hand for data scientists, but also making the data available to decision makers and operational information workers. Pelin, I'd like to hear your thoughts on, people have been referring to this as data democratization for a long time, making these tools and data available to the people in the organization readily to accelerate. Can you give an example of where that's not been really done the correct way, or where the outcome has not been as intended? People really love to hear examples of where you can make mistakes so that they can avoid them.
Well, first of all, I should say I agree with you. I mean, it's all about, in order to create innovation, you have to work as a team. And that team has line of business people, data scientists, data engineers, and they have to reach out to the same set of data, which is actually called data democratization. But there are some challenges with that. The most important one is probably security. So we have to keep the data as secure as possible, and integrity. So it should stay as the same. That's some of the issues we are having in real life. I couldn't give you a real example here, but just the generic examples maybe I could mention. Another one is maybe as dangerous as the security is to come up with their own insights coming from data. If you don't know what to do with the data or what the data really means, then that creates some issues that might affect the strategies from scratch, which is a problem. And I think the way to deal with it is to create the secure cloud platform, and that's one of the things what we are trying to do with Oracle.
Right. I think a lot of these practices are really coming and starting to mature right now. The people are finding that these ways of collaborating are giving benefits and are willing to share this type of information with each other. Chris, I'd like to hear, Teradata has a long and esteemed history, and in the past decade has incorporated a lot of what we probably now refer to as the big data platforms, meaning Hadoop and a lot of those technologies. What role do you see those 2010 technologies in today's 2020 AI landscape? Are they still relevant, or have we moved beyond them, or have they become sort of scaled down and with the bare essentials remaining that provide value? What's the story around that technology with respect to AI and advanced analytics?
Yeah, I think it's something that Johan said about the data mesh. I mean, we see that there is a place, it was never all about one thing fits all, so if you want to do advanced use cases like image and video recognition, then you need these platforms to store that kind of data. I think we also see it for kind of the kind of deep history. If you've got a company that's got 20 years worth of transactions, like a retailer basket data, you don't need to keep all of that in a data warehouse system with access. So there's definitely a case of the English expression is horses for courses, but I don't know if that translates. But it's this data is fit for that because of what it's actually used for. I think what we don't see the big data platforms so much for is the processing. I think that's what's changed to me, is that if you go back 10 years when there was the big hype, it was that they were going to take it. That's where all the processing was going to be done. And I don't see that so much now. I think, I think the storage is still valid.
Right. Yuan, what do you say? I mean, Microsoft has a lot of services that break out that type of functionality that used to be a part of these complete big data platforms. Streaming now is usually viewed separately, hosting is viewed separately, and that kind of thing. So what function do those old big data platforms, I shouldn't say old, but those packaged data platforms have in today's landscape?
Well, I think there were a lot of interesting innovations that we will most definitely take with us. Chris mentioned the data lake, of course, with the bottomless storage and extremely cheap. Spark engine with better performance than the Hadoop. That is one thing that's definitely still there and will be there. And of course, Kafka for streaming. If to pick three things.
Are Spark and Kafka still big players in your experience now?
Yeah, I would say so. I think from Microsoft's perspective, we're trying to bridge the worlds of, I think maybe that was what you were after, the world of big data with the world of data warehousing, with the Synapse offering, where we have a combination of Spark engines and SQL data warehouse engines and SQL on demand. So trying to melt it into to one experience on top of the data lake, both for data scientists and for BI and data warehouse developers, as well as for data explorers.
Right.
So, but I mean, the Spark is there, and the maybe not Kafka yet, but who knows?
Soon. Pelin, in your mind, these new breeds of tools, the 2020 tools, I suppose, if you will, that machine learning engineers and others use, are they slowly being incorporated into the standard offerings of Oracle, or do you see that they should be sort of kept at a sandbox place, and then you have the enterprise solution as a separate sort of track?
Data science and data management from a platform perspective. So we believe, I think that's the first answer to big data related question itself. We believe whatever we define the data is either data lakes, Hadoop, NoSQL, data warehouse. It should be the real foundation, accurate source that will feed the data science models. And in Oracle, that's what we are trying to do. We are offering a flexible platform for data scientists. They can scale up object storage and GPU if they're interested in deep learning and write their own codes with Python, TensorFlow, R, SQL, whatever they want to. Or they can create a data warehouse instance and use Oracle in database machine learning capabilities, or they can try both. So what we try to do is really create the best foundation to achieve the robust machine learning in production, which actually do not fail.
Right, all in one place. That sounds good. Well, we still would like to end with a teaser for our audience. So, Chris, if you would think of what the next up-and-coming technology that you guys have your eye on with respect to AI and advanced analytics, what would you say that technology is?
That's a good one. I think, the one thing for me that needs to really be ramped up is the labeling, auto labeling.
Okay. Automatic label to help machine learning practitioners get their hands off that sort of tedious job. All right, Yuan, what about you? What do you think is the next up and coming big thing?
Well, I actually think that's an interesting area. If we are talking about the same thing here, I think some people call it trying to create a feature store. I think maybe that's what you're after with auto labeling. I think that is an area where I guess that we will see a lot of innovation and maybe frameworks coming up in the near future. From another perspective, and the things that I see a lot of my customers, that is actually a lot of accelerators when it comes to creating the foundation, or what we talked about in the beginning, the data mesh or the data lake. Having accelerators that actually support data publishers to hydrate the data lake without writing an ETL code. That's an area where I think we'll see a lot of improvements soon.
Cool. Pelin, what do you say?
Well, I have two things that I cannot decide which one I would, say first. But I think the first one is using deep learning in a more unsupervised way to probably increase, maybe that match with Chris' point, to increase the labeled data, because we don't have the starting point most of the time when we try to do machine learning or deep learning. Right. And second one is matching with Johan's point. It's more like better feature engineering, because when we start with real projects, we start with thousands of attributes, which we don't know which one will be more important. So if we can improve that process, maybe probably with AutoML or better feature engineering, that will be really useful.
Mm-hmm. Cool. Feature, that's something we've been hearing a lot in the talks today, is feature engineering, feature store, federated learning, and that kind of thing. It's neat to hear it from all of you. Thank you very much for the session today. It was interesting talking to you. I hope the audience took notes, and I will be seeing you all at the next session. Thank you very much.
Hey there, welcome to Data Innovation Summit, and welcome to Microsoft. If you want to learn about the latest and greatest within the data and AI space, congrats, you're at the right place. During these 2 days, Microsoft subject matter experts will share their expertise and best practices on how to leverage data and AI to engage customers, empower employees, optimize operations, and transform products. You will also hear directly from our customers and partners about their first-hand experience making data-driven innovation happen on Azure. Why Azure, you might ask? Azure is the most trusted enterprise cloud that enables you to innovate at scale and innovate with agility. We offer a wide spectrum of technological innovations. It's not all about speed, performance, and scalability. Azure is also the industry leader to empower data scientists and developers to innovate responsibly with our Microsoft AI principles and responsible ML capabilities. So go ahead and embark your data innovation journey with Microsoft.
The moment an infant opens its eyes, the building blocks of creativity begin to take shape. Everything we see, hear, smell, taste, and touch determines how we think, feel, and create. It's how our minds work. It's what makes us who we are. Just by tapping out the right sequence of keystrokes, we breathe life into the void. The internet connected the minds of the world, and overnight the only limits to what we could make were the scope of our imagination, the physics of the transistor, and the speed of light. Or so we thought. While our minds fluidly process a complex and ever-changing river of information, our programs inhabited a world of boxes, rows, and columns. No incremental improvement, no workaround, no framework could cut the gridlock that entangled our code and choked our progress. It's a problem you can't unsee, and solving it became our defining obsession. So we broke the boxes. We made something new, flexible, intuitive, fast. We built it for the curious, the driven, the playful. Those who see an unsolved problem and dare to create a solution that doesn't fit in any box. We built it so our ideas can reach the world faster, so we can meet the needs of tomorrow's customers better, so we can move as fast as we think. At its core, a development experience that makes data natural in every context, reducing the friction between imagination and implementation. An adaptive, intelligent platform to serve any workload, from the most demanding transaction processing to advanced analytics to rapid prototyping. A modern foundation to build the future on that allows data to vary, to change, to flow, to adapt to whatever happens next. Because we did not come this far to stack boxes. We were all born to create.
Welcome to Microsoft Tech News. My name is Joachim Ahlström, and I'm happy to be here representing at Data Innovation Summit this year. I'm going to talk about some new announcements we have. I work as a cloud solution architect with focus in AI, and my role is to help the customer to leverage the most out of the AI technology. Hence, some focus will be surrounding Azure, if that's okay with you. We have 20 minutes, and this is the cherry picking that I've been doing for you, and I hope this can empower you to do amazing things. I want to talk about Azure SQL Edge, which was announced at Microsoft Build, and I want to talk about Cosmos DB with its new features. And I want to talk about cognitive services, our pre-trained AI, which is getting better, and we have new services. And I want to talk about Azure Synapse Analytics, our evolution of Azure SQL Data Warehouse, and some new features here. I want to talk about machine teaching. You probably heard about machine learning, but what is machine teaching? Azure Stack Hub and Azure Arc, those are also amazing news and capabilities I want to speak about. And last but not least, I want to mention a customer use case which is surrounding AI and ties different technologies together in a nice way from Scandinavian Airlines. So let's begin. Azure, we are building the world's computer with 61 data center regions, more than any other cloud provider. And we help customers to innovate from edge to hybrid with big data and AI. And now we're building an AI supercomputer. What does this mean? This will help us tremendously for our own family of large AI models. The Microsoft Turing model is very large, which has helped us to improve many different language understanding tasks. But also, you will have one of the top 5 publicly disclosed supercomputers in the world available in Azure to train your extremely large AI models. Let's look into some more news. Azure SQL Database Edge. Here we have Azure SQL Database, but it works on edge or in the cloud. You can have native data movement to Azure for long-term retention of data. And we have added features and functionality such as time series analytics, which is built in, streaming analytics, and built-in AI for anomaly detection, things you might want to need if you have an IoT use case. And it has extremely small footprint, and it runs on both x64 and ARM64 based architectures. Some news about Cosmos DB. You're probably familiar with Cosmos DB. It's our turnkey global distributed operational database, elastically scalable. It's multi-model. You can have a graph model or a NoSQL. It has 5 nines SLA uptimes, and you can have less than 10 millisecond latency for both reads and writes, up to the 99th percentile, if I'm not wrong. It has a guarantee of low latency, high scalability and availability, and now also serverless. This is great. Instead of auto scale, if you don't have an activity at Cosmos DB, you won't have any cost. This is perfect for development. If you close your laptop, computer, go home for the day, you will have no charge for the Cosmos DB. So it goes down to 0 nodes instead of earlier where it kept 1 node to keep it alive. It's also great for productional burst workloads, of course. So if you have burst workloads, you have 0 cost in between the bursts. The other feature was a request from our customers where they wanted to have more granularity around recovery. And now we support point in time instead of snapshots. This means no data loss. If wrong data is loaded, or if you do accidental writes or deletion of crucial data, you can go back to the point in time where you want with a better granularity. And the data changes will be kept for 30 days. More announcements. Well, let's look at some AI and cognitive services. This is our pre-trained AI. Before this, I want to talk about Microsoft AI in general, our breakthroughs. We compared our AI in different areas such as object recognition, machine reading, and so forth. And here you see 4 areas. And in 2016, we met human parity in object recognition, meaning our AI and a human being in general scores the same at a test. And the human being scores 96% accuracy here. And the interesting thing is, if you look at the machine translation, we met human parity back in 2018. And the interesting thing, I believe, is that humans are not great at translation. You can see the scoring is 69.9%. So what happens when our AI becomes even better than the human being in general? Well, it gets more powerful as a supportive tool. And in April 2019, we were first again compared to our competitors and match human parity in conversational Q&A. So we're constantly driving our AI to be better and better. It is evolving rapidly. And cognitive services is a package of multiple services such as translation, object recognition, speech, and so forth. And we saw growing demand in our speech services. We had use cases requests such as call center transcriptions. They want to transcribe the audio to text. They want to have speaker recognition. They want to analyze if the call was good or bad, and so forth. And other use cases such as media and entertainment or automotive, where you want to control your media equipment in your car. Maybe you want someone to read your latest email for you with a computer voice. What we did was to improve our speech services in multiple ways. We improved speech to text, where we added 27 new locales, 27 new languages, and we increased the accuracy of speech to text with 30%. That's pretty amazing. And we also added Speech Studio, as you can see here. You always have our baseline models to go from speech to text. We have a baseline model. But here in Speech Studio, you can tailor this and customize this to your needs. You can have your vocabulary, your industry-specific terminology, and you can retrain them all to get even better, to have your private own version of speech to text. What we also did with our base model was from neural text to speech, the other way around, when we have computer voices.
We added 15 new voices, and the pronunciation rate was reduced by 50% for 13 languages,
enabling you to benefit from a broad range of natural sounding voices for in-control car steering or read my emails and so forth. So this is certainly something to check out for sure. It's exciting, and it has a lot of good use cases. Another cognitive service is Form Recognizer, and this is an AI-driven OCR service. This means that if you have scanned PDFs, you can extract the PDF information into digital JSON files. So you can read the values and the data from the PDF, and output is a JSON file. So this is great. Instead of someone reading PDFs manually and putting them into an ERP system, you can automate this process. So if you have a lot of invoices, you can digitalize them easily. If you have receipts, we have a pre-trained model, and we also have a custom tooling where you can create your own custom model based on your type of documents. And with this, it only requires 5 documents to train on. So that's good, that's great, but what's even better is that if you have a PDF with table information, this will be kept into the JSON file. The structure of the table is kept intact in the JSON file. You will have columns and rows and so forth. So it's a great service. And another addition to the family is the acquisition of Softomotive, which is an RPA company. And this strengthened our RPA offerings, where we already had Power Automate, which can be combined with Form Recognizer to orchestrate the process of extracting and inputting this to another system also. 50 billion connected devices by 2030. That's an interesting figure. This is the expectations. 90% of the data is created the last 2 years. This is fact. And I always have heard this number, 70% of the data that we are collecting are never actually analyzed until now. Because now we have the capabilities. We have Azure Synapse Analytics, an evolution of our Azure SQL Data Warehouse, which also can analyze seamlessly with a big Azure Data Lake with unstructured data, combined with structured normalized data as we are used to, and also embedded AI on top of that. So we have these capabilities where we can use big Spark compute to analyze both big data and traditional data warehouse data, and AI on top of this. But the new feature I was most excited about is Azure Synapse Link. This means that you can have live streaming without any ETL for operational databases to be analyzed directly. It enables customers to get insights from their real-time transactional data stored in their operational database with a single click. You don't need to define and set up an ETL pipeline. You have this built in the Azure Synapse Link feature. Right now, we support Azure Cosmos DB as this operational database, but in the future, we will support more database engines, such as Azure SQL DB, of course, Azure Database for PostgreSQL, for MySQL. Another interesting area is, of course, machine teaching and the Bonsai acquisition, the Bonsai product. Bonsai brings intelligence to physical systems. What it does mean is that you can teach a robot or a machine how to do a task. For instance, the Bonsai team were teaching a robotic arm to stack blocks on top of each other. And this was actually 45 times faster than Google's DeepMind. And why is this? Well, Bonsai is built on deep reinforcement learning algorithms in simulated environments. We don't need a lot of custom machine learning model. We use reinforcement learning instead. Azure Stack Hub, what's great here? Well, I was excited about the AKS feature, that AKS is available, so you have a transparent move to Azure if needed, because it's the same API. So if you're using Azure Stack on premises, on a boat, or in a hospital due to regulatory or data sovereignty requirements, here you get a more transparent move, and you can work with Azure Stack Hub in a connected mode or disconnected mode to Azure. And you have all the nice management tooling here in Azure Stack Hub for IaaS and PaaS. You can work with containers, VMs, Azure Marketplace, Web Apps, Azure Functions, Service Fabric, Kubernetes, and container services, even if you are on a big freighter out at sea. Besides Azure Stack Hub, we have another announcement about Azure Arc, which is a big announcement. Azure Arc means that you can have your on-premises data center or a third-party cloud vendor where you have hardware somewhere else or a cloud somewhere else, but you get a single pane of view in Azure. You have Azure as the control plane where you can manage services which you have on premises. So for instance, you can manage security, and you can also have Azure data services anywhere. You can also have Kubernetes with Azure Arc. So if you have your Kubernetes cluster on premises, you can manage everything from Azure, which is awesome. And Azure takes care of the scaling and patching and updates also. What more news do we have on the table? Well, Azure Machine Learning, this is my favorite area, of course. And responsible AI is our new big announcement, where we have actually tools to enforce responsible AI, which is most often principles, and now we have tools to enforce these principles. And we have a lot of customers with machine learning scenarios and models. And I'm going to talk about Scandinavian Airlines, which created 5 models in 6 months. Among them were actually sales forecasting and fraud detection, which we're seeing here. So responsible AI, first I want to talk more about this before I go into the customer use case. The AI principles we speak about most often are these 3. We speak about privacy, and here we have the tooling now with Microsoft Seal to enforce privacy, to encrypt data, to avoid data poisoning when training a model, and to have data encrypted at inference. And we also have transparency as one of the principles. We want to have AI transparent to open up the black box of AI. And here we have Interpret ML, which we have available in Azure Machine Learning Studio. So when you have your models here, you can also look at the Interpret ML tab to see what features are important, how did it came to its conclusion, and so forth. And fairness, we want AI to be fair, to treat every group of people the same. And with Fairline, which is open source, we have this also embedded in Azure Machine Learning Studio for you to be able to see if it's fair or not, and to be able to take actions on this. About privacy and Microsoft Seal, as I mentioned, this is all about to have your data private and to have your private predictions on encrypted data. And this is available on GitHub right now, open source, check it out. Interpret ML is another feature for transparency. And this is where we come into the customer use case. Scandinavian Airlines have a global airline industry problem with fraudulent claims of their loyalty points in their loyalty programs. many airlines has a loyalty program, and here they have fraud. And SAS, they created a solution for this with Azure Machine Learning and AutoML and Interpret ML and MLOps, a full-blown solution which could identify frauds automatically, and they were able to identify 300% more frauds actually than earlier. So this is a great example of how they used both AutoML and Interpret ML. If you're going to accuse someone for fraud, you really need to know why to have good ground for it, right? And sometimes machine learning models can be like a black box, and Interpret ML opens up this black box. So you can see how the model comes to its conclusion. And I have a video where SAS explains this much better themselves.
Scandinavian Airlines is the oldest airline in the Nordics. We roughly had 800 departures per day, flying roughly 30 million passengers per year. We saw an opportunity to use AI and machine learning across the company to drive efficiency and improve customer experience. When you run a loyalty program within an airline, there is a lot of fraud because our loyalty points is seen as valuable to people.
So we need an AI that can respond in real time to block these accounts or block the transactions and see the pattern. Azure Machine Learning and its capability to interpret data helped us to increase the transparency in our models. We saw that we could remove a lot of them due to them not really being relevant. In one of the models, we were basically close to predict 100% certainty if a transaction or activity was fraud and/or suspicious. For us, I would say responsible AI means a lot. We need to trust the AI. And if we were to find ourselves in a situation where the wrong member is flagged and accused, that would be devastating.
Responsible ML capabilities with Azure Machine Learning helps us understand the models and make sure models are built to be accurate, fair, and secure.
And I think the explainability features available here certainly help us to see why a member, transaction, etc. is being flagged. And that creates that needed trust and bond between our staff and the AI.
Our developers have a lot of freedom within Azure Machine Learning. It's very easy for data teams to use the no-code drag-and-drop designer before moving the projects to other environments.
Azure Machine Learning and MLOps has helped us improve efficiency through automatic retraining of our models. It has given us the ability to do controlled rollouts, continuous integration, continuous development.
We use Azure Machine Learning to solve real business problems without worrying about scale. We can trust our data and models and focus directly on gaining value from the technology.
It's a great example of how we can utilize Azure Machine Learning and Interpret ML to open up the black box. What they also did at SAS, they mentioned that they were able to reduce features that wasn't that important for the model. So they reduced actually 54 features to 31. And this means that we got a benefits of a simplified model with less maintenance also and optimized performance. It also saves costs since less data to process. But most important, we get full transparency and no black box. So that's what I wanted to talk about. But there are, of course, more things that you can check out. I just wanted to end with that and say thanks for tuning in, and let's connect on LinkedIn.
Welcome everybody to Data Innovation Summit 2020. Our next session here, I have with me Antti from Solita. Please introduce yourself.
Hey, nice to meet you all. My name is Antti Loukiala. I work at the Solita as a tech lead for data platforms. Been working for 10 years in the world of BI, and for past 4 years as a data architect, data engineer, working on these data platforms.
Cool. Well, it's pretty neat. This past year, 2020, has given a lot of companies the opportunity to really focus inwards, given the new circumstances, and rethink what their strategy is for big data, advanced analytics, and AI. Can you tell me a little bit how 2020 has changed things for Solita, if at all?
Well, yeah, of course, it has been a big change. But like all the companies, we're working from home and try to be safe. And I find that there's a lot of positives out of this. When it comes to working with the customers, I feel that there's a really good sort of culture going along where we are able to actually work from abroad, and all these new technologies are really helping to do that. So I would say that it's not changed a lot, but of course it changes everything.
Right. All right. Let's dive straight into it. I'd like to hear your thoughts a little bit on what is critical if you want to be successful with becoming data-driven from a technical perspective.
Yeah, that's a very good question. I'm gonna dodge it a bit. So, you know, we have worked with a lot of companies on these data-related projects, and we sort of come out with this kind of abstraction out of them that it actually is, to become a data-driven, it touches on a lot of the things at the company. We have developed this data-driven puzzle, which is basically 9 pieces that you can sort of take a look at it. How well are you prepared for it? Where you should focus on, and how to sort of uplift your data-drivenness. So I'm not going to go through those nine steps. We have some good material on it, but if you look at it a bit from a wider range, you can really see that it touches on everything. So it touches on your culture, of course, your core business, your leaderships. You have to see data as an asset, and of course, technology is really key part of it. So I would say that if you have all those 9 pieces in place, then the tech becomes easy, and that's what we like to say. That the culture is the hard part, the tech is the easy one.
I think a lot of people, you know, they say that the tech is easy, but it's only easy because a lot of tech people have a can-do attitude. But it helps to convince people by describing in practice how we would solve things in tech. Can you tell me a little bit about what an actual modern architecture in tech consists of for becoming data-driven?
Yeah, sure. So as mentioned, working on this project, we have also discovered that, well, in building a data platform, you have this kind of architecture that comes out of it. You tend to do similar things all the time. And what you're actually after with the platforms is that you want to create valuable interactions between data producers and data consumers. And the data platform is there to help to do that. So it's actually, of course, the data is somewhere. So the data is in applications. It's all over the company. Those applications are owned by different domains. So for example, HR, manufacturing, what have you. But then other domains are actually, they want to get hands on that data so that they can start building their business cases around that core business that you have. So then the data platform becomes steps in there, that how do you actually connect these two? And of course, there's typically, you have data ingestion, you have data storage, data wrangling, data publishing, and data channels of how you connect them to the others. So these things happen all the time. But then there's, of course, each data platform you can't have a generic one in order to drive really through, but you build it for your cases. And out of these sort of technical things, you have different things around it. You have cloud governance, you have data governance, you have enterprise architecture. It has to align with that as well. And of course, the modern, like a data DevOps, data ops ways of doing it. So out of all of these, you sort of have this data platform architecture. And we have some good material around that too. So I won't go too deep into that. You can check it out from our virtual stand and so on.
I really like the idea of contextualizing it as a producer of data and a consumer of data. And you can think of it both in terms of a business producer and a business consumer, or from a very technical perspective. But let's put a pin in that for one moment. And can you tell me a little bit more about one thing you just said now that piqued my interest, which is that you can't have a general purpose data platform. So now for the past 10 years, we've been hearing from these data lake companies and data platform companies, you know, the incumbents, that there is a sort of single platform that you can use that serves all big data and advanced analytics needs. Is that what you're referring to, or what are your thoughts?
Yeah, I think it's so the data platform, of course, consists of different parts. So you have typically a data lake or the data storage, a data warehouse there. And of course, there's vendors that offer a really good solutions to those. But then it's about your core business. I'm going back to that again. So you want to create value out of that data. You want to have your decisions based on the data. And of course, the decisions in the business is yours. It's specifically to you. So therefore, you have to mix and match a lot of different vendors, or you build it yourself in order to come up with the best solution to your need. So I really like this saying that you should choose the best tool for the job. And at times when you start mixing these, of course, the possibilities are endless, the way you can mix and match these. So it's I would say yes and no. There's a lot of really good vendors that can do a lot, but then it's about combining to create that whole.
What are the typical things that sort of need to be added to these types of systems? You know, you can buy an appliance from one of the incumbent blue chip companies, or you can buy one of the, you know, popular data lake solutions. What beyond those is usually a tool that leads to success? So like what kind of things do people usually forget to incorporate into their modern data platform initiatives?
Yeah, well, I think, of course, the data lake, the data storage is kind of key, because you have to have it somewhere in order to start distributing it. But then we want to democratize data. So we want to create those value creating interactions. But in order those to happen, you have to discover the data. And well, first you have to store it, make it standardized, easy read, add some metadata to it so people understand where it's coming from, what does it mean. So out of those, actually, what I feel that it's one of those things that might be good to be in place before you start doing anything, and it's a data catalog. Because once you have a data catalog, then you can sort of pinpoint everyone, like go there you can discover what kind of data we have. And that starts to create that data democratization, because then people get to see what kind of data assets we have. Data starts to become an asset. And we start to focus on those business cases instead of wrangling with the data.
Right. What about development and developers? A lot of these tools are very centered on the usage of the data, you know, the automatic processing. And then you have sort of a team of subject matter experts that are continuously developing. And I've gotten the sense that sometimes you end up with these two islands. This hack and slash set of tools with modern languages, modern libraries, and then sort of the enterprise half. And then it becomes a big job to sort of translate these proof of concepts or these jobs that they've done in the play environment, if you will, and put them into the enterprise environment. Do you see them as staying separate, or should they be merged together?
I think like if we think about the world of data and what have you, it is lacking some years behind development, like DevOps, let's say. And I think a lot of these things have been solved in the world of DevOps. So in that sense, I feel that we have to sort of, in the world of data, and especially in the world of machine learning and artificial intelligence, which is maybe lacking even a bit more behind, we have to take a jump. And what I find really cool and nice is that the DevOps has solved a lot of the issues. We just have to understand how to translate those into the world of data. And therefore you have these kind of terms like data ops and ML ops and AI ops and what have you, to sort of pick up the speed. And I think it is that you have to have it in, of course, proof of concept or something. You do them, or you might throw them in the trash and then understand that, okay, this concept actually works, and then you start building it. But you have to make them, you have to automate everything. And I find that we have this tool called Agile Data Engine, which is exactly helping to do this. So it is actually a tool that helps you to build, deploy, and maintain and run cloud-based data warehouses. And it actually sort of incorporates everything. So it kind of, I feel that it kind of takes that, that couple year difference that you have in the world of data and development, and it starts to, catch up so that you can actually apply the best practices of DevOps, which has been around for a long time, and apply those to the world of data, so that you can actually build enterprise-ready solutions sort of right off the bat.
Let me ask you, is there a difference between the way, say, web app developers do operations and the way advanced analytics practitioners do operations? Is it as easy as just taking the tools and techniques that web developers have been using and applying them to data science, or does it take something more specific to data science and advanced analytics?
Yeah, that's a good question. Of course, if you go abstract enough, we're doing the same thing. We're doing algorithms, and we're doing producing code. But that there is, of course, certain differences, and you have to take those into consideration. So when you're doing, for example, ML ops, you train the model, you deploy the model, you test the model, and then you want to reiterate the model. So it's not one-to-one. But I think going to the fundamentals of it, we shouldn't make excuses why we don't do the fundamentals of it.
Right. Okay. So it shouldn't be an excuse, but it's worth looking towards the experts to find the right way of doing ML ops in specific.
Yes, exactly. And the same applies for the data ops. And I think those things, those terms hold a lot of good behind them. So data ops and ML ops, and that's what they're after. You want to automate things, you want to make them modern, and you want to make them work so that they're easy to operate.
Is this a stumbling block that customers typically get stuck on in its entirety? Or do you find that there's one stage? You mentioned that in your methodology, you have 9 different steps. Is it that one step is extremely difficult and the rest of them sort of lend themselves more easily? Or do you feel that the concept of operations when it comes to advanced analytics as a whole is just sort of foreign? Which of the two is it? And if it's more detailed, which one?
Yeah, I would go back to, of course, the machine learning. It's the background where it's coming from. It's not from the software development. It might come from math or statistics, and therefore the background that you have on the people doing it's a difference. So that creates not a gap, but a different mindset, let's say. So if you're specialized in development, the way you do that, it's different. But those 9 steps, I would say the hardest part is the culture. So it's you can gather the data and you can make it available and in a nice, clean way and really high quality, and you have machine learning in there, all the machine learning and how to make it operational, everything's in place. But it's not until your company has the culture that we wanna use the data, we wanna base our decisions on data, we wanna utilize the data. It's not until that's in place that you can truly become data driven and start using that data. Otherwise, it's just tech.
What is the right way to catalyze that? Because we've been speaking today in some of our other sessions about having evangelists that speak for a certain use case, having executive buy-in, that the people that are close to the ground that do operations, that they're the most in touch with what provides the most value. Where do you catalyze this type of culture change? And which one actually gets the desired effect?
Yeah, I think I've seen cases where this sort of comes from the grassroots, so that someone discovers something really cool and it sort of picks up speed, and it's truly a data driven, and that sort of creates this kind of how do you say envy of others, and they want to sort of tap into it as well. And that happens, but of course, the more core you are to the business, so all the way from strategy to from vision, from mission. So if the data is part of that, then it sort of triples down in the right way. And the leaders have, of course, the leaderships is in very important aspect. So I mean, it's kind of the bigger changes you do to the core business with the data, the higher the impact. The more you are on the outer rings, of course, the impact might not be as big.
Speaking of willingness to change, that does require a certain daring. And it's easier to do something when you've seen other people do it before you. And all the vendors that are running around now, they're talking about these use cases that you hear over and over. You know, reducing churn, predictive maintenance, and all that kind of stuff. Of the cases that you at Solita work with, the ones that are successful, are they the bread and butter, the ones that you hear about all the time? Or are they very unique and specific to the business? And what I mean is, are they these typical chatbots or reducing churn cases, or are they more unique to the business?
Yeah, I would say that they range a lot. So because we're dealing with a lot of different customers. So manufacturing, telecommunications, retail, everything. So all of them have their own niche. Some of the things repeat within certain domains. If you say that, like telecommunications has a different vibe to it, and they seem to solve similar cases. But I would say that it is to the business, and it's kind of if your vision and your mission and your strategy is specific and you want to drive those things, then of course the applications that you build, the algorithms, the data discoveries happen in that field, and they become more specific. But of course, all of them have customers. The customer is the king, so that is an essential of many of the cases.
At what stage do you find that you're able to help the customer push through those changes? I was speaking with others before where they were saying that a lot of times customers come with an idea and then ask you to implement it. But at that stage, it might already be too late to do the right thing. Do customers often come to you with ready ideas, or do you start at the ideation phase?
That's a very good question. I think there's one thing to tap on is that in many cases the data and cloud, they are really nice match, because in the cloud you have the space, you can scale from 0 to almost infinity, and you have these ways of doing algorithms, machine learning, and it doesn't cost you too much. So it's a good way to test drive stuff. So in some cases it is that the customers are looking for a way to get started with the data journey. So they're looking for how to go to the cloud, how to move to the cloud, and what have you. But of course, there's other cases when they have sort of an idea, very good idea, that let's do the tech part. But then also what happens every now and then is that there is that idea that we have done all the research and we want to do this tech, but we sort of make the customer reevaluate them and do some service design on that topic. And usually those are very, very interesting and valuable, because that does not only give the customer a second opinion, but it might give more insight to it, and that insight is actually very helpful to building the tech. So then you actually get a better understanding of why it's being built, what's the customer actually after, and what we are trying to achieve. So we have this customer service, we'll call it a department, and they are exactly after this, sort of maybe reevaluate customers' ideas, or even help customers from scratch to find these new ideas and sort of apps, if you want to call them.
So when you meet a new customer, and I've found myself that sometimes you come to a customer and they have everything in the cloud. They say that they're open to trying, new technologies and that kind of thing. And I think, okay, this is going to be easier than not. Some customers don't have those prerequisites in place. What are the prerequisites that you find really enable you to get hit the ground running, so to speak? Technical prerequisites, and maybe mind prerequisites.
Yeah, I would say that one thing is working agile, and I mean, if you're really in an agile way of working and you're willing to fail fast and you're sort of willing to test and work iteratively towards the goal, I think that helps a lot. So if you truly are a agile, then you have a really good base to start doing stuff. Of course, if we think about from the tech perspective, having a base set of skills it's really valuable. So meaning that if you're in a cloud, you have own expertise that understands the cloud and can operate it. If you have different applications, you have expertise on those and working from there. So I think a basic skill set helps a lot, but I think agile ways of working will get you even faster there.
All right, so you're talking about having these prerequisites in place when it comes to technical prerequisites and mindset prerequisites. And a topic that's come up with a lot of the people we've been speaking to during this conference has been that it's been very tough to get a hold of the right technical skills, technical competences, whether that's in data engineering or mathematics or whatever, really, even the meta categories of overseeing these types of projects in their entirety. What functions do consultancies have in adding value here? Where can they add the most value? Is it really in the specific technical competencies, or is it in the broad strokes? Where do you see yourselves really filling the best function for companies? And is there a difference between small and big companies in that respect?
Yeah, I think you have of course like a domain expertise, which is what is in the company. So then typically when we come in to help is what we call is to get started on a data journey or a cloud journey. And of course, to give a different perspective, as I mentioned before, on the service design. So what are we actually building? Let's have a second look at it, or maybe help you do the service design so that it actually matches exactly what you're after. So I would say that, and how we see at Solita is that we want to. It's not that we want to own the project. It is that we want the company to drive. We want to make impact that lasts. That's our statement. And that means that after we leave, everything should be rolling. It's not depending on us. And therefore, I think it is important to have that consultants can come in and educate the people and grow that skill set within the company so that they can become what they're after to become, and help on that journey. Because in many cases you have like cloud, it can be quite a bit of tackle to sort of start from scratch, but you might have a lot of very good competencies within the company that just need pushing in the right direction to get going. And when it comes to big and small companies, of course, in the bigger companies, you might have more resources behind it. So I would say that there isn't too much of a difference. But of course, the bigger are big.
I think there's an issue of a chicken and egg situation where it's very hard to verbalize what your needs are when you don't already have the competence in-house. What kind of specific skills can consultancies bring that they then would transfer to the company that's just getting started with advanced analytics?
Yeah, that's a good one. So usually, as mentioned earlier, the companies have their domain knowledge, but they might be lacking some heavy machine learning or artificial intelligence skills, or it might be data modeling or something like that. So what we can bring then is sort of a competency to sort of connect with the domain knowledge and then get you kickstarted on it. And for example, if you go to like machine learning ops, ML ops and such, get you that in place. So then you get going and you can pick it up from there. And of course, like the HL data engine that we have customers who are using it fully without us, of course. That's the whole point of it. And so we have a SWAT team that can come in, help you get started, install everything, show you around, show you bits and pieces, and then off you go. You can pick it up from there. So I think it's always like it's a good point that in many cases it is that, should I first invest in getting the skills in-house, or should I get a consultant to get it going? I think the best scenarios are the ones that you have consultants, but you have a pair on your side who's working with it. So then it is sort of a team that's formed, the team that is part consultants, part from in-house, and off from there it goes.
I think it's very easy to dismiss the soft skills because it's hard to put your finger on it. You know, it's not easy to actually make it concrete what it is that this communication between the techie people and the business people actually involves. And tech people tend to be problem solvers. Yeah, we can probably figure this out. So that value that's there, can you give a nice example of that type of communication and where it really has been pivotal? Maybe an example of something you've done in the past year where that's happened.
Yeah, it actually goes a bit broader, but one of our customers came to us saying that, you know, we solved this idea and we asked our customers, and this is what they want, and we want to now build a technical solution to it. And we were, of course, interested in building it, but what we actually said was that, you know, let's take a moment and do a bit of reevaluation. You know, let's do a sanity check on it. And this went to the service design sort of side of things. And what they did was that they went through the idea, how the idea was formed. They did some more customer reviews, and actually the end result was quite different. So the assumption that the customer had was actually quite wrong. Unfortunately, I can't go deeper into it, but it was so that the customer was assuming that their customer is after a better customer service, when it actually was more about faster replies, not as a better and nicer voice at the end of the phone. And that actually changed the whole technical application. And it was done at such an early phase that the cost of changing it wasn't too bad.
And does that mean that is it necessary? Because I can imagine that companies are apprehensive of letting outsiders into their business reality and sort of saying, well, we know our business, you just help us with the tech part. Would you say it's a necessity for the people that are implementing advanced analytics to be privy to the business reality? Or can you work without that?
Yeah, I think you have to be part of the business and understand it in sort of order to actually create the value. Applying just math, it gets you really bad results. There was actually this one customer case where the consultants came in, the customer gave all the data to the consultants. The consultant said that this is the end result, this is how you fix everything. But it was so that the two values that were used to predict the actual result was so that the one value was the set value and another one was the actual value that followed it. So they actually, there wasn't any discovery made. So applying math to data, applying machine learning to data without understanding the problem deeply, it can be quite hard to come up with anything reasonable.
Right. So it does make sense to let in consultants that have an experience of doing it many, many times over and seeing both the successes and the failures and knowing what to look out for in any case.
Yes, and I think it's also, of course, coming from a statistical background or a machine learning background to a specific domain, the domain can be very, very complex or simple, but it is the idea that you have to get into it. So you need the pair, the one from the customer side and one from the consultancy, and together they can come up with a solution. And of course, with the time, both of them develop skills from one another, and then they can even develop better and better solutions. And also, it's good to keep in mind that at sometimes these kind of black box solutions, if you have in machine learning, might not actually be the best solutions. So even though they might produce the best result, It is the simpler and more understandable formula, linear or what have you, that actually explains the phenomenon better and knows how to react to it. So you might want to start with that and then get into more complex when you can trust them more and more.
Makes sense. All right, Antti, thank you very much for joining us today. It's been a really good conversation, and I hope the audience took some notes from what we went through now. I will be seeing you in the next session. Thank you. I will see you tomorrow. A lot of interesting people here. Welcome back, everyone. This is Robert reporting to you from the Data Octagon at Data Innovation Summit 2020. So day one is over, and we've had a lot of interesting people here speaking in the Data Octagon. The topics that have been really top of mind across all of these conversations have been that data is quite central and that you need good data in to get good data out. I think it's a truism that a lot of people subscribe to for sure, but it helps to really make it practical. Many of the tooling requirements to make that happen are now available in commoditized form. We've seen vendors that have databases that handle data in and data out, and we have vendors that are focused very much on the cloud and a swath of tools that they've been able to sew together to enable this. But really, the point has been that it's quite central to catalog your capabilities, your data, your metadata, and everything that goes into machine learning in order to make use of it in an efficient way. So another topic that really broaches onto that and that people have been talking about that touches more on the human aspect of it has to do with the planning. You need to have a plan for all of this to begin with, and the technology is there to support you. But take the time really to plan what your strategy is going to be with AI. It's better to plan once, or plan many times, and do once than the other way around. That's probably one of the key takeaways from all the sessions today. Tune in again tomorrow for another swath of super interesting presentations on the same topics. I will see you tomorrow.